This is CS50, and this is week 7, the week here of Halloween. Indeed, special thanks to CS50's own Valerie and her mom for having created this very festive scenery, and all past ones as well. Today, we pick up where we left off last time, which, recall, we introduced Python. And that was our big transition from C, where suddenly things started to look new again, probably, syntactically, but also probably things hopefully started to feel easier. Well, with that said, like problem set 6 certainly added some challenges and you did some new things, but hopefully you've begun to appreciate that with Python, just a lot more stuff is easier to do. You get more out of the box with the language itself, and that's going to be so useful over the coming weeks as we transition further to introducing something called databases today, web programming next week and the week after, so that by term's end, and perhaps even for your final project, you really are building something from scratch using all of these various tools somehow together. So before we do that, though, today, let's consider what we weren't really able to do last week, which was actually create and store data ourselves. Right? In Python, we've played around with the CSV, comma, separated values library. And you've been able to read in CSVs from disk, so to speak, that is, from files in your programming environment. But we haven't necessarily started saving data, persisting data ourselves. And that's a huge limitation because pretty much all of the examples we've done thus far, with a couple of exceptions, have involved my providing input at the keyboard or even vocally, but then nothing happens to it. It disappears the moment the program quits because it was only being stored in memory. But today, we'll start to focus all the more on storing things on disk, that is, storing things in files and folders so that you can actually write programs that remember what it is the human did last time, and ultimately you can actually make mobile or web apps that actually begin to grow and grow and grow their data sets, as might happen if you get more and more users, for instance, on a website. To play then with this new capability of being able to write files, let's go ahead and just collect some data. In fact, those of you here in person, if you want to pull up this URL on your phone or laptop, that's going to lead you to a Google form. And that Google form is going to ask you in just a moment for really just your favorite TV show. And it's going to ask you to categorize it according to its genre, like comedy or drama or action or musical or something like that. And this is useful because if you've ever used a Google form before, or Microsoft's equivalent with Office 365, it's a really useful mechanism of just collecting data from users and then ultimately putting it into a spreadsheet form. So this is a screenshot of the form that those of you here in person or tuning in on Zoom are currently filling out. It's asking only 2 questions. What's the title of your favorite TV show? And what are one or more genres into which your TV show falls? And I'll go ahead and pivot now to the view that I'll be able to see as the person who created this form, which is quite simply a Google spreadsheet. Google Forms has this nice feature, if you've ever noticed, that allows you to export your data to a Google spreadsheet. And then from there, we can actually grab the file and download it to my own Mac or your own PC so that we can actually play around with the data that's come in. So in fact, let me go ahead and slide over to the live Google spreadsheet. And you'll see probably a whole bunch of familiar TV shows here, all coming in. And if we keep scrolling and scrolling and scrolling, only 46, 47, there we go, up to 50 plus already. If you need that URL again here, if you're just tuning in, you can go to this URL here. And in just a moment, we'll have a bunch of data with which we can start to experiment. I'll give you a moment or so there. All right. Let me hang in there a little longer. OK, we've got over 100 submissions. Good. Good. Even more coming in now. And we can see them coming in live here. Let me switch back to the spreadsheet. The list is growing and growing and growing. And in just a moment, let me give Carter a moment to help me export it in real time. Carter, just give me a heads up when it's reasonable for me to download this file. All right, and I'll begin to do this very slowly. So I'm going to go up to the File menu. If you've never done this before, download. You can download a whole bunch of formats, one in Excel. But more simply, and the one we'll start to play with here, is comma-separated values. So CSV files, we used this past week. Why are they useful? Now that you've played with them or used them in past real world, like what's the utility of a CSV file versus something like Excel, for instance? Why CSV in the first place? Any instincts? Yeah. OK, so storage is compelling. A simple text file with ASCII or Unicode text is probably pretty small. I like that. Other thoughts? Yeah, well said. It's just a simple text format, but using conventions like commas, you can represent the idea of columns. Using new lines, \n's, invisibly at the end of your lines, you can create the idea of rows. So it's a very simple way of implementing what we might call a flat file database. It's a way of storing data in a flat, that is very simple file that's just pure ASCII or Unicode text. And more compellingly, I dare say, is that with a CSV file, it's completely portable. Something's portable in the world of computing if it means you can use it on a Mac or a PC running this operating system or this other one. And portability is nice because if I were to download an Excel file, there'd be a whole bunch of people in this room and online who couldn't download it because they haven't bought Microsoft Excel or installed it. Or if they have a Mac, they might not, or if it's a .numbers file in the Mac world, a PC user might not be able to download it. So a CSV is indeed very portable. So I'm going to go ahead and download, quite simply, the CSV version of this file. That's going to put it onto my own Mac's downloads folder. And let me go ahead here, and in just a moment, let me just simplify the name because it actually downloads it at a pretty large name. And give me just one moment here. And you'll see that indeed on my Mac, I have a file called favorites.csv. I shortened the name real quick. And now what I'm going to do is go over to VS Code. And in VS Code, I'm going to open my File Explorer. And if I minimize my window here for a moment, a handy feature of VS Code is that you can just drag and drop a file, for instance, into your Explorer. And voila, it's going to automatically upload it for you. So let me go ahead and full screen here, close my Explorer, temporarily close my terminal window. And you'll see here a CSV file, favorites.csv. And the first row, by convention, has whatever the columns were in Google Spreadsheets or Office 365, in Excel Online, timestamp, comma, title, comma, genres. Then we have timestamps, which indicates when people started submitting. Looks like a couple of people were super eager to get started an hour or two ago. And then you have the title next, after a comma. But there's kind of a curiosity after that. Sometimes I see the genre like comedy, comedy, comedy. But sometimes it's like crime, comma, drama, or action, comma, crime, comma, drama. And those things are quoted. And yet I didn't do any quotes. You probably didn't type any quotes. Where are those quotes coming from in the CSV file? Why are they there if we infer? Yeah. Yeah, so you have a kind of a corner case, if you will, because if you're using commas, as you described, to separate your data into what are effectively columns, well, you've kind of painted yourself into a corner if your actual data has commas in it itself. So what Google has done, what Microsoft does, what Apple does, is they quote any strings of text that themselves have commas, so that these are now sort of English grammatical commas, not CSV-specific commas. So it's a way of escaping your data, if you will. And escaping just means to call out a symbol in a special way so it's not misinterpreted as something else. All right, so this is all to say that we now have all of this data with which we can play in the form of what we'll start calling a flat file database. So suppose I wanted to now start manipulating this data, and I want to store it ultimately indeed in this CSV format. How can I actually start to read this data, maybe clean it up, maybe do some analytics on it, and actually figure out what's the most popular show among those who submitted here over the past few minutes? Well, let me go ahead and close this. Let me go ahead then and open up, for instance, just my terminal window. And let's code up a file called favorites.py. And let's go ahead and iteratively start simple by just opening up this file and printing out what's inside of it. So you might recall that we can do this by doing something like import CSV to give myself some CSV reading functionality. Then I can go ahead and do something like with open, the name of the file that I want to open, in read mode, quote unquote R means to read it, and then I can say as file or whatever other name for a variable to say that I want to open this file and essentially store some kind of reference to it in that variable called file. Then I can give myself a reader, and I can say csv.reader, passing in that file as input. And this is the magic of that library. It deals with the process of opening it, reading it, and giving you back something that you can just iterate over, like with a for loop. I do want to skip the first row. And recall that I can do this. Next reader is this little trick that just says ignore the first row, because the first one's special. It said timestamp, title, genres. That's not your data. That was mine. But this means now that I've skipped that first row, everything hereafter is going to be the title of a show that you all like. So let me do this. For row in the reader, let's go ahead and print out the title of the show each of you typed in. How do I get at the title of the show each of you typed in? It's somewhere inside of row. Row, recall, is a list. So what do I want to type next in order to get at the title of the current row? Just as a quick check here. What do I want to type to get at the title of the row? Keeping in mind, again, that it was timestamp, title, genres. Yeah. So row bracket 1 would give me the second column, 0 index. That is the one in the middle with the title. So this program isn't that interesting yet, but it's a quick and dirty way to figure out, all right, what's my data look like? Let me actually just do a little bit of a check here and see if it contains the data I think it does. Let me maximize my terminal window here. Let me run Python of favorites.py, hitting enter. And you'll see now a purely textual list of all of the shows you all seem to like here. But what's noteworthy about it? Specific shows aside, judgment aside as to people's TV tastes, like what's interesting or noteworthy about the data that might create some problems for us if we start to analyze this data and figure out what's the most popular, how many people like this or that? What do you think? Yeah. Yeah, there might be user errors or just sort of stylistic differences that give the appearance that one show is different from the other. For instance, here, let's see if I can see an example on the screen here. Yeah, so friends here is in all lowercase. Friends here is capitalized. No big deal. We can sort of mitigate that. But this is just a tiny example of where data in the real world can get messy fast. And that probably wasn't even a typo. It was just sort of just someone not caring as much to capitalize it. And that's fine. Your users are going to type what they're going to type. So let's see if we can't now begin to get at more specific data and maybe even clean some of this data up. Let me go back into my file called favorites.py here. And let's actually do something a little more user-friendly for me. Instead of a reader, recall that there was this dictionary reader that's just a little more user-friendly. And it means I can type in dictionary reader here, passing in the same file. But now when I iterate over this reader variable, what is each row? When using a dict reader instead of a reader, recall, and this is just a peculiarity of the CSV library, this gives me back not a list of cells, but what instead, which is marginally more user-friendly for me. Yeah? Yeah, I can now use open bracket, quotes, and the title, because what's coming back now is a dict object. That is a dictionary which has keys and values, the keys of which are the column headings, the values of which are the data I actually care about. So this is just marginally better because, one, it's just way more obvious to me, the author of this code, what it is I'm getting at. I mean, I don't remember what column the title was. Was it 0? Was it 1? Was it 2? That's something you're going to forget over time. And God forbid someone changes the data by just dragging and dropping the columns in Excel or Apple Numbers or Google Spreadsheets. That's going to break all of your numeric indices. And so a dictionary reader is arguably just better designed because it's more robust against changes and potential errors like that. Now, the effect of this change isn't going to be really any different. If I run Python of favorites.py, voila, I get all of the same results. But I've now not made any assumptions as to where each of the columns actually is numerically. All right, well, let's go ahead and now filter out some duplicates, because there's a lot of commonality among some of the shows here. So let's see if we can't filter out duplicates. If I'm reading a CSV file top to bottom, what intuitively might be the logic I want to implement to filter out duplicates? It's not going to be quite as simple as a simple function that does it for me. I'm going to have to build this. But logically, if you're reading a file from top to bottom, how might you go about, in Python or just any context, getting rid of duplicate values? Yeah, what do you think? Sure, I could use a list, and I could add each title to the list, but first check if I've put this into the list before. So let's try a little something like that. Let me go ahead and create a variable at the top of my program here. I'll call it titles, for instance, initialized to an empty list, open bracket, close bracket. And then inside of my loop here, instead of printing it out, let's start to make a decision. So if the current row's title is in the titles array, I don't want to, the titles list, I don't want to put it there. And actually, let me invert the logic so I'm doing something proactively. So if it's not the case that row bracket title is in titles, then go ahead and do something like titles dot append the current row's title. And recall that we saw dot append a week or so ago, where it just allows you to append to the current list. And then what can I do at the very end after I'm all done reading the whole file? Why don't I go ahead and say for title in titles, go ahead and print out the current title. So it's 2 loops now, and we can come back to the quality of that design. But let me go ahead here and rerun python of favorites.py. Let me increase the size of my terminal window so we can focus just on this and hit enter. And now I'm just skimming. I don't think I'm seeing duplicates, although I am seeing some near duplicates. For instance, there's friends again. And if we keep going and going and going and going, there's friends again. Oh, interesting. So that's curious that I seem to have multiple friends. And I have this one here too. So how might we clean this up further? I like your instincts, and it's a step closer to it. What are we going to have to do to really filter out those near duplicates? Any thoughts? Yeah, what are the common mistakes? To summarize, we could ignore the capitalization altogether and maybe just force everything to lowercase or everything to uppercase. Doesn't matter which, but let's just be consistent. And for those of you who might have accidentally or instinctively hit like the space bar at the beginning of your input or even at the end, we can strip that off too. Stripping white space is a common thing just to clean up user input. So let me go back into my code here, and let me go ahead and tweak the title a little bit. Let me say that the current title inside of this loop is not going to be just the current row's title, but let me go ahead and strip off from the left and the right implicitly any white space. If you read the documentation for the strip function, it does just that. It gets rid of white space to the left, white space to the right. And then if I want to force everything to maybe uppercase, I can just uppercase the entire string. And remember, what's handy about Python is you can chain some of these function calls together by just using dots again and again. And that just takes whatever just happened, like the white space got stripped off, then it additionally uppercases the whole thing as well. So now I'm going to check whether this specific title is in titles. And if not, I'm going to go ahead and append that title, massaged into this different format, if you will. So I'm throwing away some information, like I'm sacrificing all of the nuances of your grammar and input to the form itself, but at least I'm trying to canonicalize, that is, standardize what the data actually looks like. So let me go ahead and run python of favorites.py again and hit enter. Oh, and this is just user error. Maybe you haven't seen this before. This just looks like a mistake on my part. I meant to say not even uppercase. That's completely wrong. The function is called upper, now that I think of it. All right, let's go and increase the size of the terminal window again. Run python of favorites.py. And now, it's a little more overwhelming to look at because it's not sorted yet and it's all capitalized. But I don't think I'm seeing multiple friends, so to speak. There's one friends up here. And that's it. I'm back up at my prompt already. So we seem now to be filtering out duplicates. Now, before we dive in further and clean this up further than this, what else could we have done? Well, it turns out that in Python 2, you often do get a lot of functionality built into the language. And I'm kind of implementing myself the idea of a set. If you think back to mathematics, a set is typically something with a bunch of values that has duplicates filtered out. Recall that Python already has this for us. And we saw it really briefly when I whipped up the dictionary implementation a couple of weeks back. So I could actually define my titles to be a set instead of a list. And this would just modestly allow me to refine my code here such that I don't have to bother checking for duplicates anyway. I can instead just say something like titles.add the current title like this. Marginally better design if you know that a set exists, you're just getting more functionality out of this. All right, so let's clean the data up further. We've now gone ahead and fixed the problem of case sensitivity. We threw away white space in case someone had hit the space bar with some of the input. Let's go ahead now and sort these things by the titles themselves. So instead of just printing out the titles in the same order you all inputted them, but in filtering out duplicates as we go, let me go ahead and use another function in Python you might not have seen, which is literally called sorted, and will take care of the process of actually sorting titles for you. Let me go ahead and increase the font size of my terminal, run python of favorites.py, and hit enter. And now you can really see how many of these shows start with the word the or do not. Now it's a little easier to wrap our minds around just because it's at least sorted alphabetically. But now you can really see some of the differences in people's inputs. So far, so good. But a few of you decided to stylize avatar in 3 different ways here. Brooklyn 99, a couple of different ways here. And I think if we keep going, we'll see further and further variances that we did not fix by focusing on white space and capitalization alone. So already here, this is only, what, 100 plus, 200 rows? Already real-world data starts to get messy quickly, and that might not bode well when we actually want to keep around real data from real users. You can imagine an actual website or a mobile application dealing with this kind of thing on scale. Well, let's go ahead and do this. Let's actually figure out the popularity of these various shows by now iterating over my data and keeping track of how many of you inputted a given title. We're going to ignore the problems like Brooklyn Nine-Nine and the Avatar, Avatar, where there was things that were different beyond just white space and capitalization. But let's go ahead and keep track of now how many of you inputted each of these titles. So how can I do this? I'm still going to take this approach of iterating over the CSV file from top to bottom. We've used a couple of data structures thus far, a list to keep track of titles or a set to keep track of titles. But what if I now want to keep around a little more information? For each title, I want to keep around how many times I've seen it before. I'm not doing that yet. I'm throwing away the total number of times I see these shows. How could I start to keep that around? We could use a dictionary. And how? Elaborate on that. Perfect. Really good instincts. Using a dictionary, insofar as it lets us store keys and values, that is, associate something with something else. This is why a dictionary, or hash tables more generally, are such a useful, practical data structure, because they just let you remember stuff in some kind of structured way. So if the keys are going to be the titles I've seen, the values could be the number of times I've seen each of those titles. And so it's kind of like just having a two-column table on paper. For instance, if I were going to do this on a piece of paper, I might just have two columns here, where maybe this is the title that I've seen, and this is the count over here. This is, in effect, a dictionary in Python. It's two columns, keys on the left, values on the right. And this, if I can implement in code, will actually allow me to store this data and then maybe do some simple arithmetic to figure out which is the most popular. So let's do this. Let me go ahead and change my titles to not be a list, not be a set. Let's have it be a dictionary instead, either doing this or, more succinctly, two curly braces that are empty gives me an empty dictionary automatically. What do I now want to do? I think most of my code can stay the same. But down here, I don't want to just blindly add titles to the data structure. I somehow need to keep track of the count. And unfortunately, if I just do this, let's do titles, bracket title, plus equals 1. This is a reasonable first attempt at this, because what am I doing? If titles is a dictionary, and I want to look up the current title therein, the syntax for that, like before, is titles bracket and then the key you want to use to index into the dictionary. It's not a number in this case. It's an actual word, a title. And you're just going to increment it by 1. And then eventually, I'll come back and finish my second loop and do things in terms of the order. But for now, let's just keep track of the total counts. Let me go ahead and increase my terminal window. Let me do python of favorites.py and hit enter. And How I Met Your Mother is giving me a key error. What does that mean? And why am I seeing this? And in fact, just to give a little bit of a breadcrumb here, let me zoom out here. Let me open up the CSV file again real quickly. And wow, we didn't even get past the second row in the file or the first show in the file. Notice that How I Met Your Mother, somewhat lowercase, is the very first show in therein. What's your instinct for why this is happening? I don't have a starting point, right? I'm adding 1 to what? Like I'm blindly indexing into the dictionary using a key, How I Met Your Mother, that doesn't yet exist in the dictionary. And so Python throws what's called a key error because the key you're trying to use just doesn't exist yet. So logically, how could we fix this? We're close. We got like half of the problem solved, but I'm not handling the obvious now case of nothing being there. Yeah. Creating the counter itself. So maybe I could do something like this. Let me close my terminal window and let me ask a question first. If the current title is in the dictionary already, if title in titles, that's going to give me a true false answer, it turns out. Then I can safely say titles bracket title plus equals 1. And recall, this is just shorthand notation for the same thing is in C, title plus 1. Whoops, typo, don't do that. That's the same thing as this, but it's a little more succinct just to say plus equals 1. Else, if it's logically not the case that the current title is in the titles dictionary, then I probably want to say titles bracket title equals, feel free to just shout it out, 0. I just have to put some value there so that the key itself is also there. All right, so now that I've got this going on, let me go ahead and undo my sorting temporarily. And now let me go ahead and do this. I can, as a quick check, let me go ahead and just run the code as is, Python of favorites.py. I'm back in business. It's printing correctly, no key errors, but it's not sorted. And I'm not seeing any of the counts. Let me just quickly add the counts. And there's a couple of ways I could do this. I could say print out the title, and then maybe let's do something like, how about just comma, titles, bracket, title. So I'm going to print two things at once, both the current title in the dictionary and whatever its value is by indexing into it. Let me increase my terminal window. Let me run Python of favorites.py, enter. And OK, None of you said a whole lot of TV shows, it seems. What's the logical error here? What did I do wrong if I look back at my code here? Yeah, why so many zeros? Exactly. To summarize, I initialized the count to 0 the first time I saw it, but I should have initialized it at least to 1 because I just saw it, or I should change my code a bit. So for instance, if I go back in here, the simplest fix is probably to initialize to 1, because on this iteration of the loop, obviously, I'm seeing this title for the very first time. Or I could change my logic a little bit. I could do something like this instead. If the current title is not in titles, then I could initialize it to 0. And then I could get rid of the else and now blindly index into the titles dictionary, because now on line 11, I can trust that lines 9 and 10 took care of the initialization for me if need be. Which one is better? I don't know. This one's a little nicer maybe because it's one line fewer. But I think both approaches are perfectly reasonable and well designed. But the key thing, no pun intended, is that we have to make sure the key exists before we presume to actually increment. Oh, this is wrong. This is incorrect code. What did I do wrong? OK, yes, there we go. So otherwise, everyone would have liked this show once. And no matter how many people said the same thing, now the code is as it should be. So let me go ahead and open up my terminal window again. Let me run Python of favorites.py. And now we see more reasonable counts. Some of the shows weren't that popular. There's just 1s and maybe 2s. But I bet if we sort these things, we can start to see a little more detail. So how else can we do this? Well, it turns out when dealing with a dictionary like this, let's go ahead and just sort the titles themselves. So let's reintroduce the sorted function as I did before, but no other changes. Let me go ahead now and run Python of favorites.py. Now it's just a little easier to wrap your mind around it because at least it's alphabetical, but it's not sorted by value. It's sorted by key. But sure enough, if we scroll down, there's something down here, for instance, like, let's see, The Office. That's definitely going to be a contender for most popular, 15 responses. But let's see what's actually going to bubble up to the top. Unfortunately, the sorted function only sorts dictionaries by keys by default, not by values. But it turns out in Python, if you read the documentation for the sorted function, you can actually pass in other arguments that tell it how to sort things. For instance, if I want to do things in reverse order, I can add a second parameter to the sorted function called reverse. And it's a named parameter. You literally say reverse equals true so that the position of it in the comma-separated list doesn't matter. If I now rerun this after increasing my terminal window, you'll see now that it's in the opposite order. Now adventure and with an E is at the bottom of the output instead of the top. How can I tell it to sort by a different part by values instead of by key? Well, let's go ahead and do this. Let me go ahead and define a function. I'm just going to call it f to keep things simple. And this f function is going to take a title as input. And given a given title, it's going to return the value of that title. So actually, maybe a better name for this would be getValue. Or we could come up with something else as well. The purpose of the getValue function, to be clear, is to take as input a title and then return the corresponding value. Why is this useful? Well, it turns out that the sorted function in Python, according to its documentation, also takes a key parameter where you can pass in, crazy enough, the name of a function that it will use in order to determine what it should sort by the key or by the value, or in other cases, even other types of data as well. So there's a curiosity here, though, that's very deliberate. Key is the name of the parameter, just like reverse was the name of this other parameter. The value of it, though, is not a function call. It's a function name. Notice I am not doing this, no parentheses. I'm instead passing in getValue, the function I wrote, by its name. And this is a feature of Python and certain other languages. Just like variables, you can actually pass whole functions around so that they can be called for you later on by someone else. So what this means is that the sorted function written by Python, they didn't know what you're going to want to sort by today. But if you provide them with a function called getValue or anything else, now their sorted function will use that function to determine, OK, if you don't want to sort by the key of the dictionary, what do you want to sort by? This is going to tell it to sort by the value, by returning the specific value we care about. So let me go ahead now and rerun this after increasing my terminal. Python of favorites.py, enter. Here we have now an example of all of the titles you all typed in, albeit forced to uppercase and with any white space thrown out. And now The Office is an easy win over Friends versus Community versus Game of Thrones, Breaking Bad, and then a lot of variants thereafter. So there's a lot of steps to go through. Like this, isn't that bad once you've done it once and you know what these functions are and you know that these parameters exist. But it's a lot of work. I mean, that's 17 lines of code just to analyze a CSV file that you all created by way of those Google Forms submissions. But it took me a lot of work just to get simple answers out of it. And indeed, that's going to be among the goals for today ultimately is how can we just make this easier? Right? It's one thing to learn new things in Python, but if we can avoid writing code or this much code, that's going to be a good thing. And so one other technique we can introduce here that does allow us to write a little less code is we can actually get rid of this function. It turns out in Python, if you just need to make a function, but it's going to be used and then essentially thrown away. It's not something you're going to be reusing in multiple places. It's not like a library function that you want to keep around. You can actually just do this. You can change the value of this key parameter to be what's called a lambda function, which is a fancy way of saying a function that technically has no name. It's an anonymous function. Why does it have no name? Well, it's kind of stupid that I invented this name on line 13. I used it on line 16, and then I never again used it. Right? If there's only being used in one place, why bother giving it a name at all? So if you instead in Python say lambda and then type out the name of the parameter you want this anonymous function to take, you can then say, go ahead and return this value. Now, notice the inconsistencies here. When you use this special lambda keyword that says, hey, Python, give me an anonymous function, a function with no name. It then says, Python, this anonymous function will take one parameter. Notice there's no parentheses, and that's deliberate if confusing. It just tightens things up a little bit. Notice that there's no return keyword, which similarly tightens things up a bit, albeit inconsistently. But this line of code I've just highlighted is actually identical in functionality to this. But it throws away the word def, it throws away the word getValue, it throws away the parentheses, and it throws away the return keyword just to tighten things up. And it's well suited for a problem like this, where I just want to pass in a tiny little function that does something useful, but it's not something I'm going to reuse. It doesn't need multiple lines to take up space. It's just a nice, elegant one-liner. That's all a lambda function does. It allows you to create an anonymous function right then and there. And then the function you're passing it to, like sorted, will use it as before. Indeed, if I run Python of favorites.py after growing my terminal window, the result is exactly the same. And we see at the bottom here all of those small results. Are any questions then on this syntax, on these ideas? The goal here has been to write a Python program that just starts to analyze or clean up data like this. Yeah? Could you use the lambda if it's just returning immediately? It's really meant for one line of code generally. So you don't use the return keyword. You just say what it is you want to return. Good question. Could you do more in that one line if it's got to be a more involved algorithm? Yes, but you would just ultimately return the value in question. In short, if it's getting it all sophisticated, you don't use the lambda function in Python. You go ahead and actually just define a name for it, even if it's a one-off name. JavaScript, another language we'll look at in a few weeks, makes heavier use, I dare say, of lambda functions. And those can actually be multiple lines. But Python does not support that instinct. All right, so let's go ahead and do one other thing. Office was clearly popping out of the code here quite a bit. Let's go ahead and write a slightly different program that maybe just focuses on the office for the moment. Just focuses on the office. So let me go ahead and throw most of this code away up until this point when I'm inside of my inner loop. And let me go ahead and I don't even want the global variable here. All I want to do is focus on the current title. How could I detect if someone likes the office? Well, I could say something like, how about this? So counter equals 0. We'll just focus on the office. If title equals the office, I could then go ahead and say counter plus equals 1. I don't need a key. There's no dictionary involved now. It's just a simple integer variable. And then down here, I'll say something like number of people who like the office is whatever this value is, and I'll put in counter in curly braces, and then I'll turn this whole thing into an F string. All right, let me go ahead and run this. Python of favorites.py, enter. Number of people who like the office is 15. All right, so that's great, but let's go ahead now and deliberately muddy the data a bit. All of you were very nice in that you typed in the office. But you could imagine someone just typing office, for instance, maybe there, and many people might just write office. You could imagine, didn't happen here, but suppose it did, and probably would have if we had even more submissions over time. Now let's go ahead and rerun this program. No changes to the code. Now only 13 people like the office. So let's fix this. The data is now, as I mutated it, to have a couple of offices and many the offices. How could I change my Python code to now count both of those situations? What could I change up here in order to improve this situation? Any thoughts? Yeah. Yeah, so I could just ask two questions like that. If title equals the office or title equals just office, for instance, and I'm still don't have to worry about capitalization. I don't have to worry about spaces because I at least threw that all away. Now I can go ahead and rerun this code. Let me go run it a third time. OK, so we're back up to 15. So I like that. But this you can imagine this not scaling very well, right? Like Avatar had 3 different permutations, and there were some others, if we dug deeper, that there might have been more variants. Could we do something a little more general purpose? Well, we could do something like this. If office in the title, this is kind of a cool thing you can do with Python. It's very English-like. Just ask the question, albeit tersely. This, interesting, just got me into trouble. Now all of a sudden we're up to 16. Does anyone know what the other one is? What office? Oh, interesting. Yes, so they hit the. OK. OK, someone did that. Sure. So the v office. OK, this one's actually going to be hard to correct for. Like, I can't really think of a general. Well. This is actually a good example of like data gets messy fast. And you could imagine doing something where, OK, we could have like 26 conditions. If someone said the A office or the B office, or right, you could imagine doing that. But then there's surely going to be other typos that are possible. So that's actually a hard one to fix. But it turns out we got lucky, and now this is actually the accurate count. But the data is itself messy. Let me show another way that just as another tool to our toolkit. It turns out that there's this feature in many programming languages, Python among them, called regular expressions. And this is actually a really powerful technique that we'll just scratch the surface of here, but it's going to be really useful actually maybe toward final projects, in web programming, anytime you want to clean up data or validate data. And actually, just to make this clear, give me a moment before I switch screens here. And let me open up a Google form from scratch. Give me just a moment to create something real quick. If you've never noticed this before when creating a Google form, you can do like a question. And if you want the user to type in something very specific as a short text answer like this, you might know that there's toggles like this in Google's world, like you can require it. Or you can do response validation, like you could say, what's your email? And then you could say something like text is an email. So here's an example in Google Forms how you can validate users' input. But a feature most of you have probably never noticed or cared about or used is this thing called a regular expression, where you can actually define a pattern. And I could actually re-implement that same idea by doing something like this. I can say, let the user type in anything, represented by dot star, then an @ sign, then something else, then a literal period, then, for instance, something else. So it's very cryptic, admittedly, at first glance. But this means any character 0 more times. This means any character 0 more times. This means a literal period, because apparently dot means any character in the context of these patterns. Then this thing means any character 0 more times. So I should actually be a little more nitpicky. You don't want 0 or more times. You want 1 or more times. So this with a plus means any character 1 or more times. So there has to be something there. And I think I want the same thing here, 1 or more times, 1 or more times. Or heck, if I want to restrict this form in some sense to edu addresses, I could change that last thing to literally .edu. And so long story short, even though this looks, I'm sure, pretty cryptic, there is this sort of mini language built into Python and JavaScript and Java and other languages that allows you to express patterns in a standardized way. And this pattern is actually something we can implement in code too. And let me switch back to Python for a second just to do the same kind of idea. Let me toggle back to my code here. Let me put up, for instance, a summary of what it is you can do. And here's just a quick summary of all of the available, some of the available symbols. A period represents any character. Dot star or dot asterisk means 0 or more characters. So the dot means anything. So it can be A or nothing. It can be B or nothing. It can be AB, ABC. It can be any combination of 0 or more characters. Change that to a plus, and you now express 1 or more characters. Question mark means something is optional. Caret symbol means start matching at the beginning of the user's input. $sign means start matching at the end of the user, or stop matching at the end of the user's input. So we won't play with all of these just now, but let me go over here and actually tackle this office problem. Let me go ahead and import a new library called the regular expression library, import RE. And then down here, let me say this. If re.search, this pattern, let's just search for office, quote unquote, in the current title. Then we're going to go ahead and increase the counter. So it turns out that the regular expression library has a function called search that takes as its first argument a pattern, and then as its second argument, the string you want to analyze for that pattern. So it's sort of look for a needle in this haystack from left to right. Let me go ahead now and run this version of the program. Enter. And now I screwed up because I forgot my colon. But that's old stuff. Enter. Number of people who like The Office is now 0. So this seems like a big, thank you, big step backwards. What did I do wrong? Yeah. Yeah, so I forced all my input to uppercase, so I probably need to do this. So we'll come back to other approaches there. Let me rerun it now. OK, now we're back up to 16. But I could even, let's say, I could tolerate just The Office. How about this? Or how about something like or The Office? Let me do this instead. And let me use these other special characters. This caret sign means the beginning of the string. This $sign weirdly represents the end of the string. I'm adding in some parentheses, just like in math, just to add another symbol here, the or symbol here. And this is saying start matching at the beginning of the user string. Check if the beginning of the string is office or the beginning of the string is the office. And then you better be at the end of the string. So they can't keep typing words before or after that input. Let me go ahead and rerun the program. And now we're down to 15. Which used to be our correct answer, but then we noticed the office. How can we deal with that? It's going to be messier to deal with that. But I could. How about if I tolerate any character represented by dot in between the and office? Now if I rerun it, now I really have this expressive capability. So this is only to say there are so many ways in languages in general to solve problems, and some of these tools are more sophisticated than others. This is one that you've actually probably glanced at but never used in the context of Google Forms for years if you're in the habit of creating these for student groups or other activities. But it's now something you can start to leverage, and we're just scratching the surface of what's actually possible with this. But let's now do one final example just using some Python code here, and let's actually write a program that's a little more general purpose that allows me to search for any given title and figure out its popularity. So let me go ahead and simplify this. Let's get rid of our regular expressions. Let's go ahead and continue capitalizing the title. And let's go ahead to, at the beginning of this program, and first ask the user for the title they want to search for. So title equals, let's ask the user for input, which is essentially the same thing as our CS50 getString function. Ask them for the title. And then whatever they type in, let's go ahead and strip white space and uppercase the thing again. And now inside of my loop, I could say something like this. If the current row's title, after stripping white space and forcing it to uppercase 2, equals the user's title, then go ahead and maybe increment a counter. So I still need that counter back. So let me go ahead and define this maybe in here. Counter equals 0. And then at the very end of this program, let me go ahead and print out just the popularity of whatever the human typed in. So again, the only difference is I'm asking the human for some input this time. I'm initializing my counter to 0. Then I'm searching for their title in the CSV file by doing the same massaging of the data by forcing it to uppercase and getting rid of the white space. So now when I run python of favorites.py, enter, I could type in the office, all lowercase even, and now we're down to 13. Why? Oh, that's correct, because I'm the one that went in and removed those the keywords a bit ago. If we fix those, we would be back up to 15. If we hadn't support for the office, we would be up to 16 as well. All right, any questions then on these various manipulations? And if you're feeling like, oh my god, this is so much Python code just to do simple things, that's the point. And indeed, even though it's a powerful language and can solve these kinds of problems, we had to write almost 20 lines of code just to ask a single question like this. But any questions on how we did this, or on any of these building blocks along the way? Anything here? No? All right, that was a lot. Let's take a 5-minute break here. When we come back, we'll do it better. So we are back. And the rest of today is ultimately about how can we store and manipulate and change and retrieve data more efficiently than we might by just writing raw code. This isn't to say that you shouldn't use Python to do the kinds of things that we just did. And in fact, it might be super common if you're getting a lot of messy input from users that you might want to clean it up. And maybe the best way to do that is to write a program so that step by step you can make all of the requisite changes and fixes like we did with the Office, for instance, again and again, and reuse that code, especially if more and more submissions are coming through. But another theme of today ultimately is that sometimes there are different, if not better, tools for the same job. And in fact, now at this point in the term, as we begin to introduce not just Python, but in a moment a language called SQL, and next week a language called JavaScript, and the week after that, synthesizing a whole lot of these languages together, is to just kind of paint a picture of how you might decide what the trade-offs are between using this tool or this other tool, because undoubtedly you can solve problems moving forward in many different ways with many different tools. So let's give you another tool, one with which you can implement a proper relational database. What we just saw in the form of CSV files are what we might call flat file databases. Again, just a very simple file, flat in that there's no hierarchy to it. It's just like rows and columns. And that is all ultimately storing ASCII or Unicode text. A relational database, though, is something that's actually closer to a proper spreadsheet program, right? Like a CSV is an individual sheet, if you will, from a spreadsheet when you export it. If you had multiple sheets in a spreadsheet, you would have to export multiple CSVs. And that gets annoying quickly in code if you have to open up this CSV, all of which represent different sheets or tabs in a proper spreadsheet. A relational database is more like a spreadsheet program that you, a programmer now, can interact with. You can write data to it, you can read data from it, and you can have multiple sheets, aka tables, storing all of your data. So whereas Excel and numbers and Google Spreadsheet are meant to be used really by humans with their mouse and their keyboard, clicking and pointing and manipulating things graphically, a relational database using a language called SQL is one in which the programmer has similar capabilities, but doing so in code, specifically using a language called SQL, and at a scale that's much grander than spreadsheets alone. In fact, if you try on your Mac or PC to open a spreadsheet that's got tens of thousands of rows, it'll probably work fine. Hundreds of thousands of rows, millions of rows, no way. Like at some point, your Mac or PC is going to struggle to open particularly large data sets. And that, too, is where proper databases come into play and proper languages for databases come into play when it's all about scale. And indeed, most any mobile app or web app today that you or someone else might write should probably plan on lots of data if it's successful. So we need the right tools for that problem. So fortunately, even though we're about to learn yet another language, it only does 4 things fundamentally, known by this silly acronym, CRUD. SQL, this language for databases, supports the ability to create data, read data, update data, and delete data. Like, that's it. There's a few more keywords that exist in this language called SQL that we'll soon see. But at the end of the day, even if you're starting to feel like this is a lot very quickly, it all boils down to these 4 basic operations. And the 4 commands in SQL, if you will, functions in a sense, that implement those 4 ideas happen to be these. They're almost the same, but with some slight variance. The ability to create or insert data is the C. The ability to select data is the R, or read. Update is the same, delete is the same, but drop is also a keyword as well. So we'll see these and a few other keywords in SQL that at the end of the day just allow you to create, read, and update data using verbs, if you will, like these. So to do that, what's the syntax going to be? Well, we won't get into the weeds too quickly on this, but here's a representative syntax of how you can create, using this language called SQL, in your very own database, a brand new table. Right? This is so easy in Excel and Google Spreadsheets and Apple Numbers. You want a new sheet, you click the plus button, you get a new tab, you give it a name, and boom, you're done. In the world of programming, though, if you want to create the analog of that spreadsheet in the computer's memory, you create something called a table, like a sheet that has a name, and then in parentheses has 1 or more columns. But unlike Google Spreadsheets and Apple Numbers and Excel, you have to decide as the programmer what types of data you're going to be storing in each of these columns. Now, even though Excel and Google Spreadsheets and Numbers does allow you to format or present data in different ways, it's not strongly typed data like it is, for instance, when we were using C. And heck, even in Python, there's underlying data types, even if you don't have to type them explicitly. Databases are going to want to know, are you storing integers? Are you storing real numbers or floats? Are you storing text? Why? Because especially as your data scales, the more hints you give the database about your data, the more performant it can be, the faster it can help you get at and store that data. So types are about to be important again, but there's not going to be that many of them, fortunately. Now, how can I go about converting, for instance, some real data, like that from you, my favorites.csv file, into a proper relational database? Well, it turns out that using SQL, I can do this in VS Code on my own Mac or PC or in the cloud here by just importing the CSV into a database. We'll see eventually how to do this manually. For now, I'm going to use more of an automated process. So let me go over to VS Code here. Let me type ls to see where we left off before. I had 2 files, favorites.csv, which I downloaded from Google Spreadsheets. Recall that I made a couple changes. We deleted a couple of thes from the file for the office, but this is the same file as before. And then we have favorites.py, which we'll set aside for now. I'm going to go ahead now and run a command, SQLite 3. So in the world of relational databases, there's many different products out there, many different software that implements the SQL language. Microsoft has their own. There's something called MySQL that's been very popular for years. Facebook, for instance, used it early on. PostgreSQL, Microsoft Access Server, Oracle, and maybe a whole bunch of other product names you might have encountered over time. Which is to say, there's many different types of tools and servers and software in which you can use SQL. We're going to use a very lightweight version of the SQL language today called SQLite. This is the version of SQL that's generally used on iPhones and Android devices these days. days, if you download an app that stores data like your own contacts, typically is stored using SQLite because it's fairly lightweight, but you can still store hundreds, thousands, even tens of thousands of pieces of data, even using this lightweight version thereof. SQLite 3 is like version 3 of this tool. We're going to go ahead and run SQLite 3 with a file called favorites.db. It's conventional in the world of SQLite to name your file something.db. I'm going to create a database called favorites.db. Once I'm inside of the program now, I'm going to go ahead and enter CSV mode. Again, not something you have to memorize, just something you can look up as needed. And then I'm going to import favorites.csv into a table that is a sheet, if you will, called favorites as well. Now I'm going to hit enter, and I'm going to go ahead and exit the program altogether and type ls. Now I have 3 files in my current directory, the CSV file, the Python file from before, and now favorites.db. But if I did this right, all of the data you all typed into the CSV file has now been loaded into a proper database where I can now use this SQL language to access it instead. So let's go ahead again and run SQLite 3 of favorites.db, which now exists. And now, at the SQLite prompt, I can start to play around and see what this data is. For instance, I can look by typing .schema at what the schema is of my data. What's the design? Now, no thought was put into the design of this data at the moment because I automated the whole process. Once we start creating our own databases, we'll give more thought to the data types and the columns that we have. But we can see what SQLite presumed I wanted just by importing the data by default. What the import command did for me a moment ago is essentially this syntax. It automated the process of creating a table, if it doesn't exist, called favorites. And then notice in parentheses, it gave me 3 columns: timestamp, title, and genres, which were inferred obviously from the CSV, all 3 of which have been decreed to be text. Again, once we're more comfortable, we'll create our own tables, choose our own types and column names. But for now, I just automated the whole process just to get us started by using this built-in import command as well. All right. So what now can I begin to do? Well, if I wanted to, for instance, start playing around with data therein, I might execute a couple of different commands, one of which, let me find the right one here, one of which would be select. Select being one of our most versatile tools to select data from this database. So if I have these 3 columns here, timestamp, title, and genres, suppose I want to select all of the titles. Doing that earlier in Python required importing the CSV library, opening the file, creating a reader or a dict reader, iterating over every row, adding every title to a dictionary or just printing it out, and ... right? There was like a dozen or so lines of code when we first began. Now, how about this? Select title from favorites, semicolon, done. So now, with this particular language, the output is very textual, and it's simulating what it looks like if it were more graphical by creating this table, so to speak. Select title from favorites is a distillation in a different language called SQL of all the lines of code I wrote early on when we first started playing with favorites.py. SQL is therefore optimized for reading and creating and updating and ultimately deleting data. So here's perhaps a better tool for the job once you have the data. Tossing it into a more powerful, versatile format might allow you now to get more work done more quickly without having to reinvent the wheel. Someone else has figured out how to select data like this. What more can I do here? Well, let me go ahead and pull up in a moment just a little bit of a cheat sheet here. Give me 1 second to find this. So suppose I want to now select data a little more powerfully. So here's what I just did in a canonical way. So select typically works like this. You select columns from a specific table, semicolon. Unfortunately, stupid semicolons are back. Select columns from table, then, is the sort of generic form of what I just did more specifically. I selected 1 column called title from favorites. Favorites is the name of the table. Semicolon ends my thought. Suppose I wanted to get 2 things, like the genres that each of you inputted. I could instead do select title, comma, genres from favorites, and then a semicolon, and enter. It's going to look a little ugly on my screen because some of these titles and some, OK, one of you really went all out with community. You can see that it's just wrapping in an ugly way, but it's just now showing me 2 columns. If we scroll up to the very top again, the leftmost of one, Black Mirror went all out too, thank you. And now OK, we're going to have to clean some of these up. Game of Thrones, good comedy, yes. um, Keep going, keep going, keep going. So now we've selected 2 of the columns that we care about. There it is. OK, so it's crazy wide because of all of those genres, but it allows me to select exactly the data I want. Let's go back to the titles, though, and perhaps start playing around with some modifiers here. For instance, it turns out, using SQL, there's a lot of functionality built into the language. You've got a lot of functions, similar to Excel or Google Spreadsheets where you can have formulas. SQL provides you with some of the same heuristics that allow you to apply operations like these on entire columns. For instance, you can take averages, count the total, get the distinct values, force things to lowercase, uppercase, min and max, and so forth. So let's try distinct, for instance. Let me go back to my terminal, and let's say select, how about the distinct titles from the favorites table? Enter. I didn't bother selecting the genres because I want it to be a little prettier. And you can see here that we have just the distinct titles, except for issues of formatting, right? So white space is going to be an issue again. Capitalization is going to be a thing again. So there's a trade-off. I mean, one of the things I was doing in Python was forcing everything to uppercase and then getting rid of white space. But we could combine some of these. I could do something like force every title to uppercase, then get the distinct value. And that's actually going to get rid of some of those values as well. And again, I did it all in one simple line. That was fast. So let me pull up at the bottom of the screen again. I selected distinct upper titles from favorites. And that did everything for me at once in just one breath. Suppose I want to get the total number of counts of titles. How about select count of all of those titles from favorites, semicolon, enter. And now you get back sort of a mini table that contains just your answer, 158 in this case. So that's the total number of not distinct, but total titles that we had in the file. And we can continue to manipulate the data further using, again, functions like these here. But there's also additional filtration we can do. We can also qualify our selections by saying where some condition is true. So just as in Scratch, in C, and Python, you have Boolean expressions, you can have the same in SQL as well, where I can filter my data where something is true or false. Like allows me to do approximations. If I want to get something that's like the office, but not necessarily THE space office, I could do pattern matching using like here. Order by, limit, and group by are other commands I can execute too. So let me go back and do a couple of these here. How about, let me just get, I don't know, all of the titles from favorites, but limit it to 10 results. That might be one thing that's helpful to see if you just care about some of the data at the top there instead. How about select all of the titles from favorites where the title itself is like, quote unquote, office. And this will give me only 2 answers. Those are the 2 rows, recall, that I mutated by getting rid of the word the. Notice that like allows me to tolerate uppercase and lowercase, because if I instead just use the equal sign, and in SQL, in single equal sign does, in fact, mean equality. It's not, for comparison's sake, it's not doing assignment. This is not how you assign data in SQL. I got back no answers there. So indeed, the equal sign is giving me literal answers that searches just for what I typed in. How could I get all of these? Well, similar in spirit to regular expressions, but not quite as powerful in SQL. I could do something like this. I can select the title from favorites where the title is like, quote unquote, office, but I can add, a bit weirdly, % signs to the left and the right. So the language SQL supports the same notion of pattern matching, but much more limited out of the box. If we want more powerful regular expressions, we probably do want to use Python instead. But the % sign here means 0 or more characters on the left, 0 or more characters on the right. So this will just grab any title that contains OFFICE in it in that order. And now I get all 16, it would seem, of those results again. How do I know it's 16? Well, I can just get the count of those titles and get back that answer instead as well. So again, it takes some getting used to the vocabulary and sort of the syntax that you can use. There's these building blocks and others, but SQL is really designed, again, for creating, reading, updating, and deleting data. For instance, I've never really been a fan of friends, for instance. So right now, if I do select, how about title from favorites, where title like, quote unquote, friends with the percent signs, we can see that there's a whole bunch of them. That's how many exactly? Let's just do a quick count. So that's 9 of them. Well, delete from favorites. OK, you and me, you delete from favorites where title like friends, enter. Nothing seems to happen, but bye-bye friends. So now we've actually, thank you. So now we've actually changed the data. And this is what's compelling about a database, a proper database. Yes, you could technically write Python code that not only reads the CSV file, but also writes it. Like you can change using quote unquote A for append or quote unquote W for write instead of quote unquote R for read alone. But it's definitely a little more involved to do that in Python. But with SQL, you can update the data in real time. And if I were actually running like a web application here or a database for a mobile app, that change theoretically would be reflected everywhere on your own devices if you're somehow talking to this application. So that's sort of the direction we're headed. This other thing has been bothering me. So select, how about title from favorites, where title equals, what was it? The office, was it? Yeah, it was that one. How about we update favorites by setting title equal to the office, where title equals, quote unquote, the office, semicolon. And now if I select the same thing again, I can go up and down with my arrow keys quickly. Now there is no the office. We've actually changed that value. How about genres? Select genres from favorites where the title is title equals Game of Thrones, semicolon. These were kind of long. And I don't really agree with all of that. So how about we update favorites, set genres equal to, sure, action, adventure, sure, drama. OK, so it's a decent list. Fantasy, sure, thriller, war. OK, anything really but comedy, I would say. Let's go ahead and hit enter now. And now if I select genres again, same query, now we've sort of canonicalized that. We've thrown data away. So whether or not that is right is probably a bit subjective and argumentative. But I have at least cleaned up my data, which is, again, the U in CRUD. Create, read, update, delete. You can do it that easily. Beware using delete. Beware worse using drop, whereby you can drop an entire table. But via these kinds of commands, can we actually now manipulate our data much more rapidly and with single thoughts. And in fact, if you're an aspiring statistician or data scientist or analyst in the real world, SQL is such a commonly used language because it allows you to really dive into data quickly and ask questions of the data and get back answers quite quickly. And this is a simple data set. You can do this with much larger data sets, as we soon will too. Are any questions on what we've seen of SQL thus far? Only scratch the surface. But again, it boils down to creating, reading, updating, and deleting data. Questions here? All right, well, let's consider the design of this data. Recall that if I do .schema, that shows me the design of my table, the so-called schema of my data. This is OK. It gets the job done. And frankly, everything the user typed in was arguably text, including the timestamp, which is the date and time. So the data set itself is somewhat simple. But if we look at the data set itself, especially genres, let's do this. Select genres from favorites. And let me point out one other thing stylistically, too. I am very deliberately capitalizing all of these special SQL keywords, and I'm lowercasing all of the column names and the table names. This is a convention. And honestly, it just helps you read, I think, the code when you're commingling your names for columns and tables with proper SQL keywords. But I could just as easily do select genres from favorites. But again, the SQL-specific keywords don't quite jump out as much. So stylistically, we would recommend this, selecting genres from favorites, semicolon. So here is where, OK, that was not intended. I accidentally made every show, including The Office, about action, adventure, drama, fantasy, thriller, and war. How did I do that accidentally? What did I do wrong? Yeah, so beware. It's funny, I think I did say beware around this time. So the SQL database took me literally. I updated favorites, setting genres equal to that, semicolon, end of thought. I really wanted to say where title equals, quote unquote, Game of Thrones, unfortunately, there isn't an undo command or time machine with a SQL database. So the best we can do here is let's actually get rid of favorites.db. Let's run SQLite of favorites.db again, which now will be recreated. Let me change myself into CSV mode. Let me import into my favorites table, the CSV file. And now, friends is back for better or for worse, but so are all of our genres. So if I now do select, if I now reload the file and do select genres from favorites, that was the result I was getting. It's much messier, but that's because some of these are quite long. But now we're back to the original data. Lesson here, be sure to back up your work. All right, so what more can we now do with this data? Well, I don't love the design of the genres table for a couple of reasons. One, I mean, we didn't have any sort of validation, but user input's going to be messy. There's just a lot of redundancy in here, right? Like, let's go ahead and do this. Let me select all the comedies you all typed in. So select title from favorites where genres equals quote unquote comedy. OK, so there's all of the shows that are explicitly comedies. But I think there might actually be others. Let me scroll back up here. Comedy drama. What was a comedy and a drama? How about? Let's search for the, whoops. Let me copy paste comedy, comma, drama. OK, so The Office, in this case, was considered comedy and drama. Billions, It's Always Sunny in Philadelphia, and Gilmore Girls as well. But notice that I get many more when I just search for comedy. So the catch here is that because I have all of these genres implemented the way Google did as a comma-separated list, it's actually really hard and messy to get at any show, all of the shows that are somewhere described as comedy, right? Because if I search for quote-unquote comedy, the only answers I'm going to get are this one, whatever that show is, this one, whatever that show is, this one, but I'm not going to get this one. I'm not going to get this one. Why? If I'm searching for where genres equals quote-unquote comedy, why am I missing those other shows? Why am I missing? Yeah. Exactly. It's not just a comedy. It's a comedy and a drama and a comedy or a news show and so forth. So I have to search for these commas. So this gets messy quickly, right? Like, let me copy this so I can do this. Let me search for where genres equals comedy. How about or genres equals comedy drama, or genres equals this whole thing, comedy, news, talk show. I'm going to get more and more results, but that's not going to scale well. What could I do instead of enumerating with ors all of the different permutations of genres, do you think? Yeah, so I could use the keyword, similar in Python to the word in. I could use the like keyword so that so long as the genres is like comedy somewhere in there, that's going to give me all of them, so long as the word comedy is in there. But let me go ahead and just open the form from earlier. The form had, let me see if I can open this real quick before I toggle over. If we look back at the form, recall that there were all of those radio buttons asking for the specific genres into which something fell. And if I open this, let me full screen here and now open the original form, you'll see all of the genres here, none of which are that worrisome except for a corner case is jumping out at me. Where might the like keyword alone get me into trouble? It's not with comedy. I'm OK with comedy, but yeah, music and musical are deliberately on the list here because, one, there are separate genres. But if I just search for something that's like music, I'm going to accidentally suck in all of the musicals, which might not be what I intend. If music is like a music video or whatever, and musical is actually a different type of show, I don't want to just do that. So it seems just very messy. Like I could probably hack something together with maybe add some commas in there or something like this. But this is just not a good design for the data. Google has done it this way because it's just simple to actually keep the user's data all in a single column and, just as they did, separate it by commas. But this is a real messy way to use CSV is by putting comma-separated values in your comma-separated values. Arguably, the folks at Google probably just did this because it's just simpler. And they didn't want to give people multiple sheets or complicate things using some other weirder character than commas alone. But I bet there's a better way for us to do this. And let me go ahead and do this. Let me go back into my code here. And in just a moment, I'm going to grab a program that I wrote in advance that's going to use Python to open up the CSV file, iterate over all of the rows, and load the data into 2 tables this time. 2 tables, one called shows and one called genres, so as to actually separate these 2 things out. Give me just a moment to grab the code. And when I run this, I'll only have to run it once. Let me go ahead and run Python in a moment, and I'll reveal the results in a sec. This is going to be version 8 of the code online. When I do this, let me go ahead and open up this file. Give me a second to move it into this directory. Version 8. OK. So here we have version 8 of this that's available online that's going to do the following. And I'll gloss over some of the details just so that we don't get stuck in the weeds of some of this code. I'm going to be using at the top of this program, as we'll soon see, a CS50 library, not for the sake of getString or getInt or getFloat, but because there's some built-in SQL functionality that we didn't discuss a couple of weeks back with the CS50 library itself. But inside of the CS50 library, we'll see, there is a special function called SQL that gives you the ability, using this weird URL-like looking thing, technically called a URI, that allows me to open a file called favorites.db. And long story short, all of the subsequent code is going to iterate over this favorites.csv file that we downloaded, and it's going to import it into the SQLite database, but it's going to use 2 tables instead of just 1. So give me just a moment to run this, and then I'll reveal the actual results. This is going to be run on favorites.csv. And taking a look here, give me just a moment. Give me a sec. Come on. Come on. This program should not be taking this long. Sorry. Let's open this real fast. Whoops, not that file. OK, let me just skim this code real quick to see where we've gone wrong with favorites.csv, reader, title, show ID, insert into shows. Row and genre split, db execute. All right, this is me debugging in real time. All those times we encourage you to use print. This is me actually using print. We'll see how quickly I can recover from this. Python of favorites version 8. OK, so here's me debugging in real time. It's printing out. Oh, maybe I just didn't wait long enough. OK, so here we go. What I'm doing is printing out the dictionary that represents each row that you all typed in. And we're actually making progress. All right, I was too impatient and didn't wait long enough. So in a moment, there we go. All right, so all you have to do sometimes is wait. Let me go ahead now and open this file using SQLite 3. So in SQLite 3, I now have a different version of favorites.db. I named it number 8 for consistency. Once I've run the program, I can do .schema to look inside of it. And here's what the 2 tables in this database are going to look like. I've created a table called shows, this time to represent all of the TV shows that are favorites, that has 2 columns. One is called ID. One is called title. But now I'm going to start taking out for a spin some of the other features of SQL. And besides there being text, it turns out there's a data type called integer. Besides there being a data type called text, there's also a special key phrase that you can specify that the title can never be null. Think back to our use of null in C. Think back to the keyword none in Python. This is a database constraint that allows you to ensure that none of you can't have a favorite TV show. Like if you submit the form, you have to have typed in a title for it to end up in our database here. And you'll notice one other new feature. It turns out on this table, I'm defining what's called a primary key, specifically to be the ID column. More on that in just a moment. Meanwhile, the second table my code has created for me, as we'll soon see, gives me a column called show ID, and then a genre, the value of which is text, that can also not be null. And then more on this in a moment. This table has what we're going to call a foreign key, specifically the show ID column that references shows ID. So before we get into the weeds of this, this is now a way of creating the relation in relational database. If I have two tables now, not just one, they can somehow be linked together by a common column. In other words, the shows column, shows table, is going to give me a table with two columns, an ID and a title. Every title you gave me, I'm going to assign a unique value. The genres table, meanwhile, is going to associate individual genres, singular, with that same ID. And the result of this, to pop back to the terminal here, is let's do this. Select star from shows of this new database. And you'll see that I've given, indeed, all of the shows you all typed in unique identifiers. I didn't filter out duplicates or do anything beyond just forcing everything to uppercase. So there's going to be some duplicates here because I didn't want to get rid of anyone's data. But you'll see that, indeed, I've given everyone a unique identifier, from the very first person who typed how I met your mother all the way down to input number 158. Meanwhile, if I do select star from genres, which is now a table, not just a column in the original data, now you'll see a much better design for this data. Notice what I've done here. Let me go all the way to the top, and you'll see two columns, one of which is called show ID, the other of which is called genre. And again, I wrote some code to do this because I had to take Google's messy output where everything was separated by commas. I had to tear away the commas and then put each genre into this table by itself. Even though we haven't introduced the syntax via which we can reconstitute the data and reassociate your genres with your titles, why at a glance might this be a better design now? Even though I've doubled the number of tables from 1 to 2, why is this probably on the direction toward a better design? What might your instincts be? Why is this cleaner? Again, first time with SQL. Why is it better, perhaps, that we've done this with our genres table? Can I come to you? Why might this be better? Yeah, oh, just because we had the conversation before about the commas. Exactly. It's as simple as that. We've cleaned up the data by giving every genre, every word in the genres column in the original Google spreadsheet its own cell in this table, if you will. And now notice show ID might appear multiple times. Whoever typed in how I met your mother, they only associated one genre with it. And so we see that show ID 1 is a comedy. But whoever typed in, I forget the name of the second show offhand, but that person, whoever was assigned show ID 2, checked off a whole bunch of the genres boxes. That happened again with show ID 3, 4, persons 5, 6, 7, only checked one box. And so you can see now that we've associated the data with what we might call a one-to-many relationship, a one-to-many relationship, whereby for every one show in the shows table, it can now have many genres associated with it, each of which is represented by a separate row here. So again, if I go ahead and select star from shows, let's limit it to the first 10, just to focus on a subset of the data. How I Met Your Mother, The Sopranos was the second input there. It would seem that now that I've created the data in this way, I could ideally somehow search the data, but a little more correctly. I don't have to worry about the commas. I don't have to worry about the hackish approach of music being a substring of musical. But how can I actually get back at this data? Well, let's go ahead and do this. Suppose I did want to get back maybe all of the comedies. All of the comedies, no matter whether the person checked just the comedy box or multiple boxes instead. How now, given that I have two tables, could I go about selecting only the titles of comedies? Like, I've actually made the problem a little harder, but again, SQL is going to give me a solution for this. The problem is that if I want to search for comedies, I have to check the genres table first, and then what's that going to give me? Like, if I search the genres table for comedies, what's that going to give me back? Potentially, yeah. Maybe show ID. So let me try that. Let me do select show ID from genres, where the genre in a given row equals quote unquote comedy. No commas, no like, no percent signs, because literally that column now is singular words like comedy or drama or the like. Let me go ahead and hit enter here. OK, so I got back a whole bunch of ID numbers. Now, this could very quickly get annoying. It looks like show ID 1, 2, 4, 5, 6, 7, 9, and so forth are all comedies. So I could do something really crazy like select title from shows where ID equals 1 or ID equals 2 or ID equals, I mean, this is not going to scale very well, but this is why SQL is especially powerful. You can actually compose one SQL question from multiple ones. So let's do this. Why don't I select the title where the ID of the show is in the following list of IDs. Select show ID from genres where the specific genre is quote unquote comedy. So I've got two SQL queries. One is deliberately nested inside of parentheses. That's going to give me back that whole list of show IDs. But that's exactly what I want to then look up the titles for by selecting title from shows where the ID of the show is in that big, tall list. And so now if I hit enter, I get back only those shows that were somehow flagged as comedy, whether you in the audience checked one box for comedy, two boxes, or all of the boxes. Somehow we teased out comedy, again, just by using that Python script, which loaded this data not into one big table, but instead two. And if we want to clean this up, let's do a couple of things. Let's, outside of the parentheses, do order by title. This is a way of sorting the data in SQL very easily. Now we have a whole list of the same titles that are now sorted. And what was the keyword with which I could filter out duplicates? Yeah, distinct. So let's try this. Same query, but let's select only the distinct titles from that whole query. And notice, I've very deliberately done it this way. And to this day, anytime I'm using SQL, I don't just start at the beginning and type out my whole thought and just get it right on the first try. I very commonly start with the subquery, if you will, the thing in parentheses, just to get myself one step toward what I care about. Then I add to it, then I add to it, then I add to it, just like we've encouraged in Python and C, taking baby steps in order to get to the answer you actually care about, like this one now. And other than this mistake, which we didn't fix because I re-imported the data after accidentally changing everyone's genre, we now have an alphabetized list of all of the same data. But now it's better designed because we have it split across these two tables. Oh, thank you. OK, just thanks. What questions do we have, if any, here? Questions on this approach? Yeah. Oh, now that we have a database, how do we transfer it to a CSV? There are ways to do that. And in fact, there's a command within SQLite that allows you to export your data back to a CSV file. If you want to email it to someone and you want them to be able to open it in Excel or Google Spreadsheets or Apple Numbers or the like, you can go in the other direction. Generally, though, once you're in the world of SQL, you're probably storing your data there long term. And you're probably updating it, maybe deleting it, adding to it, and so forth. For instance, the one command I did not show earlier is suppose someone forgot a show. Let's see. Did I see this in the output? All right, so curb your enthusiasm. Saw that last night. It was just, yeah. Did anyone see it last night? No. All right, well, just the one person that checked that box, so you and me. What's another show that didn't make the list? How about Seinfeld is now on Netflix, apparently. So insert into shows. What do we want to insert? Well, we want to insert maybe an ID and a title. But you know, I don't actually care what the ID is. So I'm just going to insert a title. And the value I'm going to give to that title is going to be, quote unquote, Seinfeld. And then let me go ahead and hit semicolon. Nothing seems to happen, but let me rerun the big query from before looking for comedies. And unfortunately, Seinfeld has not yet been flagged as a comedy. So let's get this right, too. What intuitively I'm going to have to do to associate now Seinfeld with my comedies? I just inserted into the shows table. What more needs to happen before we can flag Seinfeld as a comedy? Say again? Yeah, so I need to insert into the genres table two things now. A show ID, like this, and then the name of the genre, which presumably is comedy. What values do I want to insert? Well, the show ID, I better grab that. Oh, I don't even know what it is. I'm going to have to figure out what that is. So I could do this in a couple of ways. Let me do it a one-time thing. Select star from shows where title equals, quote unquote, Seinfeld, semicolon, 159. So now I could do insert into genres a show ID and a genre name, the values 159 and quote unquote comedy, semicolon, enter. And now if I scroll back in my history and execute that really big query again, looking for all distinct comedies, now Seinfeld has made the list. But I did this manually, so I didn't actually capitalize it. Let's clean that up. Let's do update. Let's do update my shows, set title equals to Seinfeld, semicolon? No? OK, thank you. Where title equals, quote unquote, Seinfeld. Let's not make that mistake again. Enter. And now if I execute that really big query, now Seinfeld is indeed considered a comedy. So where are we going with this? Well, thus far, we've been doing all of this pretty manually. And this is absolutely what an analyst, a data scientist type person might do if just manipulating a pretty large data set just to get at interesting answers that might be across 1, 2, or even many more tables. Eventually, in a few weeks, we're going to start to automate all of this by writing code in Python that generates SQL to do this, right? If you go to most any website on the internet today and you, for instance, log in, odds are you're typing a username and password, clicking submit. What's then happening? Well, the website might not be implemented in Python, but it's probably implemented in some language, Python, JavaScript, Java, Ruby, something else. And that language is probably using something like a relational database to use SQL to get your username, get your password, and compare the two against what you've typed in. And actually, it's hopefully not getting your actual password, but something called a hash thereof. But there's probably a database involved doing that. When you buy something on Amazon.com and you click checkout, odds are there's some code on Amazon server that's looking at what it is you added to your shopping cart, and then maybe using a for loop of some sort in Python or another language. It's doing a whole bunch of SQL inserts to store in their database what it is you bought. There's other types of databases too, but SQL databases or relational databases are quite popular. So let's go ahead and write one other program here in Python that now merges these two languages together, whereby I'm going to use SQL inside of a Python program so I can implement my sort of logic of my program in Python, step by step, line by line. But when I want to get at some data, I can actually talk to a SQL database. So let me go ahead and open favorites.python here, .py. And let me go ahead and throw away some of what we did earlier and really just now add a SQL to the mix. From the CS50 library, let's import the SQL function. This will be useful to use because most third-party libraries that deal with SQL and Python are more complicated than they need to be. So I think you'll find this library easier to use. Let's then do the following. Create a variable called db for database. I could call it anything I want. Let's use that URI, which is a fancy way of saying something that looks like a URL, but that actually opens up a database on disk, that is, in the current folder. Let's now ask the user for a title by prompting them for a quote unquote title like this. And let's strip off any white space just so that the data is not messy. And then let's go ahead and do this. And this is the new logic. I'm going to go ahead now and write a line of code that uses Python to talk to the original favorites.db. So again, I'm not using the two-table database, which is in favorites8.db. I'm using the original that we imported from your own data. And I'm going to do the following. I'm going to use db.execute to execute a SQL command inside of Python. I'm going to select the count of shows from the favorites table where the title you typed in, where the title the user typed in is like this question mark. And why I'm doing that is as follows. Just like in C, when we had %s, in SQL for now, the analog is going to be a question mark. So same idea, different syntax. Instead of %s, it's just a question mark. And using a comma outside of this first string, using CS50's execute function, I can pass in a SQL string, a command, then any arguments I want to plug into the question marks therein. So the goal at hand is to actually write a program that's going to search favorites.csv, aka favorites.db, for the total number of people that liked a particular show. So this is going to select the count of people from the favorites table where the title they typed in is like whatever the user has just now typed in. This db execute function returns a list. It returns a list of rows. And you would only know that by my telling you or reading the documentation. And therefore, if I want to get back the total count, I'm going to go ahead and grab the first row from those rows, because it's only going to give me back the count. And then I'm going to go ahead and print out that row's first value. But it's going to be a little weird. Technically, the column is going to be called count star quote unquote, which is a little weird. Let me add one more feature to the mix. You can actually give nicknames to columns that are coming back, especially if they are the result of functions like this. I can just call that column counter in all lowercase. That means I can now say get back the counter key inside of this dictionary. So just to recap, what have we done? We've imported the CS50 library SQL function. We've, with this line of code, opened the favorites.db file that you and I created earlier by importing your CSV into SQLite. I'm now just asking the user for a title they want to search for. I'm now executing this SQL query on that database, plugging in whatever the human typed in as their title in order to get back a total count. And I'm giving the count a nickname, an alias of counter, just so it's more self-explanatory. This function dbExecute, no matter what, always returns a list of rows, even if there's only one row inside of it. So this line of code just gives me the first and only row. And then this goes inside of that row, which it turns out is a dictionary, and gives me the key counter and the value it corresponds to. So what, to be clear, is this doing? Let's go ahead and run this manually in my terminal window first. Let me run SQLite 3 on favorites. Let's do this. On favorites.db, let me import the data again. So mode CSV dot import in from favorites.csv into a favorites table. So I've just recreated the same data set that you all gave me earlier in favorites.db. If I were to do this manually, let's search for the office again. Select count star from favorites where title like, and let's just manually type it in for now, the office. We'll search for the one with the word the, semicolon. I get back 12. But technically, notice what I get back. I technically get back a miniature table containing one column and one row. What if I want to rename that column? That's where the as keyword comes in. So select count star as counter. Notice what happens. Enter. I just get back same simple table, but I've renamed the column to be counter just because it's a little more self-explanatory as to what it is. So what am I doing with this line of code? This line of code is returning to me that miniature temporary table in the form of a list of dictionaries. The list contains one row, as we'll see, and it contains one column, as we'll see, the key for which is counter. So let's now run the code itself. I'm going to get out of SQLite 3, and I'm going to run python of favorites.py. Enter. I'm being prompted for a title. I'm going to type in the office and cross my fingers, and there's that 12. Why is it 12? Well, there's a typo again, because I re-imported the CSV. I had deleted 2 of the thes, so we're back at the original data set. So there's 12 total that have quote unquote the office in the title like that. So what have we done? We've combined some Python with some SQL, but we've relegated all of the complexity of searching for something, the selecting of something, gotten rid of all of the with keyword, the open keyword, the for loop, the reader, the dict reader, and all of that. And it's just one line of SQL now, sort of using the best of both worlds. Are any questions on what we've just done here or how any of this works? Any questions here? Yeah? When does this function return more than one row? Well, was that the question? Yeah, so let's do that by changing the problem at hand. This program was designed just to select the total count. Let's go ahead and select, for instance, all of the ways you all typed in the office by selecting the title this time. If I do this in SQLite 3, if I do this in SQLite 3, let me go ahead and do this again after increasing my terminal window. Let's do it manually. Select title from favorites where the title is like, quote unquote, the office, semicolon. I get back all of these different rows, and we didn't even notice this one. There's actually another little typo in there with some capitalization of the E and the C and the E. That would be an example of a query that gives me back, therefore, multiple rows. So let's now change my Python program. If I now in my Python program do this, I get back a whole bunch of rows containing all of those titles. I can now do for row in rows, I can print out the current row's title and now manipulate all of those things together. Let me keep both on the screen. Let me run python of favorites.py. And that for loop now should iterate, 10 or more times, once for each of those titles. And indeed, if I type in the office again, enter. Whoops. Row title. What did I do wrong? Oh, I should not be renaming title to counter this time. So that's just a dumb mistake on my part. Let me rerun it again. And now I should see, after typing in the office, enter, a whole bunch of the offices. And because I'm using like, even the miscapitalizations are coming through, because like is case insensitive. Doesn't matter if it's uppercase or lowercase. Whereas had I used the equal sign, I would get back only the same ones, capitalized correctly. All right, any questions on this next? All right, so let's transition to a larger, juicier data set and consider some of the issues that arise when actually now using SQL and skating toward a world in which we're using SQL for mobile apps, web apps, and generally speaking, very large data sets. So let's start with a larger data set just like that. Give me just a moment to switch screens over to what we have for you today, which is an actual relational database that we've created out of a real world data set from IMDb. So internetmoviedatabase.com is a website where you can search for TV shows and movies and actors and so forth, all using their database behind the scenes. IMDb wonderfully makes their data set available as not CSV files, but TSV files, tab separated values. And so what we did is before class, we downloaded those TSV files. We wrote a Python program similar to my favorites 8.py file earlier that read in all of those TSV files, created some SQL tables in an IMDb database for you in SQLite that has multiple tables and multiple columns. So let's go and wrap our minds around what's actually in this data set. Let me go back to VS Code here, and in just a moment, I'm going to go ahead and copy the file, which we've named shows.db. And I'm going to go ahead and increase my terminal and do SQLite 3 of shows.db. Whenever playing around with a SQLite database for the first time, typing .schema is perhaps a good place to start to give you a sense of what's in there. And things just escalated quickly. Like there's a lot in this data set because indeed there's going to be hundreds of thousands of rows in this data set and also problem set 7, where we'll look at the movie side of things and not just the TV shows. So what is the schema that we have created for you from IMDb's actual real world data? One, there's a table called shows. And notice we've just added white space by hitting enter a bunch of times to make it a little more stylistically readable. The shows table has an ID column, a title column, a year, and the total number of episodes for a given show. And the types of those columns are integer, text, numeric, and integer. So it turns out there's actually a few different data types that are worth being aware of when it comes to creating tables themselves. In fact, in SQLite, there's 5 data types, and only 5, fortunately, one of which is indeed integer, negative or positive, numeric, which is kind of a catch-all for dates and times, things that are kind of numeric but are not just integers and not just real numbers, for instance. Real number is what we've generally thought of as float up until now. Text, of course, is just text, but notice that you don't have to worry about how big it is. Like in Python, it will size to fit. And then there's blob, which is binary large object, which is for just like raw zeros and ones, like for files or things like that. But we'll generally use the other 4 of these. And so indeed, when we imported this data for you, we decided that every show would be given an ID, which is just an integer. Every show has, of course, a title, which should not be null. Otherwise, why is it in the database? Every show has a year, which is numeric, according to that definition a moment ago. And the total number of episodes for a show is going to be an integer. What now is with these primary keys that we mentioned earlier, too? A primary key is the column that uniquely identifies all of the data. In our case, with the favorites, I automatically gave each of your submissions a unique ID so that even if 2 or more of you typed in the office, your submission still had a unique identifier, a number, that allowed me to then correlate it with your genres, just as we saw a moment ago. In this version of IMDb's, there's also genres, but they don't come from us. They come from imdb.com. And so a genre has a show ID and a genre, just like our database, but these are real-world genres with a bit more filtration. Notice, though, just like my version, there's a foreign key. A foreign key is the appearance of another table's primary key in its own table. So when you have a table like genres, which is somehow cross-referencing the original shows table, if shows have a primary key called ID, and those same numbers appear in the genres table under the column called show ID, by definition, show ID is a foreign key. It's the same numbers, but it's foreign in the sense that the number is being used in this table, even though it's officially defined primarily in this other table. This is what we mean by relational databases. You have multiple tables with some column in common, numbers typically, and those numbers allow you to line the two tables up in such a way that you can reconnect the shows with their genres, just like we did with our smaller data set a moment ago. This logic is extended further. Notice that the IMDb database we've created for you has a stars table, like TV show stars, the actors therein. And that table, interestingly, has no mention of people and no mention of shows per se. It only has a column called show ID, which is an integer, and a person ID, which is an integer. Meanwhile, if we scroll down to the bottom, you will see a table called people. And we have decided in IMDb's world that every person in the TV show world will have a unique identifier that's a number, a name that's text, a birth date, which is numeric, and then again specifying that ID is going to be their primary key. So what's going on here? Well, it turns out that TV stars and writers are both types of people. So using this relational database, notice the road we're going down. We're sort of factoring out commonalities. And if a person can be different things in life, well, we're defining them first and foremost as people. And then notice these two tables are almost the same. The stars table has a show ID, which is a number, and a person ID, which is a number, which allows us via this middleman table, if you will, to link people with TV shows. Similarly, the writers table allows us to connect shows with people too, by just recording those numbers. So if we go into this data set, let's do the following. Let's do select star from people, semicolon. So a huge amount of data is coming back, right? This is hundreds of thousands of rows now based on the ID numbers alone. So this is a real world data now flying across the screen. There's a lot of people in the TV show business, not just actors and writers, but others as well. It's still going. There's a lot of data there. So my God, like if you had to do anything manually in this data set, it's probably not going to work out very well. And actually, we're up to, what, 1 million people in this data set plus, which would mean this probably isn't even going to open very well in Excel or Google Spreadsheets or Apple Numbers. SQL probably is the better approach here. Let's search for someone specific, like select star from people where name equals like Steve Carell, for instance, sticking with comedies. All right, so there's Steve Carell. He is person number 136,797, born in 1962. And that's as much data as we have on Steve Carell here. How do we figure out what shows, for instance, he's in? Well, let's see. Select star from shows, semicolon. There's a crazy number of shows out there in the IMDb database. And you can see it here again flying across the screen. Feels like we're going to have to employ some techniques in order to get at all of Steve Carell's shows. So how are we going to do that? Well, God, this is a lot of data here. And in fact, yeah, we have, what, 15 million shows plus in this data set too. So doing things efficiently is now going to start to matter. So let's actually do this. Let me select a specific show. Select star from shows where title equals, quote unquote, The Office. And there presumably shouldn't be typos in this data because it comes from the real website, imdb.com. Let's get back to show. Turns out there's been a lot of The Offices out in the world. The one that started in 2005 is the one that we want, presumably, the most popular with 188 episodes. How can we get just that? Maybe we could do like and year equals, how about 2005? All right, so now we've got back just the ID of the office that we care about. And let's do this too. Let me turn on a timer within SQLite just to get a sense of running time now. Let me do that again. Select star from shows where title equals The Office and year equals 2005. And let's keep it simple. Let's just do titles for now. Enter. All right, so not terribly long. It found it pretty fast, but it looks like it took how much real time? 0.02 seconds. Not bad for just a title, but just to plant a seed, it turns out that we can probably speed even this up. Let me do this. Let me create something called an index, which is another use of the C in CRUD for creating something. And I'm going to call this like title index. And I'm going to create it on the shows table, specifically on the title column. And we'll see in a moment what this is going to do for me. Enter. Took a moment, like 0.349 seconds, to create something called an index. But now watch if I select star from shows, searching for the office again. Previously, it took me 0.021 seconds. Not bad. But now, wow, like literally no time at all, or so low that it wasn't really measurable. And I'll do it again just to get a sense of things. Still quite low. Now, even though 0.021 seconds, not crazy long, imagine now having a lot of data, a lot of users running a real website, a real mobile app. Every millisecond we can start to shave off is going to be compelling. So what is it we just did? Well, we actually just created something called an index. And this is a nice way to tie in now some of our week 5 discussion of data structures and our week 3 discussion of running times. An index in a database is some kind of fancy data structure that allows the database to do better than linear search. I mean, literally, as you just saw, these tables are crazy long or tall right now. Very linear, that is. And so when I first searched for the office, it was literally doing linear search, top to bottom, looking at as many as, like, what, 1 million plus rows. That's relatively slow. I mean, it's not that slow, 0.021 seconds, but that's relatively slow just theoretically, algorithmically, doing anything linearly. But if you instead create an index using syntax like this, which I just did, creating an index on the title column of the shows table, that's like giving the database a clue in advance, saying, hey, I know I'm going to search on this column in this table a lot. Do something with data structures to speed things up. And so if you think back to our discussion of data structures, maybe it's using a tree, maybe it's using a trie or a hash table, some fancier two-dimensional data structure is generally going to lift the data up, creating maybe a tree structure, so it's just much faster to find data, especially if it's sorting it now based on title and not just storing it in one long list. And in fact, in the world of relational databases, the type of structure that's often used in a database is something called a B tree. It's not a binary tree, different use of the letter B, but it looks a little something like the trees we've seen. It's not binary because some of the nodes might have more than 2 children or fewer, but it's a very wide but relatively shallow tree. It's not very tall. And the upside of that is that if your data is stored in this tree, the database can find it more quickly. And the reason it took like half a second, a third of a second to build the index is because SQLite needed to take some non-zero amount of time to just build up this tree in memory. And it has algorithms for doing so based on like alphabetization or other techniques. But you spend a bit of time up front, a third of a second, and then thereafter, wow, like every subsequent query, if I keep doing it again and again, is going to be crazy low, 0.000, maybe 0.001, but an order of magnitude, a factor of 10 or 100 faster than it previously was earlier. So we have these indexes, which allow us to get at data faster. But what if we want to actually get data that's now across these multiple tables? How can we do that? And how might these indices or indexes help further? Well, it turns out there is a way that we've seen already indirectly to join 2 tables together. Previously, when I selected the ID of the office and then I searched for it in the other table using select and a nested query, I was kind of joining 2 tables together. And it turns out there's a couple of ways to do this. Let's go ahead now and, for instance, find all of like Steve Carell's TV shows, not just The Office, but all of them too. Unfortunately, if we look at our schema, shows up here have no mention of shows over here has no mention of the TV stars in them. And people have no mention of shows. We somehow need to use this table here to connect the 2. And this is called a join table in the sense that using 2 integer columns, it kind of joins the 2 tables together logically. And so if you're kind of savvy enough with SQL, you can kind of do what I did with my hands earlier and like recombine tables by using these common IDs, these integers together. So let me do this. Let me go ahead and figure out step by step Steve Carell shows. So how am I going to do this? Well, if I select star from people where name equals Steve Carell. Fortunately, there's only one of them. So this gives me back his name. His ID, and his birth year. But it's really only his ID that I care about. Why? Because in order to get back his shows, I need to link person ID with show ID, right? So I need to know his ID number. So what could I do with this? Well, remember the schema and the stars table. I've just gotten from the people table Steve Carell's ID. I bet by transitivity, I could now use his person ID, his ID, to get back all of his show IDs. And then once I've got all of his show IDs, I can take it one step further and get back all of his show's titles. So the answer is actually English words and not just random, seemingly integers. So let me go ahead and do this. Let me again get Steve Carell's ID number, but not star. Star represents everything. It's a wildcard character in SQL. Let me just select the ID of Steve Carell. And that gives me back 136,797. And it's only giving me back one value. The thing called ID is just the column heading up above. Now, suppose I want to select all of the show IDs that Steve Carell is affiliated with. Let me select show ID from stars, where the person ID in stars happens to equal Steve Carell's ID. So again, I'm sort of building up my answer in reverse and taking these baby steps. On the right, in parentheses, I'm getting Steve Carell's ID. On the left, I am now selecting all of the show IDs that have some connection with that person ID in the stars table. This answer, too, is not going to be that illuminating. It's just a whole bunch of integers that have no meaning to me, the human. But let's take this one step further. And even though my code is getting long, I could hit enter and kind of format it nicely, especially if I were doing this in a code file. But I'm just doing it interactively for now. Let's now select all of the titles from the shows table where the ID of the show is in this following previous query. So again, the query is getting long, but notice it's the third and last step. Select title from the shows table where the ID of the show is in the list of all of the show IDs that came back from the stars table searching for Steve Carell's person ID. How did we get that person ID? Let me scroll to the end. Well, I selected in my innermost parentheses Steve Carell's own ID. So now when I hit enter, voila, I get all of Steve Carell's TV shows up until now. And if I want to tidy this up further, I can use the same tricks as before, order by title, semicolon. Now I've got it all alphabetized as before. So again, with SQL comes the ability to search. I mean, look how quickly we did this. 0.094 seconds to search across 3 different tables to get back this answer. But my data is now all kind of neatly designed in individual tables, which is going to be important now that the data set is so large. But let me take this one step further. Let me go ahead and do this. Let me go ahead and point out that with this query, notice that I'm searching on let's say I'm searching on a person ID here. And at the end here, I'm searching on a name column here. So let me actually go ahead and do this. Let me go ahead and see if we can't speed this up. This query at the moment takes 0.092 seconds. Let's see if we can't speed this up further by just quickly creating a few more of those B trees in the database's memory. Create an index called person index. And I'm going to do this on the stars table. On the person ID column. Enter. It's taking a moment. That's almost a full second because that's a big table. Let's create another index called show index on the stars table. Why? Because I want to search by the show ID also. That was part of my big query. Takes a moment, OK, just more than about 2/3 of a second. Now let's create one last one, another index called name index, but I could call these things anything I want, on the people table. Why? Because I'm also searching on the name column. So in short, I'm creating indexes on each of the columns that are somehow involved in my search query, going from one table to the other. Now let's go back to the previous query, which recall took I think I erased it, 0.091. All right, well, it was roughly this order of magnitude. We're not seeing the data now. But let me go ahead and run my original big query once, and boom, we're down to almost nothing. So again, creating these indexes in memory has the effect of rapidly speeding up our computation time. Now, if you've ever used, for instance, the My.Harvard course shopping tool here on campus or Yale's analog, you might wonder, like, why is the thing so slow? This could be one of the reasons why large data sets with thousands of rows, thousands of courses tend to be slow if, and I'm only conjecturing, if the database isn't properly indexed. If you're building your own web application and you're finding that users are waiting and waiting and things are spinning and spinning, what might be among the problems? Well, it could absolutely just be bad algorithms and bad code that you wrote. Or it might be that you haven't thought about, well, what columns should be optimized for searches and filtration like I've done here in order to speed up subsequent queries. Again, from the outside in, we can only conjecture. But ultimately, this is just one of the things that explains performance problems as well. All right, let's point out just a couple of final syntactic things, and then we'll consider, bigger picture, some problems that might arise in this world. If these nested queries start to get a little much, there are other ways, just so you've seen it, that you can execute similar logic in SQL. For instance, if I know in advance that I want to connect Steve Carell to his show IDs and to their titles, we can do something more like this. Select title from the people table joined with the stars table on people ID equals stars.person ID. So what am I doing? New syntax. And again, this is not something you'll have to memorize or ingrain right away. But just so you've seen other approaches, select title from people join stars. This is an explicit way to say, take the people table in one hand, the stars table in the other hand, and somehow join them, as I keep doing with my fingertips here. How to join them? Join them so that the people, the ID column in the people table, lines up with the person ID in the stars table. But that's not quite everything. I could also say join further on the shows table where the stars show ID equals the shows ID column. So what am I doing here? That's saying go further and join the people table, the stars table with the shows table, joining the show ID column with the ID column. Again, this starts to get a little messy to think about. But now I can just say where name equals quote unquote Steve Carell. I can do in one query what previously took me 3 nested queries and get back the same answers. And I can still add in my order by title to get back the result. And if I do this a little more neatly, let me type this out a little differently. Let me type this out by adding a new line. Can't do that here. I'm going to leave it alone for now. We can type it on multiple lines in other contexts. And let me do one last thing. Do I want to show that? I'm going to show it, but this is not something you should ingrain just yet either. Select title from people, stars, and shows. If you know in advance that you want to do something with all 3 tables, you can just enumerate them. One table name after the other. And then you can say where people.id equals stars.personid. And now I'm hitting enter so that it formats a little more readably on my screen. And stars.showID equals shows.id. And lastly, name equals Steve Carell. In short, you specify that you want to select data from all 3 of these tables, and then you tell the database how to combine foreign keys with primary keys. That is, the columns that have those integers in common. If I hit enter now, I get these same exact results, ever more so if I also add in an order by title. Oops. That's why I didn't want to do this earlier. I'd have to go back through my history multiple times to actually get back the multi-line query this time. All right, that was a lot all at once. But this is only to say that even as we sort of make the design of the data more sophisticated and we put some of it over here, some of it over here, some of it over here so as to avoid duplication of data, weird hacks like putting commas in the data, we can still get back all of the answers that we might want across these several tables. And using indexes, we can significantly speed up these processes so as to handle 10 times as many, 100 times as many users on the same actual database. There is going to be a downside. And thinking back to our discussion of algorithms and data structures in past weeks, what might be a downside of creating these indexes? Because as of now, I created 4 separate indexes on the name column, the title column, and some other columns too. Like, why wouldn't I just go ahead and index everything if it's clearly speeding things up? Memory. So space. Anytime you're starting to benefit time-wise in computer science, odds are you're sacrificing space or vice versa. And probably indexing absolutely everything is a little dumb because you're going to waste way more space than you might actually need. So figuring out where the right inflection point is part of the process of designing and just getting better at these things. Now, unfortunately, a whole lot of things can go wrong in this world, and they continue to in the real world with people using SQL databases. In fact, here on out, if you're reading something technical about SQL databases and websites being hacked in some form and passwords leaking out, unfortunately, all too often it is because of what are called SQL injection attacks. And just to give you a sense now to counterbalance, maybe any enthusiasm for like, whoo, that was neat how we can do things so quickly. With great power comes responsibility in this world too. And so many people introduce bugs into their code by not quite appreciating what it is that, how it is the data is getting into your application. So what do I mean by that? Here, for instance, is a typical login screen for Yale. And here's the analog for Harvard, where you're prompted, like every day probably, for your username and your password, your email address and your password here. Suppose, though, that behind this login page, whether Harvard's or Yale's, there's some website. And that website is using SQL underneath the hood to store all of the Harvard or Yale people's usernames, passwords, ID numbers, courses, transcript, all of that stuff. So there's a SQL database underneath the website. Well, what might go wrong with this process? Unfortunately, there's some special syntax in SQL, just like there is in C and Python. For instance, there are comments in SQL too. If you do 2 hyphens, dash, dash, that's a comment in SQL. And if you, the programmer, aren't sufficiently distrustful of your users such that you defend against potentially adversarial attacks, you might do something like this. Suppose that I, somewhat maliciously or curiously, log in by typing my username, mailin@harvard.edu, and then maybe a single quote and a dash dash. Why? Because I'm trying to suss out if there is a vulnerability here to a SQL injection attack. Do not do this in general, but if I were the owner of the website trying to see if I've made any mistake, I might try using potentially dangerous characters in my input. Dangerous how? Because single quote is used for quoting things in SQL, as we've seen, single quotes or double quotes. Dash dash, I claim now, is used for commenting. But let's now imagine what the code underneath the hood might be for something like Yale's login or Harvard's login. What if it's code that looks like this? So let me read it from left to right. Suppose that they are using something like CS50's own execute function. And they've got some SQL typed into the website that says select star from users, where username equals this and password equals that. And they're plugging in username and password. So what am I doing here? Well, when the user types their username, password, hits enter, I probably want to select that user from my database to see if the username and passwords match. So the underlying SQL might be select star from users, where username equals question mark and password equals question mark. Users is the table. One column is username. One column is password. All right. And if we get back one row, presumably, mailin@harvard.edu exists with that password, we should let him proceed from there on out. So that's like some pseudocode, if you will, for this scenario. What if, though, this code is not as well written as it currently is and isn't using question marks? So the question mark syntax is a fairly common SQL thing, where the question marks are used as placeholders, just like in printf %s was. But this function, db.execute from CS50's library and third-party libraries as well, is also doing some good stuff with these question marks and defending against the following attack. Suppose that you were not using a third-party library like ours, and you were just manually constructing your SQL queries like this. You were to do something like this instead, using an F string in Python. You're comfortable with format strings now. You've gotten into the habit of using curly braces and plugging in values. Suppose that you, the aspiring programmer, is just using techniques that you've been taught. So you have an F string with select star from users, where username equals quote unquote username in curly braces, and password equals quote unquote password in curly braces, right? Like as of 2 weeks ago, this was perfectly legitimate technique in Python to plug in values into a string. But notice, if you are using single quotes yourself and the user has typed in single quotes to their input, what could go wrong here? Like, where are we going with this? If you're just blindly plugging user input into your own prepared string of text. Yeah. Yeah, worst case, they could insert what is actually SQL code into your database as follows. Generally speaking, if you're using special syntax like single quotes to surround the user's input, you'd better hope that they don't have an apostrophe in their name. Or you better hope that they don't type a single quote as well, because what if their single quote finishes your single quote instead, and then the rest of this is somehow ignored? Well, let's consider how this might happen. Let me go ahead and here, it's got a little blurry here, but let me plug in here. Wow, that looks awful. Let me fix the red. Just change this to white so it's more readable. What happens if the user does this instead? They type in, like I did into the screenshot, malin@harvard.edu, single quote, dash, dash. What has just happened logically, even though we've only just begun with SQL today? Well, select star from users, where username equals malin@harvard.edu, end quote. What's bad about the rest of this? Dash dash I claim means a comment, which means my color coding is going to be a little blurry again. But everything after the dash dash is just ignored. The logic then of this SQL query then is to just say select malin@harvard.edu from the database, not even checking the password anymore. Therefore, you will get back at least one row. So length of rows will equal 1. And so presumably the rest of the pseudocode logs the user in, gives them access to my .harvard account or whatever it is, and they've pretended to be me. Simply by using a single quote and a dash dash in the username field. Again, please don't go start doing this later today on Harvard, Yale, or other websites, but it could be as simple as that. Why? Because the programmer practiced what they were taught, which was just to use curly braces to plug in f-strings values. But if you don't understand how the user's input is going to be used, and if you don't distrust your users fundamentally, for every good person out there, there's going to be, unfortunately, some adversary who just wants to try to find fault in your code or hack into your data set. This is what's known as a SQL injection attack, because the user can type something that happens to be or look like SQL and trick your database into doing something it didn't intend to, like, for instance, logging the user in. Worst case, they could even do something else. Maybe the user types a semicolon, then the word drop or the word update. You could imagine doing semicolon update table grades, where name equals Malin and set the grade equal to A instead of B or something like that. The ability to inject SQL into the database means you can do anything you want with the data set, either constructively or, worse, destructively. All right, and now, just a quick little cartoon that should now make sense. OK, to like one of us, two of us. Awkwardly, somewhat funny. All right, so let's move on to one last condition. There's one other problem that can go awry here. Oh, and I should explain this. So this is an allusion to the son Robert having typed in semicolon, the word drop, table, students, and doing some of the same technique. This is sort of humor that only CS people would understand, because it's the mom realizing, oh, her son's doing a SQL injection attack onto the database. Less funny when you explain it. But if once you notice the syntax, that's all this is an allusion to. All right, so one final threat, now that you are graduating to the world of proper databases and away from CSV files alone. Things can go wrong when using databases, and honestly, even using CSV files if you have multiple users. And thus far, you and I have had the luxury in almost every program we've written that it's just me using my code. It's just you using your code. And even if your teaching fellow or TA is using it, probably not at the same time. But the world gets interesting if you start putting your code on phones, on websites, such that now you might have two users literally trying to log in at the same time, literally clicking a button at the same or nearly the same time. What happens then if a computer is trying to handle requests from two different people at once, as might happen all the time on a website? You might get what are called race conditions. And this is a problem in computing in general, not just with SQL, not just with Python, really just any time you have shared data, like a database, as follows. This apparently is one of the most liked Instagram posts ever. It is literally just a picture of an egg. Has anyone clicked on this egg? It's like a couple. OK, wow. All right, so yes. So go search for this photo if you'd like to add to the likes on Instagram. The account is World Record Egg. This is just a screenshot of Instagram of that picture of an egg. If you're in the habit of using Instagram or like any social media site, there's some equivalent of a like button or a heart button these days. And that's actually a really hard problem. Such a simple idea to like count the number of likes something has. But that means someone has to click on it. Your code has to detect the click. Your code has to update the database and then do it again and again, even if multiple people, or perhaps right now, clicking on that same egg. And unfortunately, bad things can happen if two people try to do something at the same time on a computer. How might this happen? So here's some more code, sort of half pseudocode, half Python code here as follows. Suppose that what happens when you, literally right now maybe, click on the like button on the Instagram post, suppose that code like the following is executed on Facebook servers. db.execute of select likes from posts where ID equals question mark. All right, so what am I assuming here? I'm assuming that that photograph has a unique ID. It's like some big integer, whatever it was randomly assigned. I'm assuming that when you click on the heart, the unique ID is somehow sent to Instagram server so that their code can call it ID. And I'm assuming that Instagram's using a SQL database and selecting from a posts table the current number of likes of that egg for that given ID number. Why? Because I need to know how many likes it already has if I want to add one to it and then update the database, right? I need to select the data, then I need to update the data here. All right, so in some Python code here, let's store in a variable called likes whatever comes back in the first row from the likes column. Again, this is new syntax specific to our library, but a common way of getting back first row and the column called likes therein. So at this point in the story, likes is storing the total number of likes in the millions or whatever it is of that particular egg. Then I do this. Execute, update, posts, set the number of likes equal to this value, where the ID of the post equals this value. What do I want to update the likes to? Whatever likes currently is plus 1, and then plugging in the ID. So a simple idea, right? I'm checking the value of the likes, and maybe it's 10. I'm changing 10 to 11 and then updating the table. But a problem can arise if two people have clicked on that egg at roughly the same time, or literally the same time. Why is that? Well, in the world of databases and servers, and the Instagrams of the world have thousands of physical servers nowadays, so they can support millions, billions even, of users nowadays. What can go wrong? Well, typically, code like this is not what we'll call atomic. To be atomic means that it all executes together or not at all. Rather, code typically is executed, as you might imagine, line by line. And if your code is running on a server that multiple people have access to, which is absolutely the case for an app like Instagram, if you and I click on the heart at roughly the same time, for efficiency, the computer, the server owned by Instagram, might execute this line of code for me, then it might execute this line of code for you, then this line of code for me, then this line of code for you, then this line of code for me, then this line of code for you. That is to say, our queries kind of might get intermingled chronologically, because it'd be a little obnoxious if when you're using Instagram, I'm blocked out while you're interacting with the site. It'd be a lot nicer for efficiency and fairness if somehow they do a little bit of work for me, a little bit of work for you, and back and forth equitably on the server. So that's what typically happens by default. These lines of code get executed independently, and they can happen in alternating order with other users. You can get them sort of combined like this. Same order top to bottom, but other things might happen in between. So suppose that the number of likes at the very beginning was like 10, and suppose that Carter and I both click on that egg at roughly the same time. And suppose this line of code gets executed for me, and that gives me a value in likes ultimately of 10. Suppose then that the computer takes a break from dealing with my request, does the same code for Carter, and gets back what value for the current number of likes? Also 10 for Carter, because mine has not been recorded yet. At this point in the story, somewhere in the computer's memory, there's a likes variable for me, storing 10. There's a likes variable storing 10 for Carter. Then this line of code executes for me. It updates the database to be likes plus 1, which stores 11 in the database. Then Carter's code is executed, updating the same row in the database to 11, unfortunately, because his value of likes happened to be the same value of mine. And so the metaphor here, that if we had a refrigerator on stage, we would actually act out, is something that was taught to me years ago in an operating systems class, whereby the kind of most similar analog in the real world would be if you've got a mini fridge in your dorm room, and you and a roommate one of you and your roommates comes home, opens the fridge, and realizes oh, we're out of milk, was how the story went in my day. So you close the refrigerator and you walk across the street, go to CVS, and get in line to buy some milk. Meanwhile, your roommate comes home. They, too, inspect the state of your refrigerator, aka a variable, open the door and realizes, oh, we're out of milk. I'll go get more milk. Close the fridge, go across the street, and head to maybe a different store, or the line is long enough that you don't see each other at the store. So long story short, you both eventually get home, open the door, and damn it, now there's milk from your other roommate there because you both made a decision on this based on the state of a variable that you independently examined, and you didn't somehow communicate. Now, in the real world, this is absolutely solvable. Like, how would you fix this or avoid this problem in the real world? Literally, own roommate, own fridge. Perfect. Let them know. So somehow communicate. And in fact, the terminology here would be multiple threads can somehow intercommunicate by having shared state, like the iMessage thread on your phone. You could leave a note. You could more dramatically lock the refrigerator somehow, thereby making the milk purchasing process atomic. The fundamental problem is that for efficiency, again, computers tend to intermingle logic that needs to happen when it's happening across multiple users, just for fairness' sake, for scheduling's sake. You need to make sure that all three of these lines of code execute for me, and then for Carter, and then for you, if you want to ensure that this count is correct. And for years, when social media was first getting off the ground, this was a super hard problem. Twitter used to go down all of the time, and tweets and retweets were a thing that were similarly happening with a very high frequency. These are hard problems to solve, and thankfully, there are solutions. And we won't get into the weeds of how you might use these things, but know that there are solutions in the form of things called locks, which I use that word deliberately with the fridge. Software locks can allow you to protect a variable so no one else can look at it until you're done with it. There are things called transactions, which allow you to do the equivalent of sending a message to or really locking out your roommate from accessing that same variable too, but for slightly less amount of time. There are solutions to these problems. So for instance, in Python, the same code now in green might look a little something like this. When you know that something has to happen all at once, all together, you first begin a transaction and you do your thing, and then you commit the transaction at the very end. Here too, though, there's going to be a downside. Typically, the more you use transactions in this way, the higher the probabilities that you're going to box someone out or make Carter's request a little slower. Why? Because we can't interact at the same time. Or you might make his request fail if he tries to update something that's already been updated. So you generally want to have as few lines of code together in between these transactions so that you get in and you get out. And you go to CVS and you get back really fast so as to not cause these kind of performance things. So things indeed escalated quickly today. The original goal was just to solve problems using a different language more effectively than Python. But as soon as you have these more powerful techniques, a whole new set of problems arises. It takes practice to get comfortable with. But ultimately, this is all leading us toward the introduction next week of web programming with HTML, CSS, and some JavaScript. The week after, bringing Python and SQL back into the mix so that by term's end, we've really now used all of these different languages for what they're best at. And over the next few weeks, the goal is to make sure you're understanding and comfortable with what things each of these things is good and bad for. Let's go ahead and wrap here. I'll stick around for questions. We'll see you next time. This is CS50, and this is already week 8. And if we think back to like the past several weeks now, recall that things started pretty interestingly, pretty interactively in like week 0. when we were using Scratch, because with Scratch we had a GUI, a graphical user interface. So even as we explored variables and loops and conditionals and all of that, you had kind of a fun environment in which to express those ideas. And then in week 1, we sort of took a lot of that away when we introduced C and a terminal window and a command line, because now all of your programs became very textual, very keyboard based, and gone was the mouse, the animations, the menus, and so forth. And so now, fast forward to week 8, we're going to bring those kinds of user interface, UI elements back in the form of web programming. And this goes beyond just laying out websites. This will, to this week and next week, combine elements of the back-end server stuff that we've been doing for the past several weeks, using Python, using SQL, and now introducing a couple of other languages on the so-called client side, on your own Mac, your own PC, your own phone, that's going to talk to those back-end services. So indeed, at this end of CS50, does everything rather come together into a user interface that's just super familiar. All of us are on our phones, desktops, laptops every day, and increasingly, even the mobile apps that you all are using are implemented not necessarily in languages like Swift or Java, if you're familiar with those, but with languages called HTML, CSS, and JavaScript, which we'll focus on here today. But before we do that, let's kind of provide a foundation on which these apps can run, because indeed, we'll start to look underneath the hood of how the internet itself works, albeit quickly, so that we have kind of a mental model for where all of this code is running, how you can troubleshoot issues, and how really ultimately after CS50 you can learn by just poking around other actual websites. So the internet, we're all on it, literally right now. What is it, in your own words? What is the internet? It's this utility nowadays that we all rather take for granted. How would you describe it? OK, big storage. And indeed, that's how the cloud is described, which is kind of an abstraction, if you will, for a whole lot of wires and cables and hardware. And the internet, other formulations of the term. How else? OK, a bunch of data that we can all reach by way of being interconnected somehow with wires or wirelessly. And so really, the internet, too, is a hardware thing. There's a whole lot of servers out there that are somehow interconnected via physical cables, via internet service providers, via wireless connectivity, and the like. And once you start to have networks of networks of networks, you get the internet. Indeed, Harvard has its own network, and Yale has its own network, and your own home probably has its own network. But once you start connecting those networks, do you get the interconnected network, that is, the internet as we now know it. So there's this whole alphabet soup that goes with the internet, some of whose acronyms and terms you've probably seen before, but let's at least peel back some of those layers and consider what some of the building blocks are. So here's a picture of the internet before it was known as the internet back in 1969, when it was something called ARPANET from the Advanced Research Projects Agency. And the intent originally was just to interconnect a few universities here in Utah and California, literally servers or computers on each of those in each of those areas somehow interconnected with wires so that people could start to share data. A year later, it expanded to include MIT and Harvard and others. And now fast forward to today, you have a huge number of systems around the world that are on this same network. And in fact, if I just pull up a web page here that's sort of constantly changing, a visualization of the internet as it might now be today, this here, in the abstract, all of these lines and interconnections represent just how interconnected the world is today. And it just means that there's all the more servers, all the more cabling, all of the more hardware giving us this underlying infrastructure. But if we focus really on just these nodes, these individual dots, whether back in 1970 or now in 2021, each of these dots you can think of as, yes, a server, but a certain type of server, namely known as a router. And a router, as the name implies, just routes data left to right, top to bottom, from one point to another. And so there's all these servers here on campus at Harvard, on Yale's campus, in Comcast's network, Verizon's network, your own home network. You have your own routers out there whose purpose in life is to take in data and then decide, should I send it this way or this way or this way, so to speak, assuming there are multiple options with multiple cables. You in your home probably have just one cable coming in or going out, but certainly if you're a place like Harvard or Yale or Comcast or the like, there's probably a whole bunch of interconnections that the data can then travel across ultimately. So how do we get data among these routers? For instance, if you want to send an email to someone at Stanford in California from here on the East Coast, or if you want to visit www.stanford.edu, how does your laptop, your phone, your desktop actually get data from point A to point B? Well, essentially, your laptop or phone knows when it boots up at the beginning of the day what the local router is, what the address of that local router is. So if you want to send an email from like my laptop over here, my laptop's essentially going to hand it to the nearest Harvard router. And then from there, I don't know, I don't care how it gets the rest of the distance, but hopefully within some small number of steps later, Harvard's router is going to send it to maybe Boston's router, is going to send it to California's router, is going to send it to Stanford's router until finally it reaches Stanford's email server. And we can depict this actually, how about a bit playfully. Thankfully, the course's staff kindly volunteered to create a visualization for this using a familiar technology. So here we have some of our TFs and TAs and CAs present and past. Let me go ahead and full screen this window here. Give me just a moment to pull it up on my screen here. And we'll consider what happens if we want to send a packet of information from one person or router, namely Phyllis in this case in the bottom right-hand corner, up to Brian in this case in the top left-hand corner. So each of the staff members here represents exactly one of these routers on the internet. The applause is appreciated. It actually took us a significant number of attempts to get that ultimately right. So what was it the staff were all passing here? Here we have just physically what it was the staff were passing around. So Phyllis started with an envelope inside of which was that email, presumably on the East Coast. And she wanted to send it to Brian on the West Coast, top left-hand corner. And so she had all of these different options, different connections between her and point B, namely Brian. She could go up, down in her case. And then each of those subsequent routers could go up, down, left, or right until it finally reaches Brian. And long story short, there's algorithms that figure out how you decide to send a packet up, down, left, or right, so to speak. But they do so by taking an input. And in the form of input is this envelope. And there's at least a couple of things on the outside of this, because all of these routers, and in turn all of our Macs and PCs and phones these days, speak something called TCP/IP. A set of acronyms you've probably seen somewhere on your phone, your Mac, or PC in print somewhere, which refers to two protocols, two conventions that computers use to intercommunicate these days. Now, what's a protocol? A protocol is like a set of rules that you behave. In healthier times, I might extend my hand, and someone like Carter might extend his hand, thereby interacting with me based on a human protocol of like literally physically shaking hands. Nowadays, we have mask protocols, whereby what you need to do is wear a mask indoors, but that too is just a set of rules that we all follow and adhere to that's somewhere standardized and documented. So computers use protocols all the time to govern how they are sending information and receiving information. And TCP and IP are two such protocols that standardize this as follows. What TCP/IP tells someone like Phyllis to do is, if she wants to send an email to Brian, is put the email in a virtual envelope, so to speak. But on the outside of that virtual envelope, put Brian's unique address. And I'll describe this as destination on the middle of the envelope, just like in our human world, you would write the destination address on the envelope. And then she's going to put her own source address in the top left-hand corner, just like you, the sender, would put your own source address in the human world. But instead of these addresses being like something Kirkland Street, Cambridge, Massachusetts, 02138 USA, you probably know that computers on the internet have unique addresses of their own known as IP addresses. And an IP address is just a numeric identifier on the internet that allows computers, like Phyllis and Brian, to address these envelopes to and from each other. And you've probably seen the format at some point. Typically, the format of IP addresses is something, dot something, dot something, dot something. Each of those somethings, represented here with a hash symbol, is a number from 0 through 255. And based on that little hint, if each of these hashes represents a number from 0 to 255, each of those hashes is represented with how many bytes or bits? 8 bits, or 1 byte, which is to say, we can extrapolate from there, an IP address must use 32 bits, or 4 bytes, if we rewind now to some of the primitives we looked at in week 0. And what that means is, at least at a glance, it looks like we have 4 billion some odd IP addresses available to us. Now, unfortunately, there's a huge number of humans in the world these days, many of whom have multiple devices, certainly in places like this, where you have a laptop and a phone, and you have other Internet of Things type devices, all of which need need to be addressed. So there's another type of IP address that's starting to be used more commonly. This is version 4 of IP. There's also version 6, which instead of 32 bits, uses 128 bits, which gives us a crazy number of possible addresses for computers, so we can at least handle all of the additional devices we now have today. So this is to say, what ultimately is going on this envelope is the destination address, that is Brian's IP address, and the source address, that is Phyllis's IP address, so that this packet can go from point A to point B, and if need be, back by just flipping the source and the destination. But on the internet, you presumably know that there's not just email servers. There's web servers, there's chat servers, video servers, game servers. Like, there's all of these different functions on the internet nowadays. And so when Brian receives that envelope, how does he know it's an email versus a web page versus a Skype call versus something else altogether? Well, it turns out that we can look at the other part of this acronym, the TCP, in TCP/IP. And what TCP allows us to do, for instance, is specify a couple of things. One, the type of service whose data is in this envelope. That is, it does this with a numeric identifier. And I'm going to go ahead and write down a colon and the word port, P-O-R-T. And I'm going to write that in the source address too, colon and port. So technically now what's on this envelope is not just the addresses, but also a unique number that represents what kind of service is being sent from point A to point B, whether it's email or web traffic or Skype or something else. These numbers are standardized. And here are just two of the most common ones, not even in the context of email, but in the context of the web. Port 80 is typically used whenever an envelope contains a web page or a request, therefore. Or the number 443 when that request is actually encrypted using that thing you probably know in URLs known as HTTPS, where the S literally means secure. More on what the HTTP means later. If it's email, the number might be 25 or 465 or 587. Like, these are the kinds of things you Google if you ultimately care about. But if you've ever had to configure like Outlook or even Gmail to talk to another account, you might very well have seen these numbers by typing in something like smtp.gmail.com and then a number, which is only to say these numbers are omnipresent, but they're typically not things you and I have to care about because servers and computers nowadays automate much of this process. But that's all it takes ultimately for Phyllis to get this message to Brian. But what if it's a really big message? If it's a short email, it might fit perfectly in one single packet, so to speak. But suppose that Phyllis wants to send Brian a picture of a cat like this, or worse, a video of a cat. It would be kind of inequitable if no one else could do anything on the internet just because Phyllis wants to send Brian a really big picture, a really big video of a cat. It would be nice if we could kind of timeshare the interconnections across these routers so that we can give a little bit of time to Phyllis, a little bit of time to someone else, a little bit of time to someone else, so that eventually Phyllis's entire cat gets through the internet. But in terms of fairness, she doesn't monopolize the bandwidth of the network in question. And this then allows us to do one other feature of TCP/IP, which is fragmentation, where we can temporarily, and Phyllis's computer would do this automatically, fragment the big packet in question, or the big file in question, and then use not just a single envelope, but maybe a second, a third, and a fourth, or more. If we do that, though, we're probably going to need one other piece of information just logically on these envelopes. Like, if you were implementing this, chopping up this picture of a cat into 4 parts, like, intuitively, what might you want to put virtually on the outside of this envelope now? Yeah. The order of them somehow. So probably something like part 1 of 4, part 2 of 4, part 3 of 4, and so forth. So I'm going to write one more thing in like the memo line of the envelope here. I put some kind of sequence number that's just a little bit of a clue to Brian to know in what order to reassemble these things. And even more powerfully than that, this actually gives us this simple primitive of just using ints on these envelopes in these packets. If Brian receives envelopes like these, with numbers like these in the memo field, what other feature does TCP apparently enable Brian and Phyllis to implement? This is a bit subtle, but it's not just the ordering of the packets. What else might be useful about putting numbers on these things, might you think? What might be useful here? Yeah, back? If you missed something that was intended to be sent, if I heard that correct. So shorter answer, exactly, yes. So TCP, because of this simple little integer that we're including, can quote unquote guarantee delivery. Why? Because if Brian receives 1 out of 4, 2 out of 4, 4 out of 4, but not 3 out of 4, he now knows predictably that he needs to ask Phyllis somehow to resend that packet. And so this is why pretty much always, if you receive an email, you either receive the whole thing or nothing at all. Like sentences and words and paragraphs should never really be missing from an email. Or if you download a photograph on the web, it shouldn't just have a blank hole in the middle just because that packet of information happened to be lost. TCP, if it is the protocol being used to transmit data from point A to point B, ensures that it either all gets there or ultimately none of it at all. So this is an important property. But just as a teaser, there's other protocols out there. There's something called UDP, which is an alternative to TCP that doesn't guarantee delivery. And just as a taste of why you might ever not want to guarantee delivery, maybe you're watching like a streaming video, like a sports event online. You probably don't necessarily want the thing to buffer and buffer and buffer just because you have a slow connection, because you're going to start to miss things. And then you're going to be the only one in the world watching the game that ended 20 minutes ago when everyone else is sort of up to speed. Similarly for a voice call. It'd be really annoying if our voice is constantly buffered. So UDP might be a good protocol for making sure that even if the person on the other end sounds a little crappy, at least you can hear them. It's not pausing and resending, because that would really slow down that sort of human interaction. So in short, IP handles the addressing of these packets and standardizes numbers that every computer, your own included, gets. And TCP handles the standardization of like what services can be used between points A and point B. All right, this is great, but presumably when Phyllis sends a message to Brian, like she doesn't really know and probably shouldn't care what his IP address is, right? These days, it's like, I don't know most of the phone numbers that my friends have. I instead look them up in some way. And indeed, when you visit a website, what do you type in? It's typically not something, where each of those somethings is a number. What do you typically type in to a browser? So a domain name, right? Something like stanford.edu, harvard.edu, yale.edu, gmail.com, or any other such domain name. And so thankfully, there's another system on the internet, one more acronym for today, called DNS, Domain Name System. And pretty much every network on the internet, Harvard's, Yale's, Comcast's, your own home network, somewhere somehow has a DNS server. You probably didn't have to configure it yourself. Someone else did, your campus, your job, your internet service provider. But there's some server connected somehow to the network you're on via wires or wirelessly that just has a really big table in its memory, a big spreadsheet, if you will, or if you prefer, a hash table that has at least 2 columns of keys and values respectively, where on the left-hand side is what we'll call domain name, something like harvard.edu, yale.edu, and IP address on the right-hand side. That is to say, a DNS server's purpose in life is just to translate domain names to IP addresses, and vice versa if you want to go in the other direction. And technically, just to be precise, it translates fully qualified domain names to IP addresses. And we'll see what those are in just a moment. But again, all of this just kind of happens magically when you turn on your phone or your laptop today, because all of these things are pre-configured for us nowadays. So how can we actually start to see some of these things in action? Well, let's go ahead and poke around, for instance, at a couple of URLs here. Let's see what we can actually do now with these basic primitives. If we now have the ability to move data from point A to point B, and what can be in that envelope could be, yes, an email, but today onward, it's really going to be web content. There's going to be content that you're requesting, like give me today's homepage, and there's content you're sending, which would be the contents of that actual homepage. And so just to go one level deeper, now that we have these packets that are getting from point A to point B using TCP IP, let's put something specific inside of them. Not just an email and a bunch of text, but something called HTTP, which stands for Hypertext Transfer Protocol. You've seen this for decades now, probably, in the form of URLs, so much so that you probably don't even type it nowadays. Your browser just adds it for you automatically, and you just type in harvard.edu or yale.edu or the like. But HTTP is just a final protocol that we'll talk about here that just standardizes how web browsers and web servers intercommunicate. So this is a distinction now between the internet and the web. The internet is really like the low-level plumbing, all of the cables, all of the technology that just moves packets from left to right, right to left, top to bottom, that gets data from point A to point B. You can do anything you want on top of that internet nowadays, email and web and video and chat and gaming and all of that. So HTTP, or the web, is just one application that is conceptually on top of, built on top of the internet. Once you take for granted that there is an internet, you can do really interesting things with it, just like in our physical world. Once you have electricity, you can just assume you can do really interesting things with that too, without even knowing or caring how it works. But now that you'll be programming for the web, it's useful to understand how some of these things indeed work. So let's take a peek at the format of the things that go inside of these messages. These days, it's usually actually HTTPS that's in play, where again, the S just means secure. More on that later. But the HTTP is what standardizes what kinds of messages go inside of these envelopes. And wonderfully, it's just textual information typically. There's a simple text format that humans decided on years ago that goes inside of these envelopes that tells a browser how to request information from a server and how to respond from the server to that client with information. So here's, for instance, a canonical URL, https://www.example.com. What might you see at the end of this? You might sometimes see a slash. Browsers nowadays kind of simplify things and don't show it to you. But slash, as we'll see, just represents like the default folder, the root of the web server's hard drive, like whatever the base is of it. It's like C:\/ on Windows, or it's my computer on Mac OS. But a URL can have more than that. It can have /path, where path is just a word or multiple words that sort of describe a longer part of the URL. That path could actually be a specific file, we'll see, like something called file.html. More on HTML in just a bit. Or it can even be /folder, maybe with another slash. Or maybe it can be /folder/file.html. Now, these days, Safari and even Chrome to some extent and other browsers are in the habit of trying to hide more and more of these details from you and me. Ultimately, though, it'll be useful to understand what URLs you're at because it maps directly to the code that we're ultimately going to write. But this is only to say that all this stuff in yellow refers to, presumably, a specific file and or folder on the web server on which you're programming. All right, what's this? Example.com. This is the domain name as we described it earlier. Example.com is the so-called domain name. This whole thing, www.example.com, is the fully qualified domain name. And what the www is referring to is specifically the name of a specific server in that domain. So back in the day, there was a www.example.com web server. There might have been a mail.example.com mail server. There might have been a chat.example.com chat server. Nowadays, this host name or subdomain, depending on the context, can actually refer to a whole bunch of servers, right? When you go to www.facebook.com, that's not one server. That's thousands of servers nowadays. So long story short, there's technology that somehow get your data to one of those servers. But this whole thing is what we meant by fully qualified domain name. This thing here, host name. In the context of an email address, it might alternatively be called a subdomain. This thing here, top level domain. Probably know that .com means commercial, although anyone can buy it these days. .org is similar, .net. Some of them are a bit restricted. .mil is just for the US military. .edu is just for accredited educational institutions. But there are hundreds, if not more, top-level domains nowadays, some more popular than others. CS50's tools, for instance, use CS50.io. IO sort of connotes input, output. It actually is belongs, though, to a small island nation, a country whose country code is .io. And you see other two-letter top-level domains that are country-specific indeed. Something.uk, something.jp, and the like typically refer to countries. But some of them have been rather co-opted, .tv as well, because they have these meanings in English as well. Lastly, this is what we'll call the protocol. That specifies how the server uses this URL to get data from point A to point B. So what is inside of this envelope? Let's now start poking around a little bit more. What is inside of this envelope? It's essentially, for our purposes today, one of two verbs, either get or post. And if any of you have dabbled with HTML or made your own website, you might have seen some of these terms before. But these two verbs describe just how to send information from you to the server. Long story short, more on this next week. Get means put any user input in the URL. Post means hide it so that things you're searching for, credit card numbers you're typing in, usernames and passwords you're inputting don't show up in the URL and are therefore visible to anyone with access to your computer and your search history, but rather they're somehow provided elsewhere deeper into that envelope. But for now, we'll focus almost entirely on get, which is perhaps the most common one that we're always going to use. And what we're going to do is this. Let me switch over just to a blank screen here. And if we assume that little old me is this laptop here, and I'm connected to the cloud, and in that cloud is some server that I want to request the web page of, harvard.edu or yale.edu, it's really going to be a two-step process. There's going to be a request that goes from point A to point B. And then hopefully the server that hears that request is going to reply with what we'll typically call a response. And other terms that are relevant here is my laptop is the so-called client. Harvard.edu, Yale.edu, whatever it is the so-called server. And just like in a restaurant where you might request something to eat, the server might bring it to you. It's, again, that kind of bi-directional relationship. One request, one response for each such web page we request. All right, so what's inside these envelopes and what do we actually see? Well, this arrow, this line I just drew from left to right representing the request technically looks a little more like this. When you visit a web page using your browser on your phone, laptop, or desktop, what's going inside that envelope and the textual message your Mac or PC or phone is automatically generating looks a little something like this. The verb get, the URL, or rather the path that you want to get. Slash represents the default page on the website. HTTP/1.1 is just some mention of what version of HTTP you're speaking. Now we're up to versions 2 and version 3, but 1.1 is quite common. And the envelope contains some mention of the host that was typed in, the fully qualified domain name. This is because single servers can actually host many different websites. If you're using Squarespace or Wix or one of these popular hosting websites nowadays, you don't get your own personal server most likely. You're on the same server as dozens, hundreds of other customers. But when your customers, your users, browsers include a little mention of your specific fully qualified domain name in the envelope, Squarespace and Wix just know to send it to your web page or my web page or some other customer altogether. ... There's some other stuff there, but that's really the essence of what's in these requests. Hopefully then, when your browser requests this web page from the server, what comes back? Well, hopefully a response that looks like this. HTTP/1.1, so the same version, some status code, like a number 200, and then literally a short phrase like OK, which means exactly that, like OK, this request was satisfied. Then it contains some other information, like the type of content that's coming back. And we'll see that this, too, is standardized. Text/HTML means here comes some HTML, which is just a text language. It could instead be image/JPEG, or image/ping, or video/MP4. There are these different content types, otherwise known as MIME types, that uniquely identify types of files that come back. Similar in spirit to file extensions, but a little more standardized this way. Then there's some more stuff, ... But in general, what you see here are our familiar pattern, keys and values. These keys and values are otherwise known as HTTP headers. And your browser has been sending these every time you visit a website. And indeed, we can see this right now ourselves. Let me go over in just a second to Chrome on my computer, though you can do this kind of thing with most any browser today. I'll go ahead and visit http://harvard.edu, enter. And voila, I'm at Harvard's homepage for today. The content often changes, but this is what it looks like right now. Well, I typed in the URL, but notice it changed a little bit. It actually sent me to HTTPS, and it added www, even though I didn't type that. But it turns out we can poke around at what my browser is actually doing. Let me open another page. And I'm going to start to use incognito mode this time, not because I care that people know I'm visiting harvard.edu, but because it throws away any history that I just did so that every request is going to look like a brand new one. And that's just useful diagnostically, because we're always going to see fresh information. My browser's not going to remember what I previously already requested. But I'm going to go up to View, Developer Tools, which is something that all of you have if you use Chrome. And there's something analogous for Firefox and Edge and Safari and other browsers. Developer Tools is going to open up these tabs down here. I don't really care what's new, so I'm going to close the bottom thing there. And I'm going to hover over the Network tab for just a moment. And now I'm going to go and say http://harvard.edu, so the shorter version. I'm going to hit Enter. And a whole bunch of stuff just flew across the screen, and it's still coming in. And if I zoom in down here, my God, visiting harvard.edu, still going, is downloading, what, 17, 18, 19 megabytes, 20 megabytes, millions of bytes of information over 111 HTTP requests. In other words, a bit of a simplification, but my browser, unbeknownst to me, sent one envelope initially with the request. Then the server said, OK, by the way, there's 110 other things you need, 112 other things you need to get. So my computer went back and forth requesting even more content for me. Why? Well, inside of Harvard's web page is a whole bunch of images and maybe sound files and videos and other stuff that all need to be downloaded and to compose what is ultimately the web page. But I don't care about like 100 plus of these things. Let's focus on the very first one first. The very first request I sent was up here. And I'm going to click on this row under the Network tab. And then I'm going to see a bit of diagnostic information. To an average person using the web, they needn't care about this, just as you probably didn't care about it until right now. And even then, perhaps not. But if I scroll down to request headers, you will see if I click View Source, literally everything that was in the request, my Mac just sent to harvard.edu. Two of the lines are familiar. Get/HTTP 1.1, host:/harvard.edu, and then other stuff that for now it's not that interesting for us. But let's look at the response that came back from the server. I'm going to scroll up now and see response headers, view source. And this is interesting. It is not OK. There's no 200. There's no word OK. Curiously, harvard.edu has moved permanently. What does that mean? Well, there's a whole bunch of stuff here that's not that interesting for us. But this line, location, is interesting. This is an HTTP header, a standardized key-value pair that's part of the HTTP protocol, that is, conventions. And if I highlight just this one, it's telling me Harvard is not at http://harvard.edu. Harvard's website is now, and perhaps forever, at https://www.harvard.edu. So what's the value here? Probably someone at Harvard wants you to use a secure connection, so they redirected you from HTTP to HTTPS. Maybe the marketing people want you to be at www instead of just harvard.edu. Why? Just to standardize things. But there are technical reasons to use a host name and not just the raw domain name. And all of this other stuff is sort of uninteresting for our purposes now, because a browser that receives a 301 response knows by design, by the definition of HTTP, to automatically redirect the user. And that's why in my browser, all of this happened in like a split second, because I didn't really know or care about all of those headers. But that's why and how I ended up at this URL here. My browser was told to go elsewhere via that new location. And the browser just followed those breadcrumbs, if you will, at which point it downloaded all of the other images and files and so forth that compose this particular page. Well, let me zoom out and let me actually go into VS Code, if only because it's a little more pleasant to do things in just a terminal window without actually using a full-fledged browser. So now let's just use an equivalent program. It's called curl for connecting to a URL. That's going to allow me to play with websites and just see those headers without bothering to download all the images and text and so forth from the website. It's going to allow me to do something like this. Let me go ahead and run, for instance, curl-i-x get, which is just the command line arguments that says simulate a GET request textually as though you're a browser. And let's go to http://harvard.edu, enter. Now, by way of how curl works, I'm just seeing the headers. It didn't bother downloading the whole website. And you see exactly the same thing. 301 moved permanently. Location is indeed this one here. So that's kind of interesting. But let's follow it manually now. Let's now do what it's telling me to do. Let's go to the location with HTTPS and the www and hit enter. And now, what's a good sign with this output? Most of it's irrelevant. 200 OK. That means I'm seeing, presumably, if I were using a real browser, the actual content of the web page. Looks like Harvard's version of HTTP is even newer than the one I'm using. It's using HTTP version 2, which is fine. But 200 is indeed indicative of things being OK. Well, what if I try visiting some bogus URL like harvard.edu and this file does not exist? Something completely random, probably doesn't exist, and hit enter. What do you see now that's perhaps familiar in the real world? Yeah. Yeah, error 404. All of us have seen this probably endlessly from time to time when you screw up by mistyping a URL or someone deletes the web page in question. But all that is a status code that a browser is being sent from the server that's a little clue as to what the actual problem is underneath the hood. So instead of getting back, for instance, something like OK or move permanently, what I've just gotten back quite simply is 404 not found. Well, it turns out there's other types of status codes that you'll start to see over time as you start to program for the web. 200 is OK. 301 is moved permanently. 302, 304, 307 are all similar in spirit. They're related to redirecting the user from one place to another. 401, 403, unauthorized or forbidden. If you ever mess up your password or you try visiting a URL you're not supposed to look at, you might see one of these codes indicating that you just don't have authorization for those. 404, not found. 418, I'm a teapot, was a April Fool's joke by the tech community years ago. 500 is bad. And unfortunately, all of you are probably on a path now to creating HTTP 500 errors once next week we start writing code, because all of us are going to screw up. We're going to have typos, logical errors. And this is on the horizon, just like seg faults were in the world of C, but solvable with the right skills. 503, service unavailable, means maybe the server's overloaded or something like that. And there's other codes there, but those are perhaps some of the most common ones. Has anyone, we can get away with this here, less so in New Haven. Has anyone ever visited safetyschool.org? http://safetyschool.org. Dare we do this? Enter. Oh, look at that. Where did we end up? OK, so this has been like a joke for like 10 or 20 years. Someone out there has been paying for the domain name safetyschool.org just for this 2-second demonstration. But we can now infer, how did this work? The person who bought that domain name and somehow configured DNS to point to like their web server, the IP address of their web server, what is their web server presumably spitting out whenever a browser requests the page? What status code, perhaps? Well, we can simulate this. Let me go over to VS Code. Let me go back over here. Let me increase my terminal window. Let me do curl-i-x get http://safetyschool.org, enter. And that's all this website does. There's not even an actual website there. No HTML, no CSS languages we're about to see. It literally just exists on the internet to do that redirect there. In fairness, there are others. Let me actually do another one here. Instead of safetyschool.org, turns out someone some years ago bought harvardsucks.org. Enter. And when we do this, you'll see that, they don't need us to be secure, but I do need the www. Let's do this one. Enter. Oh, that one is not found. This demo actually worked for so many years, but someone has stopped paying for the Squarespace account recently, apparently. So, OK. So fortunately, we did save the YouTube video to which this thing refers. And so just to put this into context, since it's been quite a few years, Harvard and Yale, of course, have this long-standing rivalry. There is this tradition of pranking each other. And honestly, hands down, one of the best pranks ever done in this rivalry was by Yale to Harvard. It's about a 3-minute retrospective. It's one of the earliest videos, I dare say, on YouTube. So the quality is representative of that. But let me go ahead and full screen my page here. And what used to live at harvardsucks.org is this video here. If we could dim the lights for about 3 minutes.
We're here to cheer for Harvard.
Yeah! Let's go, Harvard!
Pass them down.
It's not going to say something like Yale sucks. It says go Harvard.
We're nice.
You see that? Look at them. They have the Joker. It's going to happen. It's actually
What do you think of Yale?
They don't think good.
Does everyone have it? Does everyone have their stuff?
Okay.
Does everyone have their stuff?
Probably that it's going to be legible. It's very small.
I agree.
I know, but it's too complicated.
What houses?
How many extra? How many extra are there? Sometimes.
Yeah. You guys have from Harvard.
No, Foho. Four-timer.
Yeah, but you said Hope.
Just make sure everyone
Well, you
has
probably
it.
dropped.
It looks like they're still passing. Are all the cards distributed?
Yeah.
All right, we can do it now.
Hold on this side! What do you think of Yale, sir?
Go on the wings. Do it one more
They
time.
suck?
One more time. One more
Do it
time.
again!
Oh, and there it goes again.
All right, so thanks to our friends at Yale for that one. Let's go ahead here and consider in just a moment what further is deeper down inside of the envelope, because we now have the ability to get data from, okay, all YouTube autoplay again. Got to stop doing that. Let's consider for just a moment that we now have this ability to get data from point A to point B, and we have the ability to specify in those envelopes what it is we want from the website. We want to get the home page. We want to get back the HTML. But what is that HTML? In fact, we don't yet have the language with which the web pages themselves are written, namely HTML and CSS. But let's go ahead and take a 5-minute break here, and when we come back, we'll learn those two languages. All right, we are back. So we got 3 languages to look at today, but 2 of them are not actually programming languages. What makes something a programming language, like C or Python and SQL, is that there are these constructs via which you can express conditionals. You might have variables. You might have looping constructs. You have the ability ultimately to express logic. HTML and CSS aren't so much about logic as they are about structure and the aesthetics of a page. And so we're going to create like the skeleton of a web page using this pair of languages, HTML and CSS, and then toward the end of the today, we'll introduce an actual programming language that actually is pretty similar in spirit and syntactically to both C and Python, but that's going to allow us to make these web pages not just static things that you look at, but interactive applications as well. And then next week again, in week 9, will we reintroduce Python and SQL, tie all of this together so that you can actually have a browser or a phone talking to a back-end server and creating the experience that you and I now take for granted for most any app or website today. Well, let's go ahead and do this. Let's quickly whip up something in this language called HTML. I'm in VS Code here. I'm going to go ahead and create a file quite simply called hello.html. The convention is typically to end your file names in .html. And I'm going to go ahead and bang this out real quick, but then we'll more slowly step through what the constructs are herein. So I'm going to say doc type HTML, open bracket HTML, and then notice I'm going to do open bracket / HTML close bracket. And I'm leveraging a feature of VS Code and programming environments more generally to do a bit of autocomplete. So you'll see that there's this symmetry to much of what I'm going to type, but I'm not typing all of these things. VS Code is automatically generating the end of my thought for me, if you will. Let me go ahead and say open the head tag, open the title tag. I'll say something cute like hello title. And then down here, I'm going to create the body of this web page and say something like hello body. And let me specify at the very top that all of this is really in English, lang equals en. So at this moment, I have a file in my VS Code environment called hello.html. VS Code, as we're using it, of course, is cloud-based. We're using it in a browser, even though you can also download it and run it on a Mac and PC. So we are kind of in this weird situation where I'm using the cloud to create a web page, and I want that web page to also live in the cloud, that is, on the internet. But the thing about VS Code, or really any website that you might use in a browser, by default, that website is using probably TCP port number 80 or TCP port number 443, which is HTTP and HTTPS respectively. But here I am, sort of a programmer myself, trying to create my own website on an existing website. So it's a bit of a weird situation, but that's OK, because what's nice about TCP is that you and I can just pick port numbers to use and run our own web server on a web server. That is, we can control the environment entirely by just running our own web server via this command, http-server. In my terminal window. This is a command that we pre-installed in VS Code here. And you'll notice a pop-up just came up. Your application running on port 8080 is available. That's a commonly used TCP port number. When 80 is already used and 443 is already used, you can run your own server on your own port, 8080 in this case. I've opened that tab in advance. And if I go into another browser tab here I see a so-called directory listing of the web server I'm running. So I don't see any of my other files. I don't see anything belonging to VS Code itself. I only see the file that I've created in my current directory called hello.html. And so if I click on this file now, I should see hello body. I don't see the title, but that's because the title of a web page nowadays is typically embedded in the tab. And if I'm full screen in my browser, there are no tabs. So let me minimize the window a bit. And now you can see just in this single browser window and my own URL here that hello body is in the top left-hand corner. And if I zoom in, there's hello title. So what have I done here? I have gone ahead and created my own web page in HTML in a file called hello.html. And then I have opened up a web server of my own, configured it to listen on TCP port 8080, which just says to the internet, hey, listen for requests from web browsers, not on the standard port number 80 or 443, listen on 8080. And this means I can develop a website using a web-based tool like this one here, which is increasingly common today. All right, so now let's consider what it is I actually just typed out. HTML is characterized really by just two features, two vocab words, tags and attributes. Most of what I just typed were tags, but there was at least one attribute already. Here's the same source code that I typed out in HTML from top to bottom. Let's consider what this is. The very first line of code here, doctype HTML, is the only anomalous one. It's the only one that starts with an open bracket, a less than sign, and an exclamation point. There's no more exclamation points thereafter for now. This is the document type declaration, which is a fancy way of saying it's just got to be there nowadays. It's like a little breadcrumb at the beginning of a file that says to the browser, you are about to see a file written in HTML version 5. That line of code has changed over time, over the years. The most recent version of it is nice and succinct like this. And it's just a clue to the browser as to what version of HTML is being used by you, the programmer. All right, what comes after that? Well, after that, and I've highlighted two things in yellow, this is what we're going to start calling an open tag or a start tag. Open bracket HTML, then something. Close bracket is the so-called start or open tag. Then the corresponding close or end tag is down here. And it's almost the same. You use the same tag number, you use the same angled brackets, but you do add a slash, and you don't repeat yourself with any of the things called attributes. Because what is this thing here? Lang equals quote unquote en means the language of my page is written in the English language. Humans have standardized 2- and 3-letter codes for every human language right now. And so this is just a clue to the browser for like automatic translation and accessibility purposes, what language the web page itself is written in. Not the tags, but the words like hello title and hello body, which while minimalist are indeed in English. So when you close a tag, you close the name of it with the slash and the angled brackets. You don't repeat the attribute. That would just be annoying to have to type everything again. But notice the pattern here. It's new syntax, but this is another example of key-value pairs in computing. The key is lang. The value is en for English. The attribute is called lang. The value is en. So again, it's just key-value pairs and just yet another context. Probably the browser's using a hash table underneath the hood to keep track of this stuff, like a 2-column table with keys and values. Again, humans keep using the same paradigm in different languages. What's inside of that? The nesting is important visually, not to the computer, but to us, the humans, because it implies that there's some hierarchy here. And indeed, what is inside of the HTML tag here? Well, we have what we'll call the head tag. The head tag says, hey, browser, here comes the head of the page. And then the body tag says, hey, browser, here comes the body of the page. The body is like 99% of the user's experience, the big rectangular window. The head is really just the address bar and other such stuff at top, like the title that we saw a moment ago. Just to introduce the vernacular then, The HTML tag, otherwise known as an element, has two children, the head child and the body child, which is to say that head and body are now siblings. So you can use the same kind of family tree terminology that we used when talking about trees weeks ago. If we look at the head tag, how many children does it seem to have? I'm saying 1. And indeed, at least if we ignore all the white space, the spaces or tabs or new line characters, there's just one child, a title element. And an element is the terminology that includes the start tag and the end tag and everything in between. So this is the title element. And the title element has one child, which is just pure text, otherwise known as a text node. Recall node from our discussions of data structures weeks ago. If we jump then to the body, which is the other child of the HTML tag, it too has one child, which is just another chunk of text, a text node that says, quote unquote, hello body. What's nice about this indentation, even though the browser technically is not going to care, is that it implies this kind of structure. And this is where we connect like weeks 5 and now weeks 8. Here is the tree structure we began to talk about, even in our world of C. It's not a binary tree, even though this one happens to have no more than 2 children. It's an arbitrary tree that can have 0 or any number of children. But if we have a special node here that refers to the document, the root node, so to speak, is HTML, drawn with a rectangle here, just for discussion's sake. It has 2 children, head and body, also rectangles. Head has a title child, and then it and body have text nodes, which I've drawn with ovals instead. Which is only to say that when your browser, Chrome, Safari, whatever, downloads a web page, opens up that envelope, and sees the contents that have come back from the server, it essentially reads the code that someone wrote, the HTML code, top to bottom, left to right, and creates in the browser's memory, in your Mac or your PC or your phone's memory or RAM, this kind of data structure. That's what's going on underneath the hood. And that's why aesthetically it's just nice as a human to indent things stylistically, because it's very clear then to you and to other programmers what the structure actually is. So that's it for like the fundamentals of HTML. We'll see a bunch of tags and a bunch of examples now. But HTML is just tags and attributes. And it's the kind of thing that you look them up when you need to. Eventually, many of them get ingrained. I constantly check the reference guides or Stack Overflow if I'm trying to figure out how do I lay something out. It's really just these building blocks that allow you to assemble the structure of a web page. This one's being super simple, but it's just tags and attributes. Any questions on this framework before we start to add more tags, more vocabulary, if you will? And in the middle, yeah. If we put the tello tag around body, that's a good question. Let's try it. So let me actually go to this and say open bracket title. Whoops. Sometimes you don't want it to finish your thought for you, but it did that time. I've gone ahead and changed the file. Let me go and open up. Give me a second to open my terminal window and go back to the URL that has my page. Give me a second. There's my hello.html. Let me zoom in on this. Let me zoom in on this. And let me go ahead now and click on hello.html. And in this case, it looks like we don't actually see anything. So the browser is hiding it. Technically speaking, browsers tend to be pretty generous. And half the time when you make mistakes in HTML, it will display. It might display, not display as you intended. It might not display the same on Macs or PCs or Chrome or on Firefox. There is a tool, though, that we'll see that can help answer this question for you. For instance, if I go to validator.w3.org, W3 is the World Wide Web Consortium, a group of people that standardize this kind of stuff. I can click on Validate by Direct Input and just copy paste my sample HTML into this box and click Check. And I should see, hopefully, that indeed it's an error, what you propose that I do. The browser just did its best to do something, which was to show me nothing, at least, rather than the incorrect information. But if I revert that change, and let me undo what we just did, let me copy my original code back into this text box and click Check. Now you can see, conversely, my code is now correct. And there's automated tools to check that, but we'll encourage you for problem sets and projects to use that particular manual tool. All right, so let's go ahead and enhance this a little bit by introducing a whole bunch of tags just to give you a sense of some of the building blocks here. So I'm going to go ahead and create a new file called paragraphs.html. And I'm just going to do a bunch of copy paste just to start things off so I'm not constantly typing all this darn stuff again and again, because I want everything to be the same here, except I'm going to change my title to be paragraphs for this demo. And inside of the body, I need a whole bunch of paragraphs of text, and I don't really want to come up with some text. So let me go to some random website here and grab lorem ipsum text, which if you're involved in like student newspaper or just design, this is just placeholder text. Kind of looks like Latin, but technically isn't. Here, though, I have a handy way of just getting 3 long paragraphs in something that looks like Latin. And I've put those, notice, inside of the body. And they're indeed long. Look how long the made-up words here are. So let me go now into my browser tab here. Let me reload this page, and you'll see 2 files have now appeared. Paragraphs.html, which is my new one, and hello.html. Let me click on paragraphs.html. And what clearly seems to be wrong? Yeah. Yeah, it's obviously one massive paragraph instead of 3, so that's interesting. But it's just a little hint as to how pedantic HTML is. It will only do what you say. And each of these tags tells the browser to start doing something and then maybe stop doing something. Like, hey, browser, here comes my HTML. Hey, browser, here comes the head of my page. Hey, browser, here comes the title of my page. Hello, title. Hey, browser, that's it for the title. That's it for the head. Here comes the body tag. So it's kind of having this conversation between the browser, between the HTML and the browser, doing literally what it says. So if you want a paragraph, you're probably going to want to use the p tag for paragraph. And I'm going to go ahead and add this to my code. I'm going to keep things neat, even though the browser won't care, by indenting things here. Let me create another paragraph tag here and close it right after that one, indenting again, and I'm keeping everything nice and orderly. Let me do one more here. Let me indent that, and then let me add it to the end of my page here. So again, a little tedious, but now I have 3 paragraphs of text that say, hey, browser, start a paragraph. Hey, browser, stop that paragraph. Start, stop, and so forth. Let me go back to the browser window here. Let me hit Command-R or Control-R to reload the page, and voila, now I have 3 cleaner paragraphs. All right, so there's a p tag for paragraphs. So now we have that particular building block. What if I want to add, for instance, some headings to this page? Well, that's something that's possible too. Let me go ahead and create a new file called headings.html. Let me copy and paste that same code as before. But now let's preface each paragraph with maybe h1. And I'm going to just write the word 1. And here I'm going to say h2, 2. And down here I might say h3, 3. So this is another tag, another 3 tags, h1, h2, h3. As you might have inferred by the file name I chose, this gives you headings, like in a book, different chapters or sections or subsections, or in an academic paper, you have different hierarchies to the text that you're writing. So now that I've added an h1 tag and the word 1, h2 tag, the word 2, h3 tag, and the word 3, let's go back to the browser, reload the page again, and voila, once the page reloads, I'll do it with the manual button, reload the page. Oh, what am I doing wrong? Yeah. I'm right. I'm not in the headings file. So let me go back a page. Now there's headings.html. Let me click on that. OK, now we see some evidence of this. Again, it's nonsensical content, but you can kind of see that h1 is apparently big and bold. h2 is slightly less big, but still bold. h3 is the same, but a little smaller. And it goes all the way down to h6. After that, you should probably reorganize your thoughts. But there's 6 different hierarchies here, as you might use for chapters, sections, subsections, and so forth. All right, so those are headings as an HTML tag. In our vocabulary. What's a common thing too? Well, let me go to VS Code again. Let me go ahead and get some boilerplate here, create a file called list.html. Let's create a simple list inside of my body. And I'll give this a title of list. And let me fix the title of this one to be headings as well. So in list.html, suppose I want to have a list of things, foo, bar, and baz, or like a computer scientist's go-to words, just like a mathematician might say x, y, z. Foo, bar, baz is in list.html. Let me go back to my browser, hit the back button. There's list.html. And hopefully I'll see foo, bar, and baz, one on each line, like a nice little list. But of course, I do not. And this is not English. Chrome thinks it might be Arabic. But that's curious, too, because the lang attribute should be overriding that. So Google is trying to override it. All right, what's the obvious explanation why we're seeing foo, bar, and baz on the same line and not 3 separate ones? We didn't tell it to do that. So we need paragraph tags or maybe something else. Turns out there is something else. There is a UL tag for an unordered list in HTML, inside of which you can have LI tags for list item, inside of which you can put your words. So there's my foo, there's my bar, there's my baz. And again, notice that VS Code is finishing my thought for me. But notice the hierarchy. Open UL, open LI, close LI, open LI, close LI, open LI, close LI, close UL. So it's sort of done in reverse order here. Let me go back to my browser, reload the same page, list.html, and voila, a default bulleted list that still seems to be in Arabic. What if I want this list to be numbered? Well, you can probably guess. If you don't want an unordered list, but an ordered list, what tag should I use? OL, sure. So let's try that. It's not always that easy as just guessing. But in this case, OL is going to do the trick. Let me go back to my other browser. Let me reload the page. And now it's going to automatically number for me. It's a tiny thing. But this is actually useful if you have a very long list of data. And maybe you might add some things in the middle, the beginning, or the end. It would just be annoying to have to go and renumber it. The computer is doing it for us by instead just numbering from top to bottom here. All right, what about another type of layout? Not just paragraphs, not just lists, but what about tabular data? You've got some research data you want to present, some financial data you want to present, a phone book that you want to present. How might we go about laying out data a la a table? Well, let me create a file called table.html. And I'll just copy paste where we started earlier. Let me start to close some of these other files. And in table.html, this is going to be a bit more HTML, but I'm going to go ahead and do this. Table and close table. Tables can have table headings. Sothead is the name of that tag. And tables can have tbodies, table bodies. So I'm going to add that tag. And this is a common technique, sort of start your thought, finish your thought, and then go back and fill in what's in between. What do I want to put in this table? How about a bunch of names and numbers? So for instance, like left column name, right column number. So let's create a table row with what's called the tr tag. Let's create a table heading with the th tag. And let's say name here. Let's create another table heading called number here. And all of that, to be clear, is in one table row. Meanwhile, in the table body, let me create another table row. But this time, it's not a heading. Now I'm in the guts of my table. Let's do table data, which is synonymous with like the cell of the table in like in an Excel spreadsheet or Google spreadsheet. In this TD, I'm going to say like Carter's name. And then let's grab Carter's number from our past demo, 617-495-1000. Then let's put me into the mix. And I'll go ahead and copy paste here, which often is not good. But we'll see that there's a lot of shared structure with HTML. Let me go ahead and do mine, 949-468-2750. And now save this page. So we're getting to be a lot of indentation. I'm using 4 spaces by default. Some people use 2 spaces by default. So long as you're consistent, that's considered good style. But let me go back to my browser here and hit back. That then brings me to my directory listing again. Here's table.html. And this is not that interesting yet. But you can see that there's 2 columns, name and number. Because it's a table heading, th, the browser made it bold-faced for me. In the table are 2 rows below that, Carter and David. It's a little, oh, I forgot my number 1. Sorry about that. 1 and 1. It's not the prettiest table, right? I feel like I kind of want to separate things a little more, maybe put some borders or the like. But with HTML alone, I'm really focusing on the structure alone. So we'll make this prettier soon. But for now, this is how you might lay out tabular data. All right, let me pause here just to see if there's any questions. But again, the goal right now is just to kind of throw at you some basic building blocks that, again, can be easily looked up in a reference. But we're going to start stylizing these things soon, too. And yeah, in the middle. How do you indent paragraphs? Really good question. For that, we're probably going to want something called CSS, Cascading Style Sheet. So let me come back to that in just a little bit. For the stylization of these things, beyond the basics like big and bold, we're going to need a different language altogether. All right, well, let's now create what the web is full of, which is like photographs and images and the like. Let me go ahead and create a new file called image.html. And let me go ahead and change the title here to be, say, image. And then in the body of this page, let's go ahead and put an image. The interesting thing about an image is that it's actually not going to have a start tag and an end tag, because that's kind of illogical. Like, how can you start an image and then eventually finish it? It's either there or it isn't. So some tags do not have end tags. So let me do image, img, source equals harvard.jpg. And let me go ahead and in my terminal window, I actually came with a photo of Harvard. Let me grab this for just a second. Let me grab harvard.jpg and put it into my directory. Pretend that I downloaded that in advance. And so I'm referring to now a file called harvard.jpg that apparently is in the same folder as my image.html file. If this image were on the internet, like Harvard server, I could also say like https://www.harvard.edu/folder name, whatever it is, /harvard.jpg. But if you've in advance uploaded a file to your own VS Code environment, like I did before class, by dragging and dropping this photo of Harvard, you can just refer to it relatively, so to speak. This would be the same thing as saying /harvard.jpg, go to the current directory and get the file called harvard.jpg. But that's unnecessary to type. For accessibility purposes, though, for someone who's vision impaired, it's ideal if we also give this an alternative text, something like Harvard University and the so-called alt tag. And this is so that screen readers will recite what it is the photo is for folks who can't see it. And if you're just on a slow connection, sometimes you'll see the text of what you're about to see before the image itself downloads, especially on a mobile device. So let's now go back to my open browser tab. And let's look in the directory. I now have harvard.jpg, which I downloaded in advance, and image.html. Let me click on image.html. And here we have a really big picture of Memorial Hall, the building we're currently in. Suffice it to say, I should probably fix this and maybe make it only so wide. But to do that, we're going to probably want to use this other language, CSS. There are some historical attributes that you can still use to control width and height and so forth. But we're going to do it the better way, so to speak, with a language designed for just that. How about a video, though? I also came prepared with, let me grab another file here. Let me grab a file called halloween.mp4, which is an MPEG file. And let me go ahead and change this now to be a file called video.html. I'll change my title to be video. And let's go ahead and now introduce another tag, a video tag, open bracket video. And then let me go ahead and close that tag proactively. And then inside of the video tag, you can say the source of the video is going to be specifically halloween.mp4. The type of this file, I know, is video/mp4 because I looked up its content type or MIME type. And the video tag actually has a few attributes. I can have this thing autoplay. I can have it loop forever. I can mute it so that there's no sound, which is necessary nowadays. Most browsers, to prevent ads, don't autoplay videos if they have sound. So if you mute your video, it will autoplay, but presumably not annoy users. And let me set the width of this thing to be like, 1280 pixels wide. But I can make it any size I want. So I know this just from having looked up the syntax for this tag. But notice one curiosity. Sometimes attributes don't have values. They're empty attributes. They're just single words, autoplay, loop, muted. And that kind of makes sense for any attribute that really does what it says. Like, it doesn't make sense to say muted equals something. Like, it's either muted or not. The attribute is there or not. Similarly for these others as well. So let me go back to my other browser tab, reload the directory listing. There is both my MP4 and also video.html, which is the web page that embeds it. And this is actually a video that was just on Harvard's website yesterday, and it was amazing. So we included it in this demo here. This is the video that was on harvard.edu last night. Same photo. But you can see here that an image alone probably would not have the same effect. This is actually a movie, a small video file that's now looping. Now, there's some artifacts here, like there's a white border around the top. I feel like it'd be nice to fill the screen. But again, we'll come back to a language that can allow us to do exactly that. Well, it's not just videos like this that you might want to put into a web page. Let me create another file called iframe.html. If you've ever poked around with it, if you have your own YouTube account, or if you had your own blog or WordPress site or Wix or Squarespace, you might have been in the habit of embedding videos in websites using like embedded YouTube players. Well, this is possible too using what's called an inline frame, an iframe. And an iframe is just a tag that is literally iframe. It has source equals and then a URL. And if it happens to be a YouTube video, there's a certain URL format you need to follow per YouTube's documentation. So you might do www.youtube.com, embed, and then here's an ID of a video. So this is essentially what we do if we want to embed CS50's own lecture videos in the course's website, or the video player does literally this. If I want to allow full screen, I can add this attribute too, that I know exists by just having checked the documentation. And if I now go back to my browser here, reload my directory listing. There's iframe.html. It's not going to fill the screen because I haven't customized the aesthetics yet, but it does seem to embed a tiny little video there for you to play with later if you'd like. So we could change the width, change the height, get rid of that margin and so forth. But an iframe is a way of embedding someone else's web page in your web page if they allow it, so as to create all the more of an interactive experience for them on, say, your site. All right, well, the web is, of course, known for things like links. Let's go ahead and create a file called link.html. And if we want to create a web page that actually links from itself somewhere else, let's go ahead and do this. Something very simple like visit harvard.edu, period. Now, in like Facebook, Instagram, a lot of websites nowadays, if you just type in a domain name or a fully qualified domain name, it automatically becomes a link. That's because those websites have code in them that automatically detects something that looks like a URL and turns it into a proper link. HTML itself does not do that for you. And so if I go back to my web page here, click on link.html, if you type visit harvard.edu, period, that's all you're literally going to see. But instinctively, even if you've never written HTML before, what should we probably do here to solve this problem? What could we do to solve this problem? What do I probably want to add? Yeah. Yeah, so I want to surround the URL with some kind of link text. And you wouldn't necessarily know this until someone told you or you looked it up. But the tag for creating a link is somewhat weirdly called the A tag for anchor. It has an attribute called href for hyperreference, which is like a link in the virtual world, to a URL. So let me type in Harvard's full and proper URL here. Then I'm going to close the tag. And then I can still say harvard.edu and make that what the human sees. But the place they're going to go should be a full URL, protocol and all, HTTP or HTTPS and all. Now if I go back here and reload the page, now it automatically gets underlined. It happens to be purple by default. Why? Because we visited harvard.edu a few minutes ago. So my browser by default is indicating in purple that I've been there before. But now I have a link that I can click on. And if I hover over it but don't click, you'll see that in most browsers, there's a little clue as to where you will go if you click subsequently on this link. And without going too far down a rabbit hole, but to tie together our discussion of cybersecurity recently, what if I were to do something like this? Right now you have the beginnings of a phishing attack of sorts, phishing, whereby you can create clearly a web page, or heck, even an email using HTML that tells the user they're going to go one place, but they're really going to go someplace else altogether. And that is the essence of phishing attacks these days. If you've ever gotten a bogus email pretending to be from PayPal or your bank or some other website, odds are they've just written HTML that says whatever they want, but the underlying tags might do something very different. And so having the instinct to look in the bottom left-hand corner or be a little suspicious when you're just told blindly to click on a link, it's this easy to socially engineer people, that is, deceive them by just saying one thing and linking to another. Well, what if I want to link my page to another page I already created? Well, if I want to link to like that photo of Harvard, I can just do href equals quote unquote in the name of a file in my same account that is itself a web page. So this is how you can create relative links, multi-page web pages, or multi-page websites yourself. So if I now reload this page, hover over harvard.edu, you'll see in the bottom left-hand corner a very long URL, but that's because I'm in code spaces right now, VS Code, and it's appending automatically to the end of my current URL, the file name, image.html. But this should work. When I click on this, I go immediately to that file we created earlier with a crazy big version of the image. But that's just a way that one page on a website can link to another page on a website. Let's do one other thing here, making things more responsive, because in fact, that wasn't a particularly responsive website. Responsive means responding to the size of the user's device, which is so important when someone might be on a screen like this or on a screen like this these days. There are special tags we can use to tell the browser to modify its display based on the hardware. So let me create a file called responsive.html. I'm going to copy paste some starting point here, call this title responsive. And let me go ahead and just grab some of that lorem ipsum text from before, just so that we have a sizable paragraph to play with here. And let me go ahead and grab this text here. And I'm just going to paste this into the body of this page. And that's it. So I just have a big paragraph at the moment inside of my body. Let me go back to my browser. let me open up this file called responsive.html to make the point that it is not yet responsive. Let me go ahead and click on responsive.html. That looks fine. But here's another trick you can do using Chrome or Edge or other browsers these days. You can pretend to be another device. Let me go to View, Developer, Developer Tools again. Last time we used this to use the Network tab, which was kind of interesting because we could see what the underlying network traffic is. But notice we can also click on this icon, in Chrome at least, that looks like a mobile phone. I can turn my laptop into what looks like a mobile device by clicking this. I'm going to click the dot, dot, dot menu over here and just move the dock. Instead of on the bottom where it might be by default, I'm going to move it to the right-hand side so that now on the left you see what looks more like the shape of a vertical phone. And in fact, if I go to my dimensions here, I'll choose something like iPhone X. So a few years back, here's what that same website might look like on an iPhone X. You know, that looks pretty damn small, you know, to be able to read it. And that's because the website has not automatically responded to the fairly narrow dimensions of the iPhone in question or Android device or whatnot. So let me go ahead and do this. Let me go back into my code. And let me go into the head of the page. And for the first time, add another tag up here. This word is now all over the internet. But there is a meta tag that allows you to specify the name of some kind of configuration detail here, a property, if you will. Viewport is the technical term for the rectangular region that the human sees in a browser. It's essentially the body of the page, but only the part the human is currently seeing. And you can specify the content of the viewport should have an initial scale of 1, so it shouldn't be zoomed in or out. And the width that the browser should assume should be equal to the device's width. These are sort of magical statements that you just have to know or copy paste or transcribe that just express to the browser, assume that the width of the page is the same thing as the width of the device. Don't assume the luxury of a big laptop or desktop computer. Now, making only that change, let me go back to my pretend iPhone here using Chrome's developer tools. Let me reload the page. And now, it's not very effective on this screen. If I were showing you this on, there we go. Let's do this. There we go. So if I zoom into 100%, this would be on an actual physical device much more readable than it would have been a moment ago, even though I realized that demo was not necessarily persuasive. But it's as simple as telling the browser to resize the thing to the width of the page. All right, let me pause here to see if there's any questions, because that feels like enough HTML tags. We'll add just a couple of more in. But for the most part, like HTML tags are things you Google and figure out over time just to build up your vocabulary. The basic building blocks are tags, attributes. Some attributes have values, some do not. And that's sort of the structure of HTML in essence. Questions on any of these, though? Yeah? Do attributes have an order? No. Attributes can be in any order from left to right. I tend to be a little nitpicky, and so I alphabetize them, if only because then I can easily spot if something's missing if it's not there alphabetically. Most people on the internet don't seem to do that. Yeah, in the middle. Yeah, good question. I mentioned that HTML is starting to replace other languages for user interfaces. And it's not just HTML alone. It's HTML with CSS, with JavaScript, both of which we'll get a taste of here today. That rather has been the trend for portability and the ability for companies, for individual programmers, to write one version of an app and have it work on Android devices and iPhones and Macs and PCs and the like. It is very expensive. It is very time consuming to learn a language like Java and write an Android app. Learn another language called Swift and make an iOS app. Not to mention make them look and behave the same. Not to mention fix a bug in one and then remember to fix it in the other. I mean, this is just very painful and time consuming and costly. So this standardization on HTML, CSS, and JavaScript, even for mobile apps and web apps, has been increasingly compelling because it solves problems like that. All right, so let's go ahead and now do something that's finally interactive. All of these pages thus far are really just tastes of static content, content that does not change. Well, let's go ahead and do this. Let me introduce one other format of URLs, which looks a little something like it did before, so /path, but it could actually be something like this, /path ? key equals value. You might not have noticed or cared to notice the URLs in your URL bar every day, but these things are everywhere. Often when you type into a search engine like Google, a search query, whatever you just typed ends up in the URL. When you click on a link that contains some information, there might be a question mark and then some keys and values. There might be an ampersand and more keys and values. Here again is that very common programming paradigm of just associating keys with values. We can see this as follows. Let me actually go to google.com in a browser here, and let me search for something the internet is filled with, cats. Enter. Notice now that my URL changed from google.com to google.com/search q equals cats ampersand, and then a bunch of stuff that I don't understand or know. So let's just delete it for now and leave it with the essence of that URL. And that still works. If I zoom out here, years ago you would get pictures of cats. Now you get videos of the movie. And the top query there is cat's a bad movie. But we can also, of course, click on images, and there are the adorable cat. Oh, creepy cats. All right, this didn't used to happen when we searched for cats. But anyhow, the point is that the URL changed to include the user's input. And this is such a simple but such a powerful thing. This is how humans provide input to servers. They don't manually create the URLs like I sort of just did. But when you fill out a form on the web and you hit enter, typically the URL suddenly changes to include whatever you typed in the URL, assuming the form is using the verb get. That's not ideal if you're typing in a username, a password, a credit card information, because you don't want the next person to sit down at your laptop to see literally everything you typed in saved in your history. So there's another verb, post, that can hide all of that. And it's just sent a little differently. But things like this are typically sent via get. And what that means underneath the hood is that your browser is just making a request like this. Get/search q equals whatever you typed in, the host that you visited, and so forth. And hopefully what comes back is a page full of search results, including cats. And what's interesting here now is if I go back to VS Code on my own computer, and let me go ahead and create a file called, how about search.html. In search.html, I'm going to start with some copy paste from before, change my title to search, and in the body of this page, I'm going to introduce a form tag. And in this form tag, I'm going to have a couple of inputs. And the types of inputs are going to be text. And the type of the input is going to be submit. And this isn't that interesting yet, but let's see what's happening in the page itself. Let me go back to my directory listing. Let me click on search.html. I seem to have the beginning of my own search engine. It's not very interesting. It's just a text box and a submit button. But let's finish my thoughts here. So let's specifically give this text box a name of Q, which, if you roll back to the late 90s when Larry and Sergey of Google fame created google.com, Q represented query, the query that the human's typing in. So the name of this text box shall be shall be Q. The form is going to use what method? Technically, it uses get by default, but I'll be explicit and say method equals quote unquote get. Stupidly, it's lowercase in HTML, even though what's in the envelope is indeed uppercase by convention. The action of this form specifically would ideally go to my own server, but we don't really have time today to implement Google itself. So we're just going to send the user's request to google.com/search. So I'm creating a form, the action of which is to send the data to Google's/search path using the get method. It's going to send a input called Q whenever I click this submit button. Let me go back to the browser, reload the page. Nothing seems to have changed yet, but if I search for, let me zoom out so we can see the URL bar. Right now I'm in search.html. If I zoom out and search for cats now and click submit, I'm whisked away to google.com, but notice that the URL is parameterized with those key value pairs, that key value pair, and I get back a whole bunch of cat results. And I can very easily now make this a little prettier. Right now, it's not ideal that like the human has to move their cursor and click in the box. And it's a little obnoxious that autocomplete is enabled if I don't want to search for cats anymore. Well, according to HTML's documentation, I can say something like this. Autocomplete equals off, to turn off autocomplete. Autofocus, to automatically put the cursor inside of that text box. If I want some explanatory text, I can put placeholder text like quote unquote query. And now if I go back to this page and reload, now it's a little more user-friendly. You see query in kind of gray text. The cursor is already there and blinking. I don't have to even move my cursor. I can search for dogs now, and you didn't see any autocomplete at all. Hit enter to submit, and now I'm searching for, there we go, adorable dogs instead. So what have I done? I've implemented the front end of google.com, just not the back end. To implement the back end, we're obviously going to need like a really big database, maybe something like SQL. We're going to need some code that like searches the database for dogs or cats or anything else. We're going to need Python for something like that. And in fact, that's the direction we're steering next week when we implement that back end. But today, it's all about this front end. All right, any question then about forms, these URL parameters, before we now transition to making things look a little prettier with CSS? And then we'll end by making things a little more functional with JavaScript. Anything at all? No? All right. So let's start to answer a couple of the questions that came up by making these pages a little more aesthetically interesting. Let's go ahead now and introduce to the mix one other language as follows. Let me go ahead and create a file called home.html as though I'm making a home page for the very first time. And in this page, I'm going to give a title of home. And I'm just going to have like 3 things. First, I'm going to have maybe a paragraph of text up here at the top that says something welcoming for my home page, like my name, John Harvard, for instance, or John Harvard's home page. Then in the middle of the page, I'm going to have some text like, welcome to my home page, exclamation point. And at the bottom of the page, I'm going to have a final paragraph that says something like, copyright, the copyright symbol, John Harvard, or something like that. All right, so it's like a web page with 3 different structural areas made with text. This isn't that interesting. If I open this page called home.html, let me go ahead and create 3 quick paragraphs. The first paragraph for John Harvard. Inside the middle, I'm going to say something like, welcome to my home page, exclamation point. And at the bottom, a little footer that says something like copyright, a little simple copyright symbol, and John Harvard's name. All right, now let me reload the page, and there we go. It's very simple, very underwhelming web page that has 3 main sections. Let's start to now stylize this in an interesting way so that it's a little more aesthetically pleasing. First, these aren't really paragraphs. They're sort of like areas of the page, divisions. Like the header is up here. There's like the main part of my screen, and then there's the footer of my screen. So paragraphs isn't quite right if these aren't really paragraphs of text. I might more properly call them divs or divisions of the page, which is a very commonly used tag in HTML, which just has this generic rectangular region to it. It does not do anything aesthetically. No bold facing, no size changes. It just creates an invisible rectangular region inside of which you can start to style the text. Or I can take this one step further. There's some other tags in HTML known as semantic tags that literally have names that describe the types of your page, which is all the more compelling these days for accessibility to, for screen readers, for search engines, because now a screen reader, a search engine can realize that footer is probably a little fluffy. The header might be a little interesting. The main part of the page is probably the juicy part that I want users to be able to search for or read aloud substantively. So let's start to stylize this page somehow. Let's introduce a style attribute in HTML, inside of which is going to be text like this: font size, large, text align, center. On main, I'm going to add a style attribute and say font size, medium. Text align, center. And then on the footer, I'm going to say style equals font size, small, text align, center. What's going on here? Well, in blue is the language we promised called CSS, for cascading style sheets. We're not really seeing the cascading style sheet of it yet, but in blue here, notice, is another very common paradigm. It's different syntax now, but how would you describe what you're looking at here in blue? This is another example of what kind of programming convention. Yeah, it's just more key value pairs, right? It'd be nice if the world standardized how you write key value pairs, because we've now seen equal signs and arrows and colons and semicolons and all this, but it's just different languages, different choices. The key here is font dash size. The value is large. The other key is text dash align. The value is center. The semicolon just separates one key value pair from another. Just like in the URL, the ampersand did in the context of HTTP. The designers of CSS used semicolons instead. Strictly speaking, this semicolon isn't necessary. I tend to include it just for symmetry, but it doesn't matter because there's nothing after that. This is a bit of a weird example. This is the commingling of CSS inside of JavaScript. So as of now, you can use the CSS language inside of the quote marks in the value of a style attribute. We did something a little similarly a week plus ago when we included some SQL inside of Python. So again, languages can kind of cross barriers together. But we're going to clean this up because this is going to get messy quickly, certainly for large web pages the size of Harvard's or Yale's or the like. So let's see what this looks like. Let me go back to my browser window here, reload the page. And it's not that different, but it's indeed centered. And it's indeed large, medium, and small text. And let me make one refinement. The copyright symbol actually can be expressed, but there's no key on my US keyboard here. I can actually magically say ampersand #169 semicolon using what's called an HTML entity. Turns out there are numeric codes with this weird syntax that allow you to specify symbols that exist in Macs and PCs and phones, but that don't exist on most keyboards. If I reload the page now it's a proper copyright symbol. So minor aesthetic, but it introduces us to these HTML entities. So even if you've never seen CSS before, you can probably find something kind of dumb about what I did here, like poor design. It is correct if my goal was small, medium, and large, bottom up. What looks like a bad design, perhaps? Even if you've never seen this language before. Yeah, I've used the same style 3 times. Like copy paste or typing the exact same thing again and again, it has rarely been a good thing. Well, here's where we can take advantage of the design of CSS because it supports what we might call inheritance, whereby children inherit the properties, the key value pairs of their parents or ancestors. And what that means is I can do this. Let me get rid of this text align. Let me get rid of this text align. Let me get rid of this one. I could get rid of the semicolon too, but I'll leave it for now. And let me add all of that style to the parent element, the body, so that it sort of cascades down to the header, the main, and the footer tags as well. And let me close my quotes there too. Now if I go back to my browser and hit reload, nothing changes, but it's a little better designed, right? Because if I want to change the text alignment to maybe be right aligned, I can now reload the page, and voila, now it's over there. I change it in one place, not in 3 different places. So that would seem to be marginally better design. And could we do this any more differently? Well, it's not that elegant that it's all just kind of in line with my HTML. This generally tends to be bad practice where you commingle your HTML and your CSS, especially since some of you might be really good at like laying out the structure of web pages and the content and the data, and you might have a horrible sense of design or just not care about the aesthetics. You might work with a designer, an artist, who's much better at all of these fine tunings aesthetically. Wouldn't it be nice if you could work on the HTML, they could work on the CSS, and you don't have to somehow like literally edit the same lines of code as each other? Well, just like we can move stuff into header files in C or packages in Python, we can do the same in CSS. So I'm actually going to go ahead and do this. Let me get rid of all of these style attributes. And let me now start to practice a convention of not commingling CSS with my HTML. Let me instead move it into the head of the page in a style tag instead of an attribute. This is one of the rare examples where there are attributes that have the same names as tags as vice versa. It's not very common, but this one does exist. Here's a slightly different syntax for expressing the same key value pairs. If I want to apply CSS properties, that is key value pairs, to the header of the page, I say header, and then I use curly braces. And inside of those, I say font-size large, text-align center. Then if I want to apply some properties to the main section of the page, I again do font size, say medium. And then I can do text align center. Then lastly, on the footer of the page, I can assign some properties like font size small, and then text align center, semicolon. And I don't have to do anything more in my HTML. It all just represents the structure of my page. But because of this style tag in the head of the page, the browser knows in advance that the moment it encounters a header tag, a main tag, or a footer tag, it should apply those properties, those styles. If I reload the page, other than it being recentered now, there's no other changes. All we're doing is sort of iteratively improving the design here. But now everything's in the top of the file. But there's still a bad design here. What could I now do that would be smarter? Similar problem to before. Yeah. OK, create a new file with just the CSS. I like that. Let's go there in just 1 second. But even as we're here, there's still a redundancy we can probably chip away at. Yeah, get rid of the text-align center in 3 different places, which doesn't seem necessary. And perhaps someone else, if I get rid of text-align center, what should I add to my style tag in order to bring it back, but apply it to everything in the page? And the page, if I scroll down, looks like this in HTML. Yeah. Yeah, so the body tag. So let me go ahead and say body, and then in here put text align center. And that now, if I reload the page, has no visual effect, but it's just better design because now I've factored out that kind of commonality. And so just to make clear what we've been doing here, these are all, again, CSS properties, these key value pairs. And there's different types of ways of using them. And there's this whole taxonomy. What we've been doing thus far are what we're going to call type selectors, where the type is the name of a tag. And so it turns out there's other ways, though, to do this. And let's head in this direction. Let's go ahead and maybe write our CSS slightly differently. Because you know what would be nice? I bet after today, once I start creating other files for my home page or John Harvard's home page, I might want to have center text on other pages. And I might want to have large text or medium text or small text. It'd be nice if I could reuse these properties again and again and kind of create my own library, maybe even ultimately putting it in a separate file. So let me do this. Instead of explicitly applying text-align center to the body, let me create a new noun, or an adjective rather, for myself called centered. It has to start with a dot because what I'm doing is inventing my own class, so to speak. This has nothing to do with classes in Java or Python. Class here is this aesthetic feature. And actually, let me rename these to be .large, .medium, and .small. What this is doing for me is it's inventing new words, well-named words, that I can now use in this file or potentially in other web pages I make as follows. I can now say, if I want to center the whole body, I can say class equals centered. On the header tag, I can say class equals large. On the main tag, I can say class equals medium. On the footer tag, I can say class equals small. But let me take this one step further. As you suggested, why don't I go ahead now and let me actually let me grab all of the CSS, copy it to my clipboard. Let me get rid of the style tag here and create a new file called home.css. And let me just save all of that same text in a separate file ending in .css. Nothing else. No HTML whatsoever. But let me go back to my home.html page. And this is one of the most annoyingly named tags because it doesn't really mean what it does. It says link href home.css rel equals style sheet. So ideally, we would have used the link tag for links in web pages. But this is link in the sort of conceptual sense. We're linking this file to this other one so that they work together using this hyperreference, home.css. The relationship of that file to this one is that of style sheet. A style sheet is a file containing a whole bunch of stylizations, a whole bunch of properties, as we just did. So here, too, it's underwhelming, the effect. If I reload the page, nothing changed. But now, I not only have a better design here, because I can now use those same classes in my second page that I might make, my third page, my fourth page, my bio, my resume page, whatever it is I'm making on my website here, I can reuse those styles by just including one line of code instead of copying and pasting all of that style stuff into file after file after file. And heck, if the rest of the world is really impressed by my centered class and my large and medium and small classes, I could bundle this up, let other people on the internet download it, and I have my own library, my own CSS library that other people can use. Why should you ever invent a centered class again if I already did it for you, stupid and small as this one is? But it would be nice now to package this up in a way that's usable by other people as well. So this is perhaps the best design when it comes to CSS. Use classes where you can. Use external style sheets where you can. But don't use the style attribute where we began, which, while explicit, starts to get messy quickly, especially for large files. All right, any questions then on this? No? All right, so that's class selectors. When you specify dot something, that means you're selecting all of the tags in the page that have that particular class and applying those properties. So there's a couple of others here, just to give you a taste now of what's possible. There's so much more that you can actually do with HTML and CSS together. Let me go ahead and open up a few examples that I did here in advance. Let me go ahead and open up VS Code, and let me go ahead and copy my source 8 directory. Give me one sec to grab the source 8 directory for today's lectures so that I can now go into my browser, go into some of the pre-made examples in source 8, and let me open up paragraphs 1 here. So here's something. It's a little subtle, but does anyone notice how this is stylized? This is just some generic lorem ipsum text again. But what's noteworthy stylistically? A book might do this. Yeah? Yeah, the first paragraph's a little bigger. Why? Who knows? It's just a stylistic thing at the beginning of the chapter. The first paragraph is bigger. How did we do that? Well, we can actually explore this in a couple of ways. One, I can obviously go into VS Code and show you the code. But now that we're using Chrome and we're using these developer tools, let's again go into them. View, developer, developer tools. And now notice, let me turn off the mobile feature. And let me move the dock back to the bottom just so that it's fully wide. We looked at the network tab before. We looked at the mobile button before. Now let me click on Elements. What's nice about the Elements tab is you can see a pretty printed version of the web page's HTML, nicely color-coded, syntax highlighted for you, so that you can now henceforth learn from, look at the source code, the HTML source code of any web page on the internet. Notice that my own web page here, it's not that interesting. There's a bunch of paragraph tags of lorem ipsum text. But notice what I did. The very first one, I gave an ID to. This is something that you, as a web designer, can do. You can give an ID attribute to any tag in a page to give it a unique identifier. The onus is on you not to reuse the word anywhere else. If you reuse it, you've screwed up. It's incorrect behavior. But I chose an ID of first, just so that I have some way of referring to the very first paragraph in this file. If I look in the head of the page and the style tag here, notice that I have hash first. So just as I use dot for classes, the world of CSS uses a hash symbol to represent IDs, unique IDs. And what this is telling the browser, whatever element has the first ID, F-I-R-S-T, without the hash, apply font size larger to it. And that's why the first paragraph, and only the first paragraph, is actually stylized. If I actually go into VS Code now, and let me go into my source 8 directory, let me open up paragraphs1.html. Here's the actual file. If I want to change the color of that first paragraph to green, for instance, I can do color:_green. Let me close the developer tools, reload the page, and now that page is green as well. You don't have to just use words. You can use hexadecimal. What was the hex code for green in RGB? Like no red, lots of green, no blue. So you could do 00FF00 using a hash, which coincidentally is the same symbol, but it has nothing to do with IDs. This is just how Photoshop and web pages represent colors. Let's go back here and reload. It's the same, although it's slightly different version of green. This is pure green here. If I want to change it to red, that would be, let's see, RGB FF0000. And here I can go and reload. Now it's first paragraph red. This actually gets pretty tedious quickly. Like if you're a web designer trying to make a website for the first time, it actually might be fun to tinker with the website before you open up your editor and you start making changes and save and reload. That's just more steps. So notice what you can do with developer tools too in Chrome and other browsers. When I highlight over this paragraph under the Elements tab, notice that one, it gets highlighted in blue. If I move my cursor, it doesn't get highlighted. If I move it, it gets highlighted. So it's showing me what that tag represents. But notice over here on the right, you can also see all of the stylizations of that particular element. Some of them are built in. The italicized ones here at the bottom means user agent style sheet. That means this is what Google makes all paragraphs look like by default. But in non-italicized here, you see hash first, which is my code that I just changed. And if I want to start tinkering with colors, I can do like 0000FF, enter. I changed it to blue. But notice if I go back to VS Code, I didn't change my original VS Code code. This is now purely client side. And this is a key detail. When I drew that picture earlier of the browser making a request to the cloud, the server in the cloud, and the response coming back, the browser, your Mac, your PC, your phone has a copy of all the HTML and CSS, so you can change it here however you actually want. And for instance, you can do this with any website. Let's go, say, on a field trip here to, how about stanford.edu. So here's Stanford's website as of today. Let's go ahead here and let's see, there's their admissions page, campus life, and so forth. Let me go ahead and view developer tools on Stanford's page. Developer tools. Elements, you can see all of their HTML. And notice it's collapsed. So here's their header. Here's their main part. And I'm using my keyboard shortcuts to just open and close the tags to dive in deeper and deeper. Suppose you want to kind of mess with Stanford. You can actually like right-click on any element of a page or control-click, inspect, and that's going to jump you automatically to the tag in the Elements tab that shows you that link. And notice if I hover over this LI, notice Stanford's using a list as an unordered list from left to right. Though it doesn't have to be a bulleted list top to bottom. They've used CSS to change it to be a list from news, events, academics, research, healthcare, campus, admission, about. Well, so much for admission. That's gone. So now, if I close developer tools, now it's gone from Stanford's website. But of course, what have I really done? I've just like mutated my own local copy. So this is not hacking, even though this might be how they do it in TV and the movies. It's still there if I reload the page. But it's a wonderfully powerful way to, one, just iterate quickly and try different things stylistically, figure out how you want to design something, and two, just learn how Stanford did something. So for instance, if I right-click or control-click on admission again, go to inspect, and let me go to the LI tag. Let me keep going up, 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 up to the UL tag. There's going to be a lot going on here. But notice they have applied all of these CSS properties to that particular UL tag. But notice here, this is how it's something like this. And we'd have to read more to learn how this works. List style type none. This is how they probably got rid of the bullets. And what you can do is just tinker. Like, all right, well, what does this do? Well, let me uncheck it. All right, didn't really change anything. Font weight, uncheck this. There we go. So now the margin is changed. The padding around it has changed. Let's get rid of this. We can just start turning things on and off just to get a sense of how the web page works. I'm not really learning anything here so far. Let me go to the LI here for, let's go to the admissions one here. Margin. There we go. OK, so when there's a display property in CSS that's apparently effectively changing things from vertical to horizontal, if I turn that off, now Stanford's links all look like this, and there are those bullets. So again, just default styles that they've somehow overridden. And a good web designer just knows ultimately how to do these kinds of things. All right, how about a couple final building blocks before we'll take one more break, and then we'll dive in with JavaScript to manipulate this stuff programmatically. Let me go ahead and open up, how about paragraphs 2 here? Let me close this tab. Let me go into paragraphs 2, which is pre-made. And this one looks the same, except when I go ahead and inspect this first paragraph, notice that I was able to get rid of the ID somehow, which is just to say there's many, many ways to solve problems in HTML and CSS, just like there is in C and Python. Let me look in the head and the style of the page now. This is what we might call this is another type of selector that allows us to specify the paragraph tag that itself happens to be the first child only. So you can apply CSS to a very specific child, namely first child. There's also syntax for last child, if just the first one is supposed to look a little different. So here, I've just gotten out of the business of creating my own unique identifier. And instead, I'm using this type of selector as well. Well, what more can we do? Let me go into another example here called link1.html. And here we have a very simple page that just says visit Harvard. But notice it's purple by default because we've been to harvard.edu before. Let's see if we can't maybe stylize Harvard's links to be a little different. Let me go into link version 2 now, which looks like this. And now Harvard is very red. How did I do that? Well, let me right-click on it, click Inspect, and I can start to poke around. It looks like my HTML is not at all noteworthy. It's just very simple HTML anchor tag with an href. So let's look at the style. Let me zoom out. And we can look at it in two different ways. We can literally look at the style, contents here. Or we can look at Chrome's pretty version of it over here. It looks like my style sheet in the style tag has changed the color to be red and the text decoration, which is a new thing, but it's another CSS property, to none. Notice if I turn that off, links on the internet are underlined by default, which tends to be good for familiarity, for visibility, for accessibility. But if it's very obvious what is text and what is a link, maybe you change text decoration to none. But maybe, watch this, maybe the line comes back when you hover over it. Well, let's look at how I did this in style. Notice that I have stylization, and I put my curly braces on the same line here, as tends to be convention in CSS. Color is red, text decoration is none. But whenever an anchor tag is hovered over, you can change the text decoration to be back to the default underline. So again, just little ways of playing around with the aesthetics of the page once you understand that really there's just different types of selectors. And you might have to remind yourself, look them up occasionally as to what the syntax is. But it's just another way of scoping your properties to specific tags. Let's look at version 3 of this here, which adds Yale to the mix. If I go to link3.html, maybe I want to have Harvard links red, Yale links blue. How might I have done this? Well, let's right click and click inspect. And here we might have 2 links with a couple of techniques. Just to, again, emphasize, you can do this so many different ways. I gave my Harvard link an ID of Harvard, my Yale link an ID of Yale. In my CSS, if we go to the head of the page, I then did this. The tag with the Harvard ID, aka #Harvard, should be red. #Yale should be blue. And then any anchor tag should have no text decoration unless you hover over it, at which point it should be underlined. And so if I hover over Harvard, it's red underlined. Yale, it's blue underlined. If I want to get rid of the IDs, I can do this a slightly different way. Let me go into link 4. Same effect, but notice I got rid of the IDs now. How else can I express myself? Well, let's look at the CSS here. The anchor tag has no text decoration by default unless you're hovering over it. And this is kind of cool. This is what we would call on our list here an attribute selector, where you select tags using CSS notation based on an attribute. So this is saying, go ahead and find any anchor tag whose href value happens to equal this URL and make it red. Do the same for Yale and make it blue. Now, this might not be ideal because if there's something after the slash, these equal signs don't work, because if it's a different Harvard or different Yale link, this is a little too precise. So let me look at version 5 here of link.html. Look at this style, and I did this a little smarter. This is new syntax, and again, just the kind of thing you look up. Star equals means change any anchor tag whose href contains anywhere in it harvard.edu to red, and do the same thing for Yale based on star equals. So star here connotes wildcard. So search for harvard.edu or yale.edu anywhere in the href, and if it's there, colorize the link. And again, we could do this all day long with diminishing returns to actually achieve the same kind of stylizations in different ways. And as projects just get larger and larger, you just have more and more decisions to make. And so you have certain conventions you start to adopt. And indeed, if I may, you have the introduction of what are called frameworks ultimately. If you're a full-time web developer or you're working for a company doing the same, you might have internal conventions that you adhere to. For instance, the company might say, always use classes, don't use IDs, or always use attribute selectors, or don't use this. And it wouldn't be necessarily as draconian as that, but they might have a style guide of sorts. But what many people and many companies do nowadays is they do not come up with all of their own CSS properties. They start with something off the shelf, a framework, typically a free and open source framework that just gives them a lot of pretty stylizations for free just by using a third-party library. And one of the most popular ones nowadays is something called Bootstrap that CS50 uses on all of its websites, super popular in industry as well. It's at getbootstrap.com. And this is just, to give you a taste of it, a website that documents the library that they offer. And there's so much documentation here, but let me just go to things like how about components. It just gives you, out of the box, the CSS with which you can create little alerts. If you've ever noticed on CS50's website, little colorful warnings at the top of the page or callouts to draw your attention to things. How did we do that? It's probably a paragraph tag or a div tag. And maybe we changed the font color. We changed the background color. Right? It's a lot of stuff we could absolutely do from scratch. But you know what? Why reinvent the wheel if we can just use Bootstrap? So for instance, let me just scroll down. If you've ever seen on CS50's website a yellow warning alert like this, let me just zoom in on this. we are just using HTML like this. We're using a div tag, which again is an invisible division, a rectangular region of the page. But we're using classes called alert and another class called alert warning. Those are classes that the folks at Bootstrap invented. They associated certain text colors and background colors and padding and margin and like other aesthetics with. So all we have to do is use those classes. Role equals alert just makes clear to like a screen reader that this is an alert that should probably be recited. And whatever's in between the open tag and close tag is what the human would see. How do you use something like Bootstrap? Well, you just read the documentation. Under Getting Started, there is a link tag you copy paste into your own. So let me do this. So in table.html, we had code like this. Let me actually read Bootstrap's documentation really fast. And they tell me, ... copy paste this code. I'm going to put this into the head of my page. And it's quite long. But notice it's a link tag, which I used earlier for my own CSS file. The href of which is this CDN link, Content Delivery Network, that's referring to a specific version of Bootstrap that's available on this day. And the file that I'm including is called bootstrap.min.css. This is an actual file I can visit with my browser. If I open this in a separate tab, this is the CSS that Bootstrap has made freely available to us. Crazy long, no white space. That's because it's been minimized just to not waste space by adding lots of white space and comments. But this contains a whole lot, hundreds of CSS properties that we can reuse thanks to classes that they invented. If I want to use some JavaScript code, I can also copy this script tag. But we'll come back to that before long. Let me now just make a couple of tweaks to this table. If I go into my browser from before, this is what it looked like previously, where name and number were bold but centered, and then Carter and David were on the left and the numbers were to the right. You know, it's fine. It's not that pretty, but it'd be nice if it were a little prettier than that. So if we add Bootstrap into it, notice one thing happens first when I reload the page. No longer are Chrome's default styles used. Now Bootstrap's default styles are used, which is a way of enforcing similarity across Chrome, Edge, Firefox, Safari, and others. Notice it went from a serif font to a sans serif font and something cleaner like this. It still looks pretty ugly, but let me go into Bootstrap's documentation. Let me go under their content tab for tables. And if I just kind of start skimming this, these are some good looking tables, right? Like there's some underlining here, some it's bolder font, there's a dark line. If I keep going, ooh, that's getting pretty too. If I want to have a colorful table, like I could figure all of this stuff out myself if I want sort of dark mode here. If I want to have alternating highlights and so forth. There's so many different stylizations of tables that I could do myself. But I care about making a phone book, not about reinventing these wheels. So if I read the documentation closely, it turns out that all I need to do is add Bootstrap's table class to my table tag and watch with a simple reload what my now table.html file looks like. Much nicer. Right? Might not be what you want, but my God, with like 2 lines of code, I just really prettied things up. And so here then is the value of using something like a framework. It allows you to actually create much prettier, much more user-friendly websites than you might otherwise be able to make on your own, certainly quickly. And in fact, let's iterate one more time on one other example before we introduce a bit of that code. Let me go ahead and open up search.html from before, which recall looked like this. And search.html in my browser was this very simple Google search. And suppose I want to reinvent google.com's UI a bit more. Here's a screenshot of google.com on a typical day. It's got an about link, a store link, Gmail, images, these weird dots, sign in, their logo. It's not appearing well on the screen here, but there's a big text box in the middle, and then 2 buttons, Google Search and I'm feeling lucky. Well, could I maybe go about implementing this UI myself using some HTML, some CSS, and maybe Bootstrap's help, just so I don't have to figure out all of these various stylizations? Well, here's my starting point in search.html. Let's go and add in Bootstrap first and foremost so that we have access to all of their classes that are reusable now. And let me go ahead and figure out how to do this. Well, just like Stanford's site had like its navigation bar using a UL, but they changed it from being a bulleted list to being left to right, I bet I can do something like this myself. So let me go into the body of my page. And first, based on Bootstrap's documentation, let me add a div called a div with a class of container fluid. Container fluid is just a class that comes with Bootstrap that says make your web page fluid, that is, grow to fill the window. So that way it's going to resize nicely. I'm going to go ahead and fix my indentation here. If you haven't discovered this yet, if you highlight multiple lines in VS Code, you can hit Tab and indent them all at once. So now I have all of that inside of this div. Now, just like in Stanford's site, let's create an unordered list that has maybe an li called with a class of nav item. And then in here, in here, let me go ahead and say a href equals https:// about.google, which is the real URL of Google's about page. And I'll put the about text in there. Then I'm going to close my li tag here. And I want to do one other thing because I'm using Bootstrap. Bootstrap's documentation, if I read it closely, says to add a class to your links called like nav link and text dark to make it dark like black or dark gray instead of the default blue. All right, so I think I have now an about link in a navigation part of my screen. Let me go ahead and save this and reload. All right, so not exactly what I wanted. It's a bulleted list still, so I need to override this somehow. Let me read Bootstrap's documentation a little more clearly, and let me pretend to do that for time's sake. If I go under content, if I go under components, and I go to navs and tabs, long story short, if you want to create a pretty menu like this, where your links are from the left to the right, just like Stanford, I essentially need HTML like this. And this is subtle, but I left off this class. I should have added a class called nav on my UL. So that was my bad. Let me go in here and say add class equals nav. And then again, this class nav item, Bootstrap told me to. Nav link text dark, Bootstrap told me to. Let me go back to my page here, reload, and OK, still kind of ugly, but at least the about link is in the top left-hand corner, just like it should be in the real google.com. Now let me whip up a couple of more links real fast. Let me go and do a little copy paste, though I bet next week we can avoid this kind of copy paste. Let me change this link to be store.google.com. The text will be store. Let me go ahead and create another one here for Gmail. So this one's going to go to officially, how about, technically it's www.google.com/gmail. Normally it just redirects. And let me grab one more of these. And for Google Images, and I'm going to paste this. Whoops. Come on. I'm going to put this here too. This is going to be images. And that URL is imghp is their URL. All right. Let me go ahead and reload the browser page. Now it's coming along, right? About, store, Gmail, images. It's not quite what I want. So I'd have to read the documentation to figure out how to maybe nudge one of these over to start right aligning it. And there's a couple of ways to do this. But one way is if I want Gmail to move all the way over and push everything else, I can say that add some margin to the Gmail list item, margin start auto. This is in Bootstrap's documentation a way of saying whatever space you have, just automatically shove everything apart. And now if I reload the page again, now, voila, Gmail and images is over to the right. All right, so now we're kind of moving along. Let me go ahead and add the big blue button to sign in. So here with sign in, let me go ahead and over in my same nav. Yeah, so let's go ahead and do one more li, class equals nav item. And then inside of this li tag, what am I going to do? Turns out there is a class that can turn a link into a button. If you say btn for button, and then button primary makes it blue. The href for this one is going to be https accounts.google.com service login, which is literally where you go if you click on that big blue button. The role of this link is that of button. And then sign in is going to be the text on it. If I now reload the page, now we're getting even closer, although it looks a little stupid. Notice that sign in is way in the top right-hand corner, whereas the real google.com has a little bit of margin around it. OK, that's an easy fix too. Let me go back into my HTML here. Let me add margin-3. This too is a Bootstrap thing. They have a class called m-something. The something is a number from like 1 to 5, I believe, that adds just some amount of white space. So if I reload now, OK, it's just a little prettier. And now let me accelerate just to demonstrate how I can take this home. Let me go ahead and open up my pre-made version of this, whereby I added to this some final flourishes. If I go to search2.html, I decided to replace their logo with just that of a cat. And notice that I re-implemented essentially google.com. Here's a text box. Here's 2 buttons, even though they're a little washed out on the screen. I even figured out how to get dots that look pretty similar to Google's. And if we view source, you can see how I kind of finished this code. If I go to View Developer Tools, and I go to Elements, and I go into this div, and I go into this div, you'll see that here's an image tag for Happy Cat. And I added some classes there to make it fluid and width 25% of the screen. If I go into the form tag, this is the same form tag as before, but notice I used button tags this time with button and button light classes, and then I stylized them in a certain way. And so in the end result, if I want to go ahead and search now for birds and click Google search, voila, I've implemented something that's pretty darn close to google.com without even touching raw CSS myself. And now here's the value then of a framework. You can just start to use off-the-shelf functionality that someone else created for you. But if you want to make refinements, you don't really like the shade of blue that Bootstrap chose or the gray button, or you want to curve things a bit more, that's where you can create your own CSS file and do the last mile, sort of fine-tuning things. And that tends to be best practice. Stand on the shoulders of others as much as you can using libraries. And then if you really don't like what the library's doing, then use your own skills and understanding of HTML and CSS to refine things a bit further. But still, after all of that, all of these examples we've done thus far are still static, other than the Google one, which searches on the real google.com. Let's take a final 5-minute break, and we'll give you a sense of what we can next do next week onward with JavaScript. See you in 5. All right. So I think it's fair to say we're about to see our very last language next week, and final projects are ultimately going to be about synthesizing so many of these. Thankfully, this language called JavaScript is quite similar syntactically to both C and Python. And indeed, if you can imagine doing something in either of those, you can probably do it in some form in JavaScript. The most fundamental difference today, though, is that when you have written C code and Python code thus far, you've done it on the server. You've done it in the terminal window environment. And when you run the code, it's running in the cloud on the server. The difference now today with JavaScript is even though you're going to write it in the cloud using VS Code, recall that when a browser gets the page containing this code, it's going to get a copy of the HTML, the CSS, and the JavaScript code. So JavaScript that we see today is all going to be executed in the browser on users' own Macs, PCs, and phones, not in the server. JavaScript can be used on the server using an environment called Node.js. It's an alternative to Python or Ruby or Java or other languages. We are using it today client-side, which is a key difference. So in Scratch, let's do this one last time. If you wanted to create a variable in Scratch setting counter equal to 0 in JavaScript, it's going to look like this. You don't specify the type, but you do use the keyword let, and there's a few others as well, that say let counter equals 0, semicolon. If you want to increment that variable by 1, you in JavaScript could say something like counter equals counter plus 1, or you can do it more succinctly with plus equals, or the plus plus is back. In JavaScript, you can now say counter plus plus semicolon again. In Scratch, if you wanted to do a conditional like this, asking if x less than y, it looks pretty much like C. The parentheses are unfortunately back. The curly braces here are back if you have multiple statements in particular. But syntactically, it's pretty much the same as it was for if else, and even for its else if else. Unlike Python, it's 2 words, again, else if. So quite like C. Nothing new beyond that. If you wanted to do something forever in Scratch, you'd use this block. In JavaScript, you can do it a few ways. Similar to Python, similar to C, you'd say while true. In JavaScript, Booleans are lowercase again, just like in C. So it's lowercase true. If you want to do something a finite number of times, like repeat 3 times, looks almost like C as well. The only difference really is using the word let here instead of int. And again, you'll use let to create a string or an int or any other type of variable in JavaScript. The browser will figure out what type you mean from context. In C, we would have said int instead. Ultimately, this language, and that's it for our tour of JavaScript syntax. There's bunches of other features, but syntactically, it's going to be that accessible, relatively speaking. The power of JavaScript running in the user's browser is going to be that you can change this thing in memory. think about most any website that's at all interesting today that you use. It's typically very interactive and dynamic. If you're sitting in front of Gmail on a laptop or desktop with the browser tab open and someone sends you an email, all of a sudden another row appears in your inbox, another row, another row. How is that implemented? Honestly, it could be an HTML table. Maybe it's a bunch of divs top to bottom. The point, though, is you don't have to hit Command R or Control R to reload the page to see more email. It automatically appears every few seconds or minutes. How is that working? When you visit gmail.com, you are downloading not just HTML and CSS with your initial inbox, presumably. You're downloading some JavaScript code that is designed to keep talking every second, every 10 seconds or something to Gmail servers. And they then are using their code to add another element, another element, another element to the existing DOM, document object model, which is the fancy term for tree in memory that represents HTML, so that the web page can continue to update in real time. Google Maps, same thing. If you click and drag and drag and drag, your browser did not download the entire world to your Mac or PC by default. It only downloaded what's in your viewport, the rectangular region. But when you click and drag, it's going to get some more tiles up there, some more images as you keep dragging, using JavaScript again behind the scenes. So let's actually use JavaScript to start interacting with pages. How can we do this? We can put the JavaScript code in the head of the page, in the body of the page, or even factor it out to a separate file. So let's take a look. Here is a new version of hello.html that during the break I just added a form to, because it'd be nice if this page didn't just say hello title, hello body. It said hello David, hello Carter, hello whoever uses it. I've got a form that I borrowed from some of our earlier code. And that form has an input whose ID is name and that also has a submit button. But there's no code in this yet. So let's add a little bit of JavaScript code as follows. Suppose that when this form is submitted, I want to greet the user. How can I do that? Well, let's do it the somewhat messy way first. I can add an attribute called onSubmit to the form element. And I can say onSubmit, call a function called greet, close quotes. Unfortunately, this function doesn't yet exist, but I can make it exist. But there's another detail here. When the user clicks submit, normally forms get submitted to the server. I don't want to do that today. I want to just submit the form to the browsers, keep on the same page, and just print on the screen, hello, David, or so forth. So I'm also going to go ahead and say return false. And this is a JavaScript way of telling the browser, even when the user tries to submit the form, return false. Like, no, don't let them actually submit the form, but do call this function called greet. In the head of my page, I'm going to add a script tag, wherein the language is implicitly JavaScript and has no relationship, for those of you who took APCS, with Java, just a similarly named language, but no relation. I am going to name a function called greet. Apparently, in JavaScript, the way you create a function is you literally say the word function instead of def. You don't specify a return type. And in this function, I could do something like this. Alert, quote unquote, how about hello there initially? I'm going to keep it simple using a built-in function called alert, which is not a good user interface. There are better ways to do this, but we're doing something simple first. Let me now go ahead and load this page again. It still looks as simple as before with just a simple text box. I'll zoom in to make it bigger. I'm going to type my name, but I think it's going to be ignored when I click submit. It just says hello there. And this is, again, this is an ugly user interface. It literally says the whole code space URL of the web page is saying this to you. It's really just meant for simple interactions like this for now. All right, let's have it say hello David somehow. Well, how can I do this? Well, if this element on the page was given by me a unique ID, it'd be nice if, just like in CSS, I can go grab the value of that text box using code. And I actually can. Let me go ahead and do this. Let me store in a variable called name the result of calling a special function called document.querySelector. This query selector function is JavaScript's version of what we were doing in CSS to select nodes using hashes or dots or other syntax. It's the same syntax. So if I want to select the element whose unique ID is name, I can literally just pass in single or double quotes hash name, just like in CSS. That gives me the actual node from the tree. It gives me one of these rectangles from the DOM, the document object model. If I actually want to get at the specific value therein, I need to go one step further and say .value. So similar in spirit to Python, where we saw a lot of dot notation, where you can go inside an object, inside of an object. That's what's going on. Long story short, in JavaScript, there is a special global variable called document that lets you just do stuff with the document, the web page itself. One of those functions is called query selector. That function returns to you whatever it is you're selecting. And .value means go inside of that rectangle and grab the actual text that the human typed in. So if I want to now say hello to that person, the syntax is a little different from C and Python. I can use concatenation, which actually does exist in Python, but we didn't use it much. I can go ahead and say hello, quote unquote, hello plus name. All right, now if I go back to the browser window, reload the page to get the latest version of the code, type in David and click submit, now I see hello David. Not the best website, but it does demonstrate how I can start to interact with the page. But let me stipulate that this commingling of languages is never a good thing. It's fine to use classes, but using style equals quote unquote in a whole bunch of CSS, that was not going to scale well once you have lots and lots of properties. Same here. Once you have more and more code, you don't want to just put your code inside of this onSubmit handler. So there's a better way. Let's get rid of that onSubmit attribute and literally never use it again. That was for demonstration's sake only. And let's do this. Let me move the script tag actually just below the form, but still inside the body, so that the script tag exists only after the form tag exists, logically. Just like in Python, your code is read top to bottom, left to right. And let me now do this. Let me define this function called greet. And then let me do this. Document.querySelector. Let me select the form on the page. It doesn't have a unique ID. It doesn't need to. I can just reference it by name, form, because there's only one of them. And let me call this special function addEventListener. This is a function that listens for events. Now, this is actually a term of art. Within programming, many different languages are governed by events. And pretty much any user interface is governed by events, especially phones. On phones, you have touches, and you have drags, and you have long press, and you have pinch, and all of these other gestures. On your Mac or PC, you have click, you have drag, you have key down, key up as you're moving your hands up and down on the keyboard. This is a non-exhaustive list of all of the events that you can listen for in the context of web programming. And this might be a throwback to Scratch, where recall Scratch let you broadcast events. And we had the two puppets sort of talking to one another via events. In the world of web programming, game programming, any human physical device these days, they're just governed by events. And you write code that listens for these events happening. So what do I want to listen for? Well, I want to add an event listener for the submit event. And when that happens, I want to call the greet function like this. So this is kind of interesting. Thank you. I have my greet function as before, no changes. But I'm adding one line of code down here. I'm telling the browser to use document.querySelector to select the form. Then I'm adding an event listener specifically for the submit event. And when that happens, I call greet. Notice I am not using parentheses after greet. I don't want to call greet right away. I want to tell the browser to call greet when it hears this submit event. Now let me go ahead and deliberately, I think, trip over something here. Let me type in my name, David, submit, and there we go. All right, hello, David. All right, but let's now make this slightly better designed. Right now, I'm defining a function greet, which is fine, but I'm only using it in one place. And you might recall we stumbled on this in Python, where I was like, why are we creating a special function called getValue when we're only using it like one line later? And we introduced what type of function in Python the other day? Yeah, so lambda functions, anonymous functions. You can actually do this in JavaScript as well. If I want to define a function all at once, I can actually do this. Let me cut this onto my clipboard, paste it over here. Let me fix all of the alignment. Let me get rid of the name. And I can actually now do this. The syntax is a little weird, but using now just these 4 lines of code, I can do this. I can tell the browser to add an event listener for the submit event. And then when it hears that, call this function that has no name. And unlike Python, this function can have multiple lines, which is actually a nice thing. It looks a little weird. There's a lot of indentation and curly braces going on now. But you can think of this as just being run these 2 lines of code when the form is submitted. But if I want to block the form from actually being submitted, I got to do one other thing. And you would only know this from being told it or reading the documentation. I need to do this function, prevent default, passing in this e argument, which is a variable that represents the event. More on that another time. That just allows us to prevent whatever the default handling of that particular event is. So long story short, this is representative of the type of code you might write in JavaScript, whereby you can actually interact with your code, the user's actual form. And we can do interesting things too. Built into browsers nowadays is functionality like this. So here's a very simple example that has just 3 buttons in it. One red, one green, one blue. Well, it turns out using JavaScript, you can control the CSS of a page programmatically. I can change the background of the body of the page to red, to green, to blue, just by listening for clicks on these buttons and then changing CSS properties. Just to give you a taste of this, if I view the page as source, similar code here, I can select the red button by an ID that I apparently defined on it, right up here. I can add an event listener, this time not for submit, but for click. And when it's clicked, I execute this one line of code. And this one line of code we haven't seen before, but you can go into the body of the page, its style property, and you can change its background color to red. This is one example of like 2 different groups not talking to one another in advance. In CSS, properties that have 2 words are usually hyphenated, like background dash color. Unfortunately, in JavaScript, if you do something dash something, that's subtraction, which is logically nonsensical here. So in CSS, you can convert background dash color to, in JavaScript, background color, where you capitalize the C and you get rid of the minus sign. What else can we do here? Well, back in the day, there used to be a blink tag. And it's one of the few historical examples of a tag that was removed from HTML. Because in the late 90s, early 2000s, this is what the web looked like. There was a lot of this kind of stuff. There was even a marquee that would move text from left to right over the screen. And the web was a very ugly place. I will admit, my very first web page probably used both of these tags. But how can we bring it back? Well, this is a version of the blink tag implemented in JavaScript. How? I wrote some code in this example that waits every 500 milliseconds to change the CSS of the page to be visible, invisible, visible, invisible. Because built into JavaScript is support for a clock. So you can just do something on some sort of schedule. Let me go ahead and open up this example, autocomplete. Let me zoom back out. In autocomplete.html, I whipped up as an example that has just a text box. But I also grabbed the dictionary from problem set 5 speller, so that if I want to search for something like apple, this searches that 140,000 words using JavaScript to create what we know in the world of the web as autocomplete. When you start searching for something, you start to see words that start with that phrase. And sure enough, if I search for something like banana, here's the 3 variants of bananas that appear in that file and so forth. How is that working? Just JavaScript. When it finds matching words, it's just updating the DOM, the tree in the computer's memory, to show more and more text or less. And for one final example, this is how programs like DoorDash and Google Maps and Uber Eats and so work. You have built into browsers today some fancy APIs, application programming interfaces, whereby you can ask for information about the user's device. For instance, here I wrote a program in geolocation.html that's apparently asking to know my location. All right, let me go ahead and allow it this time, if that's something you're comfortable with on your own device. It's taking a moment, because sometimes these things take a little while to analyze. But hopefully, in just a moment, there are apparently my GPS coordinates. And as a final flourish today for what you can do with a little bit of HTML for your structure, CSS for your style, and now JavaScript for your logic, which will tie in again next week, let me go ahead and search Google for those GPS coordinates. Zoom in here on Google Maps. And if we zoom in. OK, we're pretty close. We're not on that street. But there it is, actually. There's the marker it had put for us. We're indeed here in Memorial Hall. So all that with JavaScript, with the basic understanding of the DOM and the document object model. We'll pick up where we left off next week and now add a backend. See you next time. All right, so this is CS50, and this is week 9. And this is kind of it in terms of programming fundamentals. Today, we come rather full circle with so many of the languages that we've been looking at over the past several weeks. And with HTML and CSS and JavaScript last week, we're going to add back into the mix Python and SQL. And with that, do we have the ability to program for the web. And even though this isn't the only user interface out there, increasingly are people certainly using laptops and desktops and a browser to access applications that people have written. But it's also increasingly the way that mobile apps are written as well. There are languages called Swift for iOS. There are languages called Java for Android. But coding applications in both of those languages means knowing twice as many language, building twice as many applications potentially. So we're increasingly seeing, for better or for worse, that the world is starting to really standardize, at least for the next some number of years, on HTML, CSS, and JavaScript, coupled with other languages like Python and SQL on the so-called backend. And so today, we'll tie all of those together and give you the last of the tools in your toolkit with which to tackle final projects, to go off into the real world ultimately, and somehow solve problems with programming. But we need an additional tool today, and we've sort of outgrown HTTP server. This is just a program that comes on certain computers that you can install for free, happens to be written in a language called JavaScript, but it's a program that we've been using to run a web server in VS Code. But you can run it on your own Mac or PC or anywhere else. But all this particular HTTP server does is serve up static content, like HTML files, CSS files, JavaScript files, maybe images, maybe video files, but just static content. It has no ability to really interact with the user beyond simple clicks. You can create a web form and serve it visually using HTTP server. But if the human types in input into a form and clicks submit, unless you submit it elsewhere to something like google.com, like we did last time, it's not actually going to go anywhere because this server can't actually process the requests that are coming in. So today, we're going to introduce another type of server that comes with Python that allows us to not only serve web pages, but also process user input. And recall that all that input is going to come ultimately from the URL or more deeply inside of those virtual envelopes. So here's like the canonical URL we talked about last week for a random website like www.example.com. And I've highlighted the slash just to connote the root of the web server, like the default folder where presumably there's a file called index.html or something else in there. Otherwise, you might have a more explicit mention of the actual file name, file.html. You can have folders, as you probably gleaned from the most recent problem set. You can have files in folders like this. And these are all examples of what a programmer would typically call a path. So it might not just be a single word. It might have multiple slashes and multiple folders and subfolders and files. But this is just more generally known as a path. But there's another term of art that's essentially equivalent that we'll introduce today. This is also synonymously called a route, which is maybe a better generic description of what these things are, because it turns out they don't have to map to, that is, refer to a specific folder or a specific file. You can come up with your own routes in a website and just make sure that when the user visits that, you give them a certain web page. If they visit something else, you give them a different web page. It doesn't have to map to a very specific file, as we'll soon see. And if you want to get input from the user, just like Google does, like q equals cats, you can add a question mark at the end of this route, the key or the HTTP parameter name that you want to define for yourself, and then equals some value that presumably the human typed in. If you have more of these, you can put an ampersand, and then more key equals value pairs, ampersand, repeat, repeat, repeat. The catch, though, is that using the tools that we had last week alone, we don't really have the ability to parse, that is, to analyze and extract things like q equals cats. You could have appended question mark q equals cats or anything else to any of your URLs in your home page for problem set 8, but it doesn't actually do anything useful necessarily unless you use some fancy JavaScript. The server is not going to bother even looking at that for you. But today, we're going to introduce, using a bit of Python, and in fact, we're going to use a web server implemented in Python instead of using HTTP server alone to automatically, for you, look for any key value pairs after the question mark and then hand them to you in the form of a Python dictionary. Recall that a dictionary in Python, a dict object, is just key value pairs. That seems like a perfect fit for these kinds of parameters. And you're not going to have to write that code yourself. It's going to be handed to you by way of what's called a framework. So this will be the second of two frameworks, really, that we look at in the class. And a framework is essentially a bunch of libraries that someone else wrote and a set of conventions, therefore, for doing things. So those of you who really started dabbling with Bootstrap this past week to make your home pages prettier and nicely laid out, you were using a framework. Why? Well, you're using libraries, code that someone else wrote, like all the CSS, maybe some of the JavaScript that the Bootstrap people wrote for you. But it's also a framework in the sense that you kind of have to go all in. Like you have to use Bootstrap's classes, and you have to kind of lay out your divs or your spans or your table tags in a sort of Bootstrap-friendly way. And it's not too onerous, but you're following conventions that a bunch of humans standardized on. So similarly, in the world of Python, is there another framework we're going to start using today? And whereas Bootstrap is used for CSS and JavaScript, Flask is going to be used for Python. And it just solves a lot of common problems for us. It's going to make it easier for us to analyze the URLs and get at key value pairs. It's going to make it easier for us to find files or images that the human wants to see when visiting our website. It's even going to make it easier to send emails automatically. Like when someone fills out a form, you can dynamically, using code, send them an email as well. So Flask, and with it some related libraries, is just going to make stuff like that easier for us. And to do this, all we have to do is adhere to some pretty minimalist requirements of this framework. We're going to have to create a file for ourselves called app.py. This is where our web app or application is going to live. If we have any libraries that we want to use, the convention in the Python world is to have a very simple text file called requirements.txt, where you list the names of those libraries top to bottom in that text file, similar in spirit to the include or the import statements that we saw in C and Python respectively. We're going to have a static folder or static directory, which means any files you create that are not ever going to change, like images, CSS files, JavaScript files, they're going to go in this folder. And then lastly, any HTML that you write, web pages you want the human to see, are going to go in a folder called templates. So this is, again, evidence of what we mean by a framework. Like, do you have to make a web app like this? No. But if you're using this particular framework, this is what people decided would be the human conventions. If you've heard of other frameworks like Django or ASP.NET or bunches of others, there are just different conventions out there for creating applications. Flask is a very nice micro framework in that that's it. Like, all you have to do is kind of adhere to these pretty minimalist requirements to get some code up and running. All right. So let's go ahead and make a web app. Let me go ahead and switch over to VS Code here. And let me practice what I'm preaching here by first creating app.py. And let's go ahead and create an application that very simply maybe says hello to the user. So something that initially is not all that dynamic, pretty static, in fact, but we'll build on that as we've always done. So in app.py, what I'm going to do first is exactly the line of code I had on the screen earlier. From Flask, import Flask with a capital F second and a lowercase f first. And I'm also going to preemptively import a couple of functions, render template and request. More on those in just a bit. And then below that, I'm going to say, go ahead and do this. Give me a variable called app that's going to be the result of calling the Flask function and passing in it this weird incantation here, name. So we've seen this a few weeks back when we played around with Python and we had that if main thing at the bottom of the screen. For now, just know that underscore underscore name underscore underscore refers to the name of the current file. And so this line here, simple as it is, tells Python, hey, Python, turn this file into a Flask application. Flask is a function that just figures out then how to do the rest. The last thing I'm going to do for this very simple web application is this. I'm going to say that I'm going to have a function called index that takes no arguments. And whenever this function is called, I want to return the results of rendering a template called index.html. And that's it. So let's assume there's a file somewhere, haven't created it yet, called index.html. But render template means render this file. That is, print it to the user's screen, so to speak. The last thing I'm going to do is I have to tell Flask when to call this index function. And so I'm going to tell it to define a route for quote unquote slash. And that's it. So let's take a look at what I just created here. This is slightly new syntax, and it's really the only weirdness that we'll have today in Python. This is what's known in Python as what's called a decorator. A decorator is a special type of function that modifies essentially another function. For our purposes, just know that on line 6, this says, hey, Python, define a route for slash, the default page on my web application. The next two lines, 7 and 8, say, hey, Python, define a function called index, takes no arguments. And the only thing you should ever do is return render template of quote unquote index.html. All right, so that's it. So really the next question naturally should be like, all right, well, what is in index.html? Well, let me go ahead and do that next. Let me create a directory called templates, practicing again what I preached earlier. So I'm going to create a new empty directory called templates. I'm going to go and cd into that directory and then do code of index.html. So here's going to be my index page. And I'm going to do a very simple web page, doc type HTML. Just going to borrow some stuff from last week. HTML, language equals English. I'll close that tag. I'll then do a head tag. I'll do a meta tag, the name of which is viewport. This makes my site, recall, responsive. That is, it just grows and shrinks to fit the size of the device. The initial scale for which is going to be 1, and the width of which is going to be device width. So I'm typing this out. I have it printed here. This is stuff I typically copy paste. But then lastly, I'm going to add in my title, which will just be hello for the name of this app. And then the body, the body of this tag will be, there we go. The body of this page, rather, will just be hello, comma, world. So very uninteresting and really kind of a regression to where we began last week. But let's go now and experiment with these two files. I'm not going to bother with a static folder right now because I don't have any other files that I want to serve up. No images, no CSS, nothing like that. And honestly, requirements.txt is going to be pretty simple. I'm going to go requirements.txt and just say, make sure the system has access to the Flask library itself. All right, but that's the only thing I'm going to add in there for now. All right, so now I have two files, app.py, and I have index.html. But index.html, thank you, is inside of my templates directory. So how do I actually start a web server? Last week I would have said HTTP server, but HTTP server is not a Python thing. It has no idea about Flask or Python or anything I just wrote. HTTP server will just spit out static files. So if I ran HTTP server and then I clicked on app.py, I would literally see my Python code. It would not get executed because HTTP server is just for static content. But today I'm going to run a different command called Flask run. So this framework Flask that I actually pre-installed in advance, so it wasn't strictly necessary that I create that requirements.txt file just yet, comes with a program called Flask, takes command line arguments like the word run. And when I do that, you'll see somewhat similar output to last week, whereby you'll see the name, your URL for your unique preview of that. You might see a pop-up saying that your application is running on TCP port something or other. By default, last week we used port 8080. Flask, just because, prefers port 5000. So that's fine too. I'm going to go ahead and open up this URL now. And once it authenticates and redirects me just to make sure I'm allowed to access that particular port, let me zoom in. Voila, there's the extent of this application. If I view source by right-clicking or control-clicking, there's my HTML that's been spit out. So really, I've just reinvented the wheel from last week because there's no dynamism now, nothing at all. But what if I do this? Let me close the source and let me zoom out so you can see my URL bar. Let me zoom in now, and I have a very unique cryptic URL. But the point is that it ends with nothing, or implicitly, it ends with slash. This is just Chrome being a little helpful. It doesn't bother showing you a slash, even though it's implicitly there. But let me do something explicit like my name equals quote unquote David. So there's a key value pair that I've manually typed into my URL bar and hit enter. OK, nothing happens, nothing changes. It still says hello world. But the opportunity today is to now dynamically get at the input from that URL and start displaying it to the user. So let me go back over here to my terminal window and code. Let me move that down to the bottom there. And what if I want to say, hello name? I ideally want to say something like, I don't want to hard code David because then it's never going to say hello to anyone else. I kind of want to put like a variable name here, like name should go here, but it's not an HTML tag, so I need some kind of placeholder. Well, here's what I can do. If I go back to my Python code, I can now define a variable called name, and I can ask Flask to go into the current request, into its arguments, that is in the URL as they're called, and get whatever the value of the parameter called name is. That puts that into a variable for me. And then in render template, this is one of those functions that can take more than one argument. If it takes another argument, you can pass in the name of any variable you want. So if I want to pass in my name, I can literally say name equals name. So this is the name of a variable I want to give to the template. This is the actual variable that I want to get the value from. And now lastly, in my index.html, the syntax as of today in Flask is to do 2 curly braces and then put the name of the variable that you want to plug in. So here's what we mean by a template. A template is kind of like a blueprint in the real world where it's like plans to make something. This is the plan to make a web page that has all of this code literally, but there's this placeholder with 2 curly braces here and here that says go ahead and plug in the value of the name variable right there. So in this sense, it's similar in spirit to our f strings or format strings in Python. The syntax is a little different, just because reasonable people disagree. Different people, different frameworks come up with different conventions. The convention in Flask in their templates is to use 2 curly braces here. The hope is that you, the programmer, will never want to display 2 curly braces in your actual web page. But even if you do, there's a workaround. We can escape that. So now let me go ahead and go back to my browser tab here. Previously, even though I added name equals David to the end of the URL with a question mark, it still said hello world. But now, hopefully, if I made these changes, let me go ahead and open up my terminal window. Let me restart Flask so it loads my changes by default. Let me go back to my Hello tab and click Reload so it grabs the page anew from the server. And there we go. Hello, David. I can play around now, and I can change the URL up here to, for instance, Carter. Zoom out, hit Enter, and now we have something more dynamic. So the new pieces here are, in Python, we have some code here that allows us to access programmatically everything that's after the question mark in the URL. And the only thing we have to do that is call this function request.args.get. You and I don't have to bother figuring out where's the question mark, where's the equal sign, where are the ampersands potentially. The framework, Flask, does all of that for us. OK, any questions then on these principles thus far? Yeah, in back. Why do you need a question mark in the URL? The short answer is just because that is where key value pairs must go if you're making a GET request from a browser to a server. The convention standardized by the HTTP protocol is to put them in the URL after the so-called route or path, then a question mark. And it delineates what's part of the route or the path and what's part of the human input to the right. Other questions? Yeah? Sure. This is this annoying thing about Python. When you pass in parameters to functions that have names, you typically say something equals something else. So let me make a slight tweak here. How about I say name of person here? This allows me to invent my own variable for my template and assign it the value of name. I now, though, have to go into my index file and say name of person. Did I get that right? Name of person. Yeah. So these two have to match. And so this is just kind of stupid because it's unnecessarily verbose. So what typically people do is they just use the same name as the variable itself, even though it looks admittedly kind of stupid. But it has 2 different roles. The thing to the left of the equal sign is the name of the variable you plan to use in the template. The thing on the right is the actual value you're assigning it. And this is because it's general purpose. I could override this, and I could say something like name always equals Emma, no matter what that variable is. And now if I go back to my browser and reload, no matter what's in the URL, David or Carter, it's always OK, Emma broke the server. What did I do? Oh, I didn't change my template back. There we go. Let me change that back to be name so that it's name there and it's name here. But I've hard-coded Emma's name. So now we're only ever going to see Emma, no matter whose name is in the URL. That's all. All right. So this is kind of bad user interface if in order to get a greeting for the day, you, the user, have to manually change the URL, which none of us ever do. This is not like how web pages work. What is the more normal mechanism for getting input from the user and putting it in that URL automatically? How did we do that last week with Google, if you recall?
We had the search bar, and then we made the icon, and make something there.
OK, so we did make something in order to get the input from the user. And specifically, what was the tag or the terminology we used last week? Sorry, a little louder? Oh, no. But yeah. so the input tag inside of the form tag. So in short, forms are, of course, like how the web works and how we typically get input from the user, whether it's a button or a text box or a drop-down menu or something else. So let's go ahead and add that into the mix here. So let's enhance this hello app to do a little something more by this time just doing this. Let me get rid of this name stuff. And let me just have a very simple index.html file that by default is going to simply ask the user for some input as follows. I'm going to go back into my index.html. And instead of printing out the user's name, this is the page I'm going to use to actually get input from the user. So I'm going to create a form tag. The method I'm going to use for now is going to be quote unquote get. Then inside of that form, I'm going to have an input tag. And I'm going to turn off autocomplete like we did last week. I'm going to turn on autofocus so it puts the cursor in the text box for me. I'm going to give the name of this input the name. Not to be too confusing, but I'm asking the human for their name. So it makes sense that the name of the input should be quote unquote name. The placeholder I want the human to see in light gray text will be name with a capital N, just so it's a little grammatical. And then type of this text field. Type of this input is going to be text. Then I'm just going to give myself, like last week, a submit button. And I don't care what it says. It's just going to say the default submit terminology. Let me go ahead now and open up my terminal window again. Let me go to that same URL so that I can see. Whoops. There we go. So that was just cached from earlier. Let me go back to that same URL, my GitHub preview.dev URL. And here I have the form. And now I can type in anything I want. The catch, though, is when I click submit, where is it going to go? Well, let's be explicit. It does have a default value. But let me go into my index.html. And let me add, just like we did last week for Google, whereas previously I said something like www.google.com/search. But today, we're not going to rely on some third party. I'm going to implement the so-called backend. And I'm going to have the user submit this form to a second route, not just slash, but how about /greet? I can make it up. Whatever I want, greet feels like a nice operative word. So /greet is where the user will be sent when they click submit on this form. All right, so let's go ahead now and go back to my browser tab. Let me go ahead actually and let me reload Flask here so that it reloads all of my changes. Let me reload this tab so that I get the very latest HTML. And indeed, quick safety check. If I view page source, we indeed see that my browser has downloaded the latest HTML. So it definitely has changed. Let's go ahead and type in David. And when I click submit here, what's going to happen? Hypotheses. What's going to happen visually, functionally, however you want to interpret when I click submit? Yeah. OK, the user's going to go to an empty page. Pretty good instinct, because nowhere else have I mentioned /greet. Doesn't seem to exist. How's the URL going to change, just to be clear? What's going to appear suddenly in the URL? Yeah. 404? No, not in the URL. Specifically in the URL, something's going to get added automatically when I click. The key value pair, right? That's how forms work. That's why our Google trick last week worked. I sort of recreated a form on my own website. And even though I didn't get around to implementing google.com itself, I can still send the information to Google, just relying on browsers standardizing, to your question earlier, that whenever you submit a form, it automatically ends up after a question mark in the URL if you're using get. So both of you are right. This is going to break. And all three of you are right, in effect. 404 not found. You can see it in the tab here. That's the error that has come back. But what's interesting and most important, the URL did change. And it went to /greet name equals David. So I just now need to add some logic that actually looks for that so-called route. So let me go back to my app.py. Let me define another route for quote unquote /greet. And then under this, let me define another function. I'll call it greet, but I could call it anything I want. No arguments for now for this. And then let me go ahead and do this. In my app.py this time around, I do want to get the human's name. So let me say request.args get quote unquote name. And let me store that in a variable called name. Then let me return a template. And you know what? I'm going to give myself a new template, greet.html, because this has a different purpose. It's not a form. I want to say hello to the user in this HTML file. And I want to pass into it the name that the human just typed in. All right. So now, if I go up and reload the page, what might happen now? Other logical check here. If I go ahead and hit reload or resubmit the form, what might happen now? Any instincts? Let me try. So let's try this. Let's go ahead and reload the page. Previously, it was not found. Now it's worse. And this is the 500 error, internal server error, that I promise next week we will all encounter accidentally, ultimately. But here we have an internal server error because it's an internal error. This means something's wrong with your code. So the route was actually found, because it's not a 404 this time. But if we go into VS Code here and we look at the console, the terminal window, you'll see that this is actually a bit misleading. Do I want to do this? Let me reload this. Let me reload here. Oh, stand by. Come on. There we go. Come on. OK. Here we have this error here. And this is where your terminal window is going to be helpful. In your terminal window, by default, is typically going to go helpful stuff like a log. LOG of what it is the server is seeing from the browser. For instance, here's what the server just saw in purple. Get/greet name equals David using HTTP version 1.0. Here, though, is the status code that the server returned 500. Why? What's the error? Well, here's where we get these annoying, pretty cryptic Python messages that Help 50 might ultimately help you with. Or here, we might just have a clue at the bottom. And this is actually pretty clear, even though we've never seen this error before. What did I screw up here? I just didn't create greet.html, right? Template not found. All right, so that must be the last piece of the puzzle. And again, representative of how you might diagnose problems like these. Let me go into my terminal window after hitting Control-C, which cancels or interrupts a process. Let me go into my templates directory. If I type ls, I only have index.html. So let's code up greet.html. And in this file, let's quickly do doctype HTML, open bracket HTML, language equals English. Inside of this, I'll have the head tag. Inside of here, I'll have the meta. The name is viewport, the content of which is, see, I always forget this too. The content of which is initial scale equals 1, width equals device width, quote unquote. Title is still going to be, I'll call this greet because this is my template. And then here in the body, I'm going to have hello, comma, name. So I could have kept around the old version of this, but I just recreated essentially my second template. So index.html now is almost the same, but the title is different and it has a form. Greet.html is almost the same, but it does not have a form. It just has the hello, comma, name. So let me now go ahead and rerun in the correct directory. You have to run Flask wherever app.py is, not in your templates directory. So let me do Flask run to get back to where I was. Let me go into my other tab, cross my fingers this time that when I go back to slash and I get index.html's form, now I type in David and click submit. Now we get hello, David. And now we have kind of a full-fledged web app that has two different routes, slash and slash greet, the latter of which takes input like this, and then using a template, spits it out. But something could go wrong. Let's see what happens here. Suppose I don't type anything in. Let me go here and just click submit. Now, I mean, it looks kind of stupid. So there's bunches of ways we could solve this. I could require that the user have input on the previous page. I could have some kind of error check for this. But there's another mechanism I can use that I'll just show you. It turns out this get function in the context of HTTP and also in general with Python dictionaries, you can actually supply a default value. So if there is no name parameter or no value for a name parameter, you can actually give it a default value like this. So I'll say world, for instance. Now let me go back here. Let me type in nothing again and click submit. And hopefully this time oops, sorry. Let me restart Flask to reload the template. Let me go ahead and type nothing this time, clicking submit. And hopefully we now, oh, interesting. I should have faked this. Suppose that the reason this, suppose I just get rid of name altogether like this and hit enter. Now I see hello world. And this is a subtlety that I didn't intend to get into here. When you have question mark name equals nothing, you're passing in what's called, when you have greet question mark name equals something, you actually are giving a value to name. It is quote unquote with nothing in between. That is different from having no value at all. So allow me to just propose that the error here, we would want to require this in a different way. And probably the most robust way to do this would be to go in here in my HTML and say that the name field is required. Now if I go back to my form after restarting Flask here, and I go ahead and click reload on my form and type in nothing and click submit, now the browser is going to yell at me. But just as a teaser for something we'll be doing in the next problem set in terms of error checking, you should never, ever, ever rely on client-side safety checks like this. Because we know from last week that a curious programmer can go to inspect. And let me poke around the HTML here. Let me go into the body, the form. OK, you say required. I say not required. You can just delete what's in the DOM in the browser. And now I can go ahead and submit this form, and it appears to be broken. Not a big deal with a silly little greeting application like this. But if you're trying to require that humans actually provide input that is necessary for the correct operation of the site, you don't want to trust that the HTML is not altered by some adversary. All right, any questions then on this particular app before we add another feature here? Any questions here? Yeah. Sorry, a little louder. In the index function? No, sorry? Would it be a problem if what? No, I mean, no, this is OK. What you should really do is something we're going to do with another example where I'm going to start error checking things. So let me wave my hands at that and propose that we'll solve this better in just a bit. But it's not bad to do what I just did here. It's only going to handle one of the scenarios that I was worried about, not all of them. All right, so even though this is new to most of us here, consider index.html, my first template, and consider greet.html, my second template. What might be arguably badly designed, even though this might be the first time you've ever touched web programming like this? Like, what's kind of bad or dumb about this design of these two templates alone? And there's a reason, too, that I kind of bored us by typing it out that second time. Yeah? Yeah, there's so much repetition. I mean, it was kind of deliberately tedious that I was retyping everything, the doc type, the HTML tag, the head tag, the title tag. And little things did change along the way, like the title and certainly the content of the body. But so much of this, I mean, almost all of the page is a copy of itself in multiple files. And God forbid we have a third template, a fourth template, a 100th template for a really big website. This is going to get very tedious very quickly. And suppose you want to change something in one place, you're going to have to change it now in 2, 3, 100 different places instead. So just like in programming more generally, we have this ability to factor out commonalities, so do you in the context of web programming, and specifically templating, have the ability to factor out all of those commonalities. The syntax is going to be a little curious, but it functionally is pretty straightforward. Let me go ahead and do this. Let me go ahead and copy the contents of index.html. Let me go into my templates directory and code a file that by default is called layout.html. And let me go ahead and, per your answer, copy all of those commonalities into this file now instead. So here I have a file called layout.html. I don't want to give every page the same title, maybe. But for now, that's OK. I'm going to call everything hello. But in the body of the page, what I'm going to do here is just have a placeholder for actual contents that do change. So in this layout, I'm going to go ahead and here and just put in the body of my page, how about this syntax? And this is admittedly new. Block body, and then %, close curly brace. And then I'm going to do end block. So kind of a curious syntax here. But this is more template syntax. The other template syntax we saw before was the 2 curly braces. That's for just plugging in values. There's this other syntax with Flask that allows you to say a single curly brace, a %, and then some functionality like this, defining a block. And this one's a little weird because there's like literally nothing between the close curly and the open curly brace here. But let's see what this can do for us. Let me now go into my index.html, which is where I kind of borrowed most of that code from. And let me focus on what is minimally different. The only thing that's really different in this page, title aside, is the form. So let me go ahead and just cut that form out to my clipboard. Let me change the first line of index.html to say this. This file is going to extend layout.html. And notice I'm using the curly braces again. And this file is going to have its own body block, inside of which is just the HTML that I actually want to make specific to this page. And I'll keep my indentation nice and neat here. And let's consider what I've done. This is starting to look weird fast. And this is now a mix of HTML with templating code. Index.html, first line now says, hey, Flask, this file extends layout.html, whatever that is. This next line, 3 through 10, says, hey, Flask, here is what I consider my body block to be. Plug this into the layout's placeholder, therefore. So if I now go back to layout.html, in layout.html, it's almost all HTML by contrast, but there is this placeholder. And if I want to put a default value, I could say, whoops, if I want to put a default value, I could put a default value there just in case some page does not have a body block. But in general, that's not going to be relevant. So this is just a placeholder, albeit a little verbose, that says plug in the page-specific content right here. So if I go now into greet.html, this one's even easier. I'm going to cut this content and get rid of everything else. Greet.html2 is going to extend layout.html, extends plural. And then I'm going to have my body block here simply be this one line of code. And then I'm going to go ahead and end that block here. These are not HTML tags. This is not HTML syntax. Technically, the syntax we keep seeing with the curly braces and these now curly braces with percent signs is an example of Jinja syntax, Jinja, which is a language that some humans invented for this purpose of templating. And the people who invented Flask decided we're not going to come up with our own syntax. We're going to use these other people's syntax called Jinja syntax. So again, there starts to be at this point in the course and really in computing a lot of sharing now of ideas and sharing of code. So Flask is using this syntax, but other libraries and other languages might also too. All right, so now index.html, is half HTML, half templating code, Jinja syntax. Greet.html is almost all Jinja syntax, no tags even. But because they both extend layout.html, now I think I've kind of improved the design of this thing. If I go back to app.py, none of this really needs to change. I don't change my templates to mention layout.html. That's already implicit in the fact that we have the extends keyword. So now if I go ahead and open my terminal window, go back to the same folder as app.py and do flask run. All right, my application is running on port 5000. Let me now go back to the /route in my browser and hit enter. I have this form again. And just as a little check, let me view the source of the page that my browser is seeing. And there's all of the code. No mention of Jinja, no curly braces, no percent signs, just HTML. It's not quite pretty printed in the same way, but that's fine because now we're starting to dynamically generate websites. And by that I mean this isn't quite indented nicely or perfectly. That's fine. If it's indented in the source code version, doesn't matter what the browser really sees. Let me now go ahead and type in my name, click submit. I should see, yep, hello David. Let me go ahead and view the source of this page, and we'll see almost the same thing with what's plugged in there. So this is now web programming in the literal sense. I did not hard code a page that says hello, David, hello, Carter, hello, Emma. I hard coded a page that has a template with a placeholder, and now I'm using actual logic, some code in app.py to actually tell the server what to send to the browser. All right, any questions then on where we're at here? This is now a web application. Simple though it is, it's no longer just a website. Yeah?
What we do is just better for design or for memory?
Is it better for design or for memory? Both. It's definitely better for design because truly, if we had a third page, fourth page, I would really start just resorting to copy paste. And as you saw with home page, often in the head of your page, you might want to include some CSS files like Bootstrap or something else. You might want to have other information up there. If you had to upgrade the version of Bootstrap or you changed libraries or you want to change one of those lines, you would literally have to go into like 3, 4, 100 different files to make one simple change. So that's bad design. And in terms of memory, yes, theoretically the server, because it knows there's this common layout, it can theoretically do some optimizations underneath the hood. Flask is probably doing that, but not in the mode we're using it. We're using it in development mode, which means it's typically reloading things each time. Other questions on this application? Anything at all? All right, so let me ask a question, not just in terms of the code design. What about the implications for privacy? Like, why is this maybe not the best design for users, how I've implemented this? I've used a web form, but yeah. Yeah, I mean, if you have a nosy sibling or roommate and they have access to your laptop and they just go trolling through your autocomplete or your history, like literally what you typed into a website is going to be visible. Not a big deal if it's your name, but if it's your password, your credit card, or anything else that's mildly sensitive, you probably don't want it ending up in the URL at all. Even if you're in incognito mode or whatnot, like you just don't want to expose yourself or your users to that kind of risk. So perhaps we can do better than that. And fortunately, this one's actually an easy change. Let me go into my index.html where my form is. And in my form, I can just change the method from get to post. It's still going to send key value pairs to the server, but it's not going to put them in the URL. The upside of which is that we can assuage this privacy concern, but I'm going to have to make one other change too, because now if I go ahead and run Flask again after making that change, and I now reload the form to make sure I have the latest version, you should be in the habit of going to view developer, view source, or developer tools just to make sure that what you're seeing in your browser is what you intend. And yes, I do see what I wanted. Method equals post now. Let me go ahead and type in David and click submit. Now I get a different error. This one is HTTP 405, method not allowed. Well, why is that? Well, in my Flask application, I've only defined a couple of routes so far, one of which is for slash. Then that worked fine. One of which is for /greet, and that used to work fine. But apparently, what Flask is doing is it only supports get by default. So if I want to change this route to support different methods, I can say, quote unquote, post inside of this parameter here, so that now I can actually support post, not just get. And if I now restart Flask, so Flask run, enter, and I go back to this URL. Let me go back one screen to the form, reload the page just to make sure I have the latest, even though nothing there has changed. Type David and click submit now. Now I should see hello world. Notice that I'm at the /greet route, but there's no mention of name equals anything in the URL. All right, so that's kind of an interesting takeaway, right? Like it's a simple change, but whereas get puts things in the URL, post does not, but it still works so long as you tweak the back end to look as a post request, which kind of means look deeper in the envelope. It's not going to be as simple as looking at the URL itself. Why shouldn't we just always use post? Like, why not use post everywhere? Any thoughts? Right? Because it's kind of obnoxious to be putting any information in URLs if you're leaving these little breadcrumbs in your history, and people can poke around and see what you've been doing. Yeah, what do you think? Yeah, I mean, if you get rid of get requests and put nothing in the URL, your history, like your autocomplete, gets pretty less useful, right? Because none of the information is therefore stored. So you can't just go through the menu and hit enter. You'd have to like refill out the form. And there's this other symptom that you can see here. Let me zoom out and let me just reload this page. Notice that you'll get this warning, and it'll look different in Safari and Firefox and Edge and Chrome here, confirm form submission. So your browser might remember what your inputs were, and that's great, but just while you're on the page. And this is in contrast to get, where the state state is information, like key value pairs is embedded in the URL itself. And if you looked at an email I sent earlier today, I deliberately linked to https://www.google.com/search *Q equals what plus time plus is plus it. This is by definition a GET request when you click on it, because it's going to grab the information, the key value pair, from the URL, send it to Google Server, and it's just going to work. And the reason I sent this via email earlier was I wanted people to very quickly be able to check what is the current time, and so I can sort of automate the process of creating a Google search for you, but that you induce when you click that link. If Google did not support GET, they only supported this, the best I could do is send you all to this URL, which unfortunately has no useful information. I would have had to add to my email, by the way, type in the words, what time is it? So it's just bad for usability. So there, too, we might have design when it comes to the low-level code, but also the design when it comes to the user experience, or UX, as a computer scientist would call it, just in terms of what you want to optimize for. Ultimately. So get and post both have their roles. It depends on what kind of functionality you want to provide and what kind of sensitivity there might be around it. All right, any questions then on this, our first web application? Super simple, just gets someone's name and prints it back out. But we kind of now have all the plumbing with which to create really most anything we want. No? All right, let's go ahead and take a 5-minute break. And when we come back, we'll add to this some first-year intramural sports. All right, so we are back. And recall that the last thing we just changed was the route to use post instead of get. So gone is my name and any value in the URL. But there was kind of a subtle bug or change here that we didn't call out earlier. Like, I did type David into the form, and I did click submit. And yet here it is saying hello, comma, world. So that seems to be broken all of a sudden, even though we added support for post. But something must be wrong. Logically, it must be the case here intuitively that if I'm seeing hello world, that's the default value I gave the name variable. It must be that it's not seeing a key called name in request.args, which is this gives you access to everything after the URL. That's because there's this other thing we should know about, which is not just request.args, but request.form. These are horribly named, but request.args is for get requests. Request.form is for post requests. Otherwise, they're pretty much functionally the same, but the onus is on you, the user, or the programmer, to make sure you're using the right one. So I think if we want to get rid of the world and actually see what I, the human, typed in, I think I can just change request.args to request.form, still .get, still quote-unquote name. And now, if I go ahead and rerun Flask, and my terminal window, go back to my browser, go back to, and actually, I won't even go back to the form. I will literally just reload, Command R or Control R. And what this warning is saying is it's going to submit the same information to the website. When I click Continue, now I should see hello, comma, David. So again, you too are going to encounter probably all these kinds of like little subtleties. But if you focus on really the first principles of last week, like what is HTTP? How does a GET request work? How does a POST request work now? You should have a lot of the mental building blocks with which to solve problems like these. And let me give you one other mental model now for what it is we're doing. This framework called Flask is just an example of many different frameworks that all implement the same paradigm, the same way of thinking and the same way of programming applications. And that's known as MVC, Model View Controller. And here's a very simple diagram that represents the process that you and I have been implementing thus far. And actually, this is more than we've been implementing thus far. In app.py is what a programmer would typically call the controller. That's the code you're writing, the so-called business logic that makes all of the decisions, decides what to render, what values to show, and so forth. In layout.html, index.html, greet.html is the so-called view. Templates, that is the visualizations that the human actually sees, the user interface. Those things are kind of dumb. They pretty much just say, plop some values here. All of the hard work is done in app.py. So controller, aka app.py, is where your Python code generally is. And in your view is where your HTML and your Jinja code, your Jinja templating, the curly braces with percent signs usually is. We haven't added an M to MVC yet, model. That's going to refer to things like CSV files or databases. The model, where do you keep actual data? typically long term. So we'll come back to that. But this picture where you have one of these, each of these components kind of intercommunicating with one another is representative of how a lot of frameworks work. What we're teaching today, this week, is not really specific to Python. It's not really specific to Flask, even though we're using Flask. It really is a very common paradigm that you could implement in Java, C#, or bunches of other languages as well. All right, so let's now pivot back to VS Code here. Let me stop running Flask, and let me go ahead and create a new folder altogether after closing these files here. And let me go ahead and create a folder called Frosh IMs, representing freshman intramural sports or first year intramural sports that I can now CD into. And now I'm going to code an app.py. And in anticipation, I'm going to create another templates directory, this one in the Frosh IMs folder. And then in my templates directory, I'm going to create a layout.html. And I'm just going to get myself started here. Frosh IMs will go here. I'm just copying my layout from earlier, because most of my interesting work this time is now going to be initially in app.py. So what is it we're creating? So like literally the very first thing I wrote as a web application like 20 years ago was a site that literally looked like this. So I was like a sophomore or junior at the time. I'd taken CS50 and a follow-on class only. I had no idea how to do web programming. Neither of those two courses taught web programming back in the day. So I taught myself at the time a language called Perl. And I learned a little something about CSV files. And I sort of read enough, can't even say Googled enough because Google didn't come out for a couple of years later, read enough online to figure out how to make a web application so that students on campus, first years, could actually register via a website for intramural sports. Back in my day, you would literally fill out a piece of paper and then walk it across the yard to Wigglesworth Hall, one of the dorms, slide it under the dorm of the proctor or RA, and thus you were registered for sports. So 1996, 1997, like we could do better by then. There was an internet, just wasn't really being used much on campus or more generally. So background images that repeat infinitely was kind of in vogue apparently at the time. All of this was like images that I had to hand make because we did not have the features that JavaScript and CSS nowadays have. So it was really just HTML. And it was really just controller code written not in Python but in Perl. And it was really just the same building blocks that we here already today now have. So we'll get rid of all of the imagery and focus more on the functionality and the aesthetics. But let's see if we can't whip up a web application via which someone could register for one such intramural sport. So in app.py, let me go ahead and import some familiar things now. From Flask, let's import capital Flask, which is that function we need to kickstart everything. Render template, so we have the ability to render, that is, print out those templates. And request, so that we have the ability to get at input from the human. Let me go ahead and create the application itself using this magical incantation here. And then let's go ahead and define a route for slash, for instance, first. I'm going to define a function called index. But just to be clear, this function could be anything. Foo, bar, baz, anything else. But I tend to name them in a manner that's consistent with what the route is called. But you could call it anything you want. It's just the function that will get called for this particular route. Now let me go ahead here and just get things started. Return render template of index.html. Just keep it simple, nothing more. So there's nothing really Frosh IM specific about this here. I just want to make sure I'm doing everything correctly. Meanwhile, I've got my layout. OK, let me go ahead and in my templates directory code a file called index.html. And let's just do extends layout.html at the top, just so that we get benefit from that template. And down here, I'm just going to say to do, just so that I have something going on visually to make sure I've not screwed up yet. In my Frosh IMs directory, let me do Flask run. Let me now go back to my previous URL, which used to be my hello example. But now I'm serving up the Frosh IMs site. Oh, and I'm seeing nothing. That's because I screwed up accidentally. What did I do wrong in index.html? What am I doing wrong? This file extends layout.html, but yeah, I forgot to tell Flask what to plug into that layout. So I just need to say block body. And then in here, I can just say to do or whatever I want to eventually get around to, then end the block. Let me end this tag here. OK, so now it looks kind of ugly, more cryptic. But this is, again, the essence of doing templating. Let me now Restart Flask up here. Let me go back to the page. Let me reload, crossing my fingers this time. And there we go, to do. So it's not the application I want, but at least I know I have some of the plumbing there by default. All right, so if I want the user to be able to register for one of these sports, let's enhance now index.html to actually have a form that's maybe got like a drop-down menu for all of the sports for which you can register. So let me go into this template here. And instead of to do, let's go ahead and give myself how about an h1 tag that just says register, so the user knows what it is they're looking at? How about a form tag that's going to use post, just because it's not really necessary to put this kind of information in the URL. The action for that, how about we plan to create a register route so that we're sending information from / to a register route. So we'll have to come back to that. In here, let me go ahead and create, how about an input with autocomplete equals off, autofocus on. How about a name equals name? Because I'm going to ask the student for their name using placeholder text of quote unquote name. And the type of this box will be text. So this is pretty much identical to before. But if you've not seen this yet, let's create a select menu, a so-called drop-down menu in HTML. And maybe the first option I want to be in there is going to be, how about the current 3 sports for the fall, which are basketball. And another option's going to be soccer. And a third option's going to be ultimate frisbee for first-year intramurals right now. So I've got those 3 options. I've got my form. I haven't implemented my route yet, but this feels like a good time to go back now and check if my form has reloaded. So let me go ahead and stop and start Flask. You'll see there's ways to automate the process of restarting the server that we'll do for you for problem set 9, so you don't have to keep stopping Flask. Let me reload my index route, and OK, it's not that pretty. It's not, though maybe nor was this, but it now has at least some functionality where I can type in my name and then type in the sport. Now, I might be biasing people toward basketball, like UX-wise, user experience-wise. It's kind of obnoxious to like pre-check basketball, but not the others. So there's some little tweaks we can make there. Let me go back into index.html. Let me create like an empty option up here that technically this option is not going to have the name of any sport, but it's just going to have a word I want the human to see. So I'm actually going to disable this option and make it selected by default, but I'm going to say sport up here. And there's different ways to do this. This is just one way of creating essentially a, option. Yep, that looks right. Creating a placeholder, sport, so that the user sees something in the drop-down. Let me go ahead and restart Flask, reload the page, and now it's just going to be marginally better. Now you see sport, that's checked by default, but you have to check one of these other ones ultimately. All right, so that's pretty good. So let me now type in David. I'll register for ultimate frisbee. OK, I definitely forgot something. Submit button. So let's add that. All right, so input type equals submit. All right, let's put that in. Restart Flask, reload. OK, getting better. Submit could be a little prettier. Recall that we can change some of these these HTML attributes. The value of this button should be register, maybe, just to make things a little prettier. Let me now reload the page and register. All right, so now we really have the beginnings of the user interface that I created some years ago to let people actually register for the sport. So let's go now and create maybe the other route that we might need. Let me go into app.py. And in here, if we want to allow the user to register, let's do a little bit of error checking, which I promised we'd come back to. Like, what could the user do wrong? Because assume that they will. 1, they might not type their name. 2, they might not choose a sport. So they might just submit an empty form. So that's 2 things we could check for just so that we're not storing like bogus entries in our database ultimately. So let's create another route called greet/greet. And then in this route, let's create a function called greet, but can be called anything we want. And then let's go ahead and in the greet function, let's go ahead and validate the submission. So a little comment to myself here. How about if there is not a request.form get name value? So that is if that function returns nothing, like quote unquote, or the special word none in Python, or request.form get quote unquote sport, not in quote unquote, what were they? Basketball. The other one was soccer. And the last was ultimate frisbee. Getting a little long, but notice what the question I'm asking. if the user did not give us a name, that is, if this function returns the equivalent of false, which is quote unquote, or literally none, if there's no such parameter, or if the sport the user provided is not some value in basketball, soccer, or ultimate frisbee, which I've defined as a Python list, then let's go ahead and just yell at the user in some way. Let's return render template of failure.html. And that's just going to be some error message inside of that file. Otherwise, if they get this far, let's go ahead and confirm registration by just returning render template, quote unquote, success.html. All right, so a couple quick things to do. Let me first go in my templates directory, let's create this failure.html file. And this is just meant to be a message to the user that they fail to provide the information correctly. So let me go ahead and in failure.html, not repeat my past mistake. So let me extend layout.html. And in the block body, you are not registered. I'll just yell at them like that so that they know something went wrong. And then let me create one other file called success.html that similarly is mostly just Jinja syntax. And I'm just going to say for now, even though they're not technically registered in any database, you are registered. That's what we mean by success. All right. So let me go ahead and back in my frosh ims directory, run flask run. Let me go back to the form and reload. Should look the same. All right. So now let me not cooperate and just immediately click register impatiently. OK. What did I do wrong? Register. Oh, I'm confusing our two examples. All right, I spotted the error. What did I do wrong? Unintentional. There's where I am. What did I actually invent over here? Where did I screw up? Anyone? Thank you. So register, not greet. I had last example on my mind. So the route should be register. Ironically, the function could be greet, because that actually doesn't matter. But to keep ourselves sane, let's use the one and the same words there. Let me go ahead now and start Flask as intended. Let me reload the form just to make sure all is working. Now let me not cooperate and be a bad user. Clicking register. Oh, my God. OK. Other unintended mistake. But this one we've seen before. Notice that by default, routes only support get. So if I want to specifically support post, I have to pass in, via a methods parameter, a list of allowed route methods that could be get comma post. But if I don't have no need for get in this context, I can just do post. All right, now let's do this one last time. Reload the form to make sure everything's OK. Click register and you are not registered. So it's catching that. All right, let me go ahead and at least give them my name, register. You are not registered. All right, fine. I'm going to go ahead and be David with Ultimate Frisbee, register. Huh. OK. What did I mean to do here? All right, so let's figure this out. How to debug something like this, which is my third and final unintended unforced error. How can we go about troubleshooting this? Turn this into the teachable moment. All right, well, first, some safety checks. Like, what did I actually submit? Let me go ahead and view page source, a good rule of thumb. Look at the HTML that you actually sent to the user. So here, I have an input with a name. So that's what I intended. That looks OK. Ah, I see it already. Even though you, if you've never used the select menu, might not know. What apparently is missing from here that I did have for my text input? Just intuitively. Like logically, what's going through my head, embarrassingly, is like, all right, if my form thinks that it's missing a name or a sport, how did I create a situation in which name is blank or sport is blank? Well, name I don't think is going to be blank because I explicitly gave this text field a name, and that did work last time. I've now given a second input in the form of the select menu, but what seems to be missing here that I'm assuming exists here? It's just a dumb mistake I made. What might be missing here? If request.form gives you all of the inputs that the user might have typed in, let me go into my actual code here in my form and Name equals sport. I just didn't give a name to that input. So it exists. And the browser doesn't care. It's still going to display the form to you. It just hasn't given it a unique name to actually transmit to the server. So now, if I'm not going to put my foot in my mouth, I think that's what I did wrong. And again, my process for figuring that out was looking at my code, thinking through logically, is this right? Is this right? No, I was missing the name there. So let's run Flask. Let's reload the form just to make sure it's all defaults again. Type in my name and type in Ultimate Frisbee, crossing my fingers extra hard this time. And there, you are registered. So I can't emphasize, I did not intend to screw up in that way, but that's exactly the right kind of thought process to diagnose issues like this. Go back to the basics, go back to what HTTP and what HTML forms are all about, and just rule things in and out. There's only a finite number of ways I could have screwed that up. Yeah? Can you say it a little louder? Why did name equals sport address the problem? Well, let's first go back to the HTML. Previously, it was just the reality that I had this user input drop-down menu, but I never gave it a name. But names, or more generally key value pairs, is how information is sent from a form to the server. So if there's no name, there's no key to send, even if the human types a value. Like it would be like nothing equals Ultimate Frisbee, and that just doesn't work. The browser's just not going to send it. However, in app.py, I was naively assuming that in my requests form, there would be a name called quote unquote sport. It could have been anything, but I was assuming it was sport, but I never told the form that. And if I really wanted to dig in, we could do a little something more. Let me go back to the way it was a moment ago. Let me get rid of the name of the sport drop-down menu. Let me rerun Flask down here and reload the form itself after it finishes being served. And now let me do this. View, Developer Tools, and then let me watch the Network tab, which recall we played around with a little bit last week. And we also played around with curl, which let us see the HTTP requests. Here's what I would have done if I still wasn't seeing the error and was really embarrassed on stage. I would have typed in my name as before. I would have chosen Ultimate Frisbee. I would have clicked register. And now I would have looked at the HTTP request. And I would click on register here. And just like we did last week, I would go down to the request down here. And there's a whole lot of stuff that we can typically ignore. But here, let me zoom in, way at the bottom, what Chrome's developer tools are doing for me is it's showing me all of the form data that was submitted. So this really would have been my telltale clue. I'm just not sending the sport, even if the human typed it in. And logically, because I've done this before, that must mean I didn't give the thing a name. But another good tool, like good programmers, web developers are using these kinds of tools all the time. They're not writing bug-free code. That's not the point to get to. The point to get to is being a good diagnostician, I would say, in these cases. OK, other questions on this? Yeah?
What if you want to edit one HTML using CSS, but you have a fixed template?
Sorry, a little louder?
If you want to edit with CSS or anything in HTML, but you have a fixed template, how do you do that?
So how would you edit CSS if you have these templates? That process we'll actually see before long is almost going to be the exact same. Just to give you a teaser for this, and you'll do this in the problem set, but we'll give you some distribution code to automate this process. You can absolutely still do something like this. Link href equals quote unquote styles.css rel equals style sheet. That's one of the techniques we showed last week. The only difference today using Flask is that all of your static files by convention should go in your static folder. So the change you would make in your layout would be to say that styles.css is in your static folder. And then if I go into my frosh.ims directory, I can create a static folder. I can cd into it. Nothing's there by default. But if I now code a file called styles.css, I could now do something like this, body. And in here, I could say background color, say FF0000 to make it red. Let me go ahead now and restart Flask in the frosh.ims directory. Cross my fingers because I'm doing this on the fly. Go back to my form and reload. Voila, now we've tied together last week's stuff as well. If I answered the right question?
I was maybe asking how you change one page and not the other.
if you want to change one page and not the other in terms of CSS, that depends. In that case, you might want to have different CSS files for each page. If they're that different, you could use different classes in one template than you did in the other. There's different ways to do that. You could even have a placeholder in your layout that allows you to plug in the URL of a specific style sheet in your individual files, but that starts to get more complicated quickly. So in short, you can absolutely do it, but typically I would say most websites try not to use different style sheets per page. They reuse the styles as much as they can. Okay. All right, let me go ahead and revert this real quick, and let's start to add a little bit more functionality here. I'm going to go ahead and just remove the static folder just so as to not complicate things just yet. And let's go ahead and just play around with a different user interface mechanism. In my form here, the drop-down menu is perfectly fine, nothing wrong with it. But suppose that I wanted to change it to like checkboxes instead. Maybe I want students to be able to register for multiple sports instead. Well, it might make sense to clean this up in a couple of ways. And let's do this. Before we even get into the checkboxes, there's one subtle bad design here. Notice that I've hard-coded basketball, soccer, and ultimate frisbee here. And if you recall, in app.py, I also enumerated all three of those here. And anytime you see like copy paste or the equivalent thereof, feels like we could do better. So what if I instead do this? What if I instead give myself like a global variable of sports? I'll capitalize the word just to connote that it's meant to be constant, even though Python does not have constants per se. The first sport will be basketball. The second will be soccer. The third will be ultimate frisbee. Now I have one convenient place to store all of my sports if it changes next semester or next year or whatnot. But notice what I could do too. I could now do something like this. Let me pass into my index template a variable called sports that's equal to that global variable sports. Let me go into my index now, and this is really now going to hint at the power of templating and Jinja in this case here. Let me go ahead and get rid of all three of these hard-coded options, and let me show you some slightly different syntax. For sport, in sports. Then end for. We've not seen this end for syntax, just like end block syntax, but it's as simple as that. So you have a start and an end to your block without indentation mattering. Watch what I can do here. Option, curly brace, sport, close curly brace. Let me save that. Let me go back into my terminal window, do Flask run. And if I didn't mess up here, let me go back to this. The red's going to go away because I deleted my CSS. And now I still have a sport dropdown, and all of those sports are still there. I can make one more improvement now. I don't need to mention these same sports manually in app.py. I can now just say if the user's inputted sport is not in my global variable sports, and ask the same question. And this is really handy because if there's another sport, for instance, that gets added, like, say, football, all I have to do is change my global variable. And if I reload the form now and look in the dropdown, boom, now I have support for a fourth sport. And I can keep adding and adding there. So here's where templating starts to get really powerful in that now in this template, I'm using Jinja's for loop syntax, which is almost identical to Python here, except you need the curly brace and the %, and you need the weird ending, end for. But it's the same idea as in Python. Iterating over something with a for loop lets you generate more and more HTML. And this is like every website out there. For instance, Gmail. When you visit your inbox and you see all of this big table of emails, you know, Google has not hard-coded your emails manually. They have grabbed them from a database. They have some kind of for loop like this and are just outputting table row after table row or div after div dynamically. All right, so now let's go ahead and change this maybe to, how about little check boxes or radio buttons. So let me go ahead and do this. Instead of a select menu, I'm going to go ahead and do something like this. For each of these sports, let me go ahead and output not an option, but let me go ahead and output an input tag, the name for which is quote unquote sport, the type of which is checkbox, the value of which is going to be the current sport, quote unquote, and then afterward I need to redundantly, seemingly output the sport so you see a word next to the checkbox. And we'll look at the result of this in just a moment. So it's actually a little simpler than a select menu, a drop-down menu, because now watch what happens if I reload my form, different user interface. And it's not as pretty, but it's going to allow users to sign up for multiple sports at once now, it would seem. Now I can click on basketball and football and soccer or some other combination thereof. If I view the page's source, this is, again, the power of templating. I didn't have to type out 4 inputs. I got them now automatically. And these things all have the same name, but that's OK. It turns out with Flask, if it sees multiple values for the same name, it's going to hand them back to you as a list if you use the right function. All right, but suppose we don't want users registering for multiple sports. Maybe capacity is an issue. Let me go ahead and change this checkbox to radio button, which a radio button is mutually exclusive, so you can only sign up for one. So now, once I reload the page, there we go. It now looks like this. And because I've given each of these inputs the same name, quote unquote sport, that's what makes them mutually exclusive. The browser knows all 4 of these things are types of sports. Therefore, I'm only going to let you select one of these things. And that's simply because they all have the same name. Again, if I view page source, notice all of them, name equals sport, name equals sport, name equals sport. But what differs is the value that each one is going to have. All right, any questions then on this approach? All right, well, let me go ahead and open a version of this that I made in advance that's going to now start saving the information. So thus far, we're not quite at the point of where this website was, which actually allowed the proctors to see, like in a database, everyone who had registered for sports. Now we're literally telling students, you are registered or you are not registered, but we're literally doing nothing with this information. So how might we go about implementing this? Well, let me go ahead and close these tabs. And let me go into what I called version 3 of this in the code for today. And let me go into my source 9 directory, frosh.ims3. And let me go ahead and open up app.py. So this is a pre-made version. I've gotten rid of football in this case. But I've added one thing at the very top. What in English does this represent on line 7? What would you describe what that thing is? What are we looking at? What do you think? Yeah, it's an empty dictionary, right? Registrants is apparently a variable on the left. It's being assigned an empty dictionary on the right. And a dictionary, again, is just key value pairs. Here, again, is where dictionaries are just such a useful data structure. Why? Because this is going to allow me to remember that David registered for Ultimate Frisbee. Carter registered for soccer. Emma registered for something else. You can associate keys with values, names with sports, assuming a model where you can only register for one sport for now. And so let's see what the logic is that handles this. Here in my register route, in the code I've pre-made, notice that I'm validating the user's name. Slightly differently from before, but same idea. I'm using request.form.get to get the human's name. If not name. So if the human did not type a name, I'm going to output error.html. But notice I've started to make the user interface more expressive. I'm telling the user, apparently with a message, what they did wrong. Well, how? I'm apparently passing to my error template, instead of just failure.html, a specific message. So let's go down this rabbit hole. Let me actually go into template/error.html. And sure enough, here's a new file I created here that adorably is apparently going to have a grumpy cat as part of the error message. But notice what I've done. In my block body, I've got an h1 tag that just says error, big and bold. I then have a paragraph tag that plugs in whatever the error message is that the controller, app.py, is passing in. And then just for fun, I have a picture of a grumpy cat connoting that there was, in fact, an error. Let's keep looking. How do I validate sport? I do similarly request.form.get of sport, and I store it in a variable called sport. If there's no such sport, that is, the human did not check any of the boxes, then I'm going to render error.html2, but I'm going to give a different message, missing sport. Else, if the sport they did type in is not in my sports global variable, I'm going to render error.html, but complain differently. You gave me an invalid sport somehow. They, like a hacker, went into the HTML of the page, changed it to add their own sport, like volleyball. Even though it's not offered, they submitted volleyball. But that's OK. I'm rejecting it, even though they might have maliciously tried to send it to me by changing the DOM locally. And then really the magic is just this. I remember that this person is registered by indexing into the registrants dictionary, using the name the human typed in as the key, and assigning it a value of sport. Why is this useful? Well, I added one final route here. I have a /registrants route, with a registrants function that renders a template called registrants.html, but it takes as input that global variable, just like before. So let's go down this rabbit hole. Let me go into templates registrants.html. Here's this template. All right, it looks a little crazy big, but it extends the layout. Here comes the body. I've got an h1 tag that says registrants, big and bold. Then I've got a table that we saw last week. This has a table head that just says name, sport for 2 columns. Then it has a table body wherein, using this for loop in Jinja syntax, I'm saying for each name in the registrants variable, output a table row start tag and end tag, inside of which 2 table datas, 2 cells, table data for name, table data for registrants bracket name. So it's very similar to Python syntax. It essentially is Python syntax, albeit with these curly braces and the %sign. So the net effect here is what? Let me open up my terminal window, run Flask run. Let me now go into the form that I pre-made here. So gone is football. Let me go ahead and type in David. Let me choose, no sport, register, error, missing sport. And there is the grumpy cat. So missing sport, though, specifically was outputted. All right, fine. Let me go ahead and say no name, but I'll choose basketball, register. Missing name. All right, and let me maliciously now do this, right? Now I'm hacking. Let me go into this. I'll type my name, sure. But let me go into the body tag down here. Let me maliciously go down in Ultimate Frisbee. Heck with that. Let's volleyball. Change that and change this to volleyball. Enter. So now I can register for any sport I want to create. Let me click register, but invalid sports. So again, that speaks to the power and the need for checking things on the back end and not trusting users. It is that easy to hack websites otherwise if you're not validating data server side. All right, finally, let's just do this for real. David is going to register for Ultimate Frisbee, clicking register. And now the output's not very pretty, but notice I'm at the registrants route. And if I zoom out, I have an HTML table, 2 columns, name and sport, David and Ultimate Frisbee. Let me go back to the form. Let me pretend like Carter walked up to my laptop and registered for basketball, register. Now we see 2 rows in this table. David, Ultimate Frisbee, Carter, basketball. And if we do this one more time, maybe Emma comes along and registers for soccer, register. All of this information is being stored in this dictionary now. All right, so that's great. Now we have a database, albeit in the form of like a Python dictionary. But why is this maybe not the best implementation? Why is it not great? Yeah. Yeah, so we're only storing this dictionary in the computer's memory. And that's great until I hit Control-C and kill Flask, stopping the web server, or the server reboots, or maybe I close my laptop or whatever. If the server stops running, memory is going to be lost, right? RAM is volatile. It's thrown away when you lose power or stop the program. So maybe this isn't the best approach. Maybe it would be better to use a CSV file. And in fact, some 20 years ago, that's literally what I did. I stored everything in a CSV file. But let's skip that step because we already saw last week, or a couple of weeks ago now, how we can use SQLite. Let's see if we can't marry in some SQL here to store an actual database for the program. Let me go back here and let me open up, say, version 4 of this, which is almost the same, but it adds a bit more functionality. Let me close these tabs, and let me open up app.py now in version 4. So notice it's almost the same, but at the top, I'm creating a database connection to a database called froshims.db. So that's a database I created in advance. So let's go down that rabbit hole. What does it look like? Let me make my terminal window bigger. Let me run SQLite 3 of froshims.db. OK, I'm in. Let's do .schema. And let's just infer what I designed this to be. I have a table called registrants, which has 1, 2, 3 columns. An ID column that's an integer, a name column that's text but cannot be null, and a sport column that's also text cannot be null. And the primary key is just ID, so that I have a unique ID for every registration. Let's see if there's anyone in there yet. Select star from registrants. OK, there's no one in there. No one is yet registered for sports. So let's go back to the code and continue on. In my code now, I've got the same global variable for validation and generation of my HTML. Looks like my index route is the same. It's dynamically generating the menu of sports. Interestingly, we'll come back to this. There's a deregister route that's going to allow someone to deregister themselves if they want to exit the sport or undo their registration. But this is the juicy part. Here's my new and improved register route. Still works on post, so some mild privacy there. I'm validating the submission as follows. I'm getting the user's inputted name, the user's inputted sport, and if it is not a name, or the sport is not in sports, I'm going to render failure.html. So I kept it simple. There's no cat in this version. It just says failure. Otherwise, recall how we commingled SQL and Python before. We're using CS50's SQL library, but that just makes it a little easier to execute SQL queries. And we're executing this. Insert into registrants, name, comma, sport. What two values? The name and the sport that came from that HTML form. And then lastly, and this is a new function that we're calling out explicitly now, Flask also gives you access to a redirect function, which is how safetyschool.org, harvardsucks.org, and those other sites we played around with last week were all implemented, redirecting the user from one place to another. This Flask function redirect comes from my just having imported it at the very top of this file. It handles the HTTP 301 or 302 or 307 code, whatever the appropriate one is. It does that for me. All right, so that's it for registering via this route. Let's look at what the /registrants route is. Here we have a new route for /registrants, and instead of just iterating over a dictionary like before, we're getting back, let's see, db.execute of select star from registrants. So that's like literally the programmatic version of what I just did manually. That gives me back a list of dictionaries, each of which represents one row in the table. Then I'm going to render registrants.html, passing in literally that list of dictionaries, just like using CS50's library in the past. So let's go and look at that form. If I go into templates and open up registrants.html, oh, OK, it's just a table like before. And actually, let me change this syntactically for consistency. We have a Jinja for loop that iterates over each registrant, and for each of them outputs a table row. But this is interesting. Instead of just having two columns with the person's name and sport, notice that I'm also outputting a full-fledged form. All right, this is starting to get kind of juicy. So let's actually go back to my terminal window, run Flask, and actually see what this example looks like now. Let me reload the page. All right, and the home page looks exactly the same, but let me now register for something. David for Ultimate Frisbee, register. Oh, damn it. Let's try this again. David registering for Ultimate Frisbee, register. OK, so good thing I have deregister. So this is what it should now look like. I have a page at the route called /registrants that has a table with two columns, name and sport, David Ultimate Frisbee. But oh, wait, a third column. Why? Because if I view the page source, notice that it's not the prettiest UI. For every row in this table, I'm also going to be outputting a form just to deregister that user. But before we see how that works, let me go ahead and register Carter, for instance. So Carter will give you basketball again, register. The table grows. Now let me go back and let's register Emma for soccer, and the table should grow. Before we look at that HTML, let's go back to my terminal window. Let's go into SQLite, frosh.ims. Let me go into frosh.ims, and let me open up with SQLite 3, frosh.ims.db, and now do select star from registrants. And whereas previously when I executed this, there were 0 people, now there's indeed 3. So now we see exactly what's going on underneath the hood. So let's look at this form now, at this page now. If I want to unregister, deregister one of these people specifically, how do we do this? Clicking one of those buttons will indeed delete the row from the database. But how do we go about linking a web page with Python code with a database? Like, this is the last piece of the puzzle. Up until now, everything's been with forms and also with URLs. But what if the user's not typing anything in? They're just clicking a button. Well, watch this. Let me go ahead and sniff the traffic, which you could be in the habit of doing now anytime you're curious how a website works. Let me go to the Network tab. And Carter, shall we deregister you from basketball? Let's deregister Carter. And let's see what just happened. If I look at the deregister request, notice that it's a post. the status code that eventually came back as 302, but let's look at the request itself. All the headers there we'll ignore. The only thing that button submits, kind of cleverly, is an ID parameter, a key, equaling 2. What does 2 presumably represent or map to? Like, where did this 2 come from? It doesn't say Carter. It doesn't say basketball. What is it? The second person that registered. So those primary keys that we started talking about a couple of weeks ago, why it's useful to be able to uniquely identify a row in a table, here is just one of the reasons why. If it suffices for me just to send the ID number of the person I want to delete from the database, because I can then have code like this. If I go into app.py and I look at my deregister route now, the last of them, notice that I got this. I first go into the form, and I get the ID that was submitted, hopefully. If there was, in fact, an ID, and the form wasn't somehow empty, I execute this line of code. Delete from registrants where ID equals question mark, and then I plug in that number, deleting Carter and only Carter. And I'm not using his name because what if we have 2 people named Carter, 2 people named Emma or David? You don't want to delete both of them. That's why these unique IDs are so important. And here's another reason why. You don't want to store some things in URLs. Suppose we went to this URL, deregister question mark ID equals 3. Suppose I maliciously emailed this URL to Emma. It doesn't matter so much what the beginning is, but suppose I emailed her this URL /deregister question mark ID equals 3, and I said, hey, Emma, click this. And it uses get instead of post. What did I just trick her into doing? What's going to happen if Emma clicks this? Yeah. You would trick her into deregistering herself. Why? Because if she's logged into this FroshIM's website and the URL contains her ID just because I'm being malicious, and she clicked on it, and the website is using get, unfortunately, get URLs are, again, stateful. They have state information in the URLs. And in this case, it's enough to delete the user. And boom, she would have accidentally deregistered herself. And this is pretty innocuous. Suppose that this was her bank account trying to make a withdrawal or a deposit. Suppose that this were some other website, a Facebook URL, trying to trick her into posting something automatically. Here, too, is another consideration when you should use post versus get, because get requests can be plugged into emails, sent via Slack messages, text messages, or the like. And unless there's a prompt saying, are you sure you want to deregister yourself, you might blindly trick the user into being vulnerable to what's called a cross-site request forgery, a fancy way of saying you trick them into clicking a link that they shouldn't have because the website was using get alone. All right, any question then on these building blocks? Yeah. When 3 columns, you mean? The 3 forward slashes. I'm not sure I follow. Sorry, it's in where? Which file? Sorry, the other direction? OK. Keep scrolling more. Oh, this thing. OK, sorry. This is just a URI that's typical syntax that's referring to the SQLite protocol, so to speak, which means use SQLite to talk to a file locally. : / is just like you and I see in URLs. The third slash essentially means current folder. That's all. So it's a weird curiosity, but it's typical whenever you're referring to a local file and not one that's elsewhere on the internet. That's a bit of an oversimplification, but that's indeed a convention. Sorry for not clicking earlier. All right, let's do one other iteration of FroshIMs here, just to show what I was actually doing too back in the day was not only storing these things in CSV files, as I recall, I was also automatically generating an email to the proctor in charge of the intramural sports program so that they would have sort of a running history of people registering and they could easily reply to to them as well. Let me go into FrosIAM's version 5, which I pre-created here. And let me go ahead and open up, say, app.py this time. And this is some code that I wrote in advance. And it looks a little scary at first glance, but I've done the following. I have now added the Flask mail library to the picture by adding Flask mail to requirements.txt and running a command to automatically install email support for Flask as well. And this is a little bit cryptic, but it's honestly mostly copy-paste from the documentation. What I'm doing here is I'm configuring my Flask application with a few configuration variables, if you will. This is the syntax for that. App.config is a special dictionary that comes with Flask that is automatically created when you create the app up here on line 9. And I just had to fill in a whole bunch of configuration values for the default sender address that I want to send email as, the default password I want to use to send email, the port number, the TCP port that we talked about last week, the mail server. I'm going to use Gmail's smtp.gmail.com server. Use TLS. This means use encryption. So I set that to true. Mail username. This is going to grab it from my environment. So for security purposes, I didn't want to hard code my own Gmail username and password into the code. So I'm actually storing those in what are called environment variables. You'll see more of these in problem set 9. And it's a very common convention on a server in the real world to store sensitive information in the computer's memory so that it can be accessed when your website is running, but not in your source code. It's way too easy if you put credentials, sensitive stuff in your source code, to post it to GitHub or to screenshot it accidentally or for information to leak out. So for today's purposes, know that the os.environ dictionary refers to what are called environment variables. And this is like an out of band, a special way of defining key value pairs in the computer's memory by running a certain command, but that never show up in your actual code. Otherwise, there would be so many usernames and passwords accidentally visible on the internet. So I've installed this in advance. Let me see if I can do this correctly. Let me go over to another tab in just a moment. And here I have on my second screen here, John Harvard's inbox. It's currently empty. And I'm going to go ahead and register for some sport as John Harvard here, hopefully. So let me go ahead and run Flask run on this version 5. Let me go ahead and reload the main screen, not that one. Let me reload the main screen here. This time, clearly, I'm asking for name and email. So name will be John Harvard, jharvard at cs50.harvard.edu. He'll register for, how about soccer? Register. And if I did this correctly, not only is John Harvard on his screen seeing you are registered, but when he checks his email on this other screen, crossing his fingers that this actually works as a demonstration, and I promise it did right before class. Oh, horrifying. I don't think there's a mistake this time. Let me try something over here real quick, but I don't think this is broken. It wouldn't have said success if it were. I just tried submitting again, so I just did another you are registered. Oh, I'm really sad right now. What's that? I could check spam, but then it's not sure we want to show spam here on the internet that every one of us gets. Oh, maybe. Oh, whew. Thank you. OK, wow, that was a risky click, I worried. All right, so you are registered is the email that I sent out. And it doesn't have any actual information in it. But back in the day, it would have, because I included like the student's name and their dorm and all the other fields of information that we asked for. So let's just take a quick look at how that code might work. I did have to configure Gmail in a certain way to allow what they call less secure apps using SMTP, which is the protocol used for outbound email. But besides setting these things, let's look at the register route down here. It's actually pretty straightforward. In my register route, I validated the submission just like before. Nothing new there. I then confirmed the registration down here. Nothing new there. All I did was use 2 new lines of code. And it's this easy to automate the sending of emails. I apparently have done it too many times, which is why it ended up in spam. I created a variable called message. I used a message function that I must have imported higher up, so we'll go back to that. Here's apparently the subject line as the first argument. And the second argument is the named parameter recipients, which takes a list of emails that should get the confirmation email. So in brackets, I just put the one user's email, and then mail.send that message. So let's scroll back up to see what message and what mail actually is. Mail, I think we saw. Yep. Mail is this, which I have as a variable because I followed the documentation for this library. You simply configure your current app with mail support, capital M here. And if you look up here now on line 7, here's the new library. From Flask Mail, I imported capital Mail, capital Message, so that I had the ability to create a message and send a mail. So such a simple thing, whether you want to confirm things for users, you want to do password resets, it can be this easy to actually generate emails, provided you have the requisite access and software installed. And just to make clear that I did add something here, let me open up my requirements.txt file. And indeed, I have both Flask and Flask-mail ready to go. But I ran the command in advance to actually do that. All right, any questions then on these examples here? No? All right, so what other pieces might actually remain for us? Let me flip over here. It turns out that a key component of most any web application nowadays that we haven't touched on yet, but it'll be one of our final flourishes today, is the notion of a session. And a session is actually a feature that derives from all of the basics we talked about today and last week. And a session is the technical term for like what you and I know as a shopping cart. When you go to Amazon.com and you start adding things to your shopping cart, they follow you from page to page to page. Heck, if you close your browser, come back to the next day, they're typically still in your shopping cart, which is great for Amazon because they want your business. They don't want you to have to like start from scratch the next day. Similarly, when you log into any website these days, even if it's not an e-commerce thing, but it has usernames and passwords, you and I are not in the habit of logging into every darn page we visit on a website. Typically, you log in once, and then for the next hour, day, week, year, you stay logged into that website. So somehow, the website is remembering that you have logged in. And that is being implemented by way of this thing called a session, and perhaps a more familiar term that you might know as and worry about called cookies. Let's go ahead and take one more 5-minute break here. And when we come back, we'll look at cookies, sessions, and these final features. All right, so the promise now is that we're going to implement this notion of a session, which is going to allow us to like log users in and keep them logged in, and even implement things like a shopping cart. And the overarching goal here is to build an application that is quote unquote stateful. Again, state refers to information, and something that's stateful remembers information. And in this context, the curiosity is that HTTP is technically a stateless protocol. Like once you visit a URL, http://something, hit enter, web page is downloaded to your browser, like that's it. Like you can unplug from the internet, you can turn off your Wi-Fi, but you still have the web page locally. And yet we somehow want to make sure that the next time you click on a link on that website, it doesn't forget who you are. Or the next thing you add to your shopping cart, it doesn't forget what was already there. So we somehow want to make HTTP stateful. And we can actually do this using the building blocks we've seen thus far. So concretely, here's like a form you might see occasionally, but pretty rarely when you log into Gmail, right? And I say kind of rarely because most of you don't log into Gmail frequently. You just stay logged in pretty much endlessly in your browser. And that's because Google has made the conscious choice to give you a very long session time, maybe a day, a week, a month, a year, because they don't really want to add friction to using their tool and making you log in every darn day. By contrast, there's other applications on campus, including some of CS50's own, that makes you log in every time, because we want to make sure that it's indeed you accessing the site and not a roommate or friend or someone maliciously. So once you do fill out this form, how does Google subsequently know that you are you? And when you reload the page even or open a second tab for your same Gmail account, how do they know that you're still David or Carter or Emma or someone else? Well, let's look underneath the hood of what's going on. When you log into Gmail, essentially, you initially see a form like this using a GET request. And the website responds, like we saw last week, with some kind of HTTP response, hopefully 200 OK with the form. Meanwhile, the website might also respond with an HTTP header that last week we didn't care about, this week we now do. whenever you visit a website, it is very commonly the case that the website is putting a cookie on your computer. And you may generally know that cookies can be bad and they kind of track you in some way. And that's both a blessing and a curse. Without cookies, you could not implement things like shopping carts and logins as we know them today. Unfortunately, they can also be used for ill purposes like tracking you on every website and serving you ads more effectively and so forth. So with good comes some bad. But the basic primitive for us, the computer scientist, boils down to just HTTP headers. A cookie is typically a big number, a big seemingly random value that a server tells your browser to store in memory, or even longer term, store on disk. So you can think of it like a file that a server is planting on your computer. And the promise that HTTP makes is that if a server sets a cookie on your computer, you will represent that same cookie or that same value on every subsequent request. So when you visit the website like Gmail, they plop a cookie on your computer like this with some session equals value, some long random value, 123 ABC or something like that. And when you then visit another page on gmail.com or any other website, you send the opposite header, not set cookie, but just cookie, and you send the exact same value. It's similar to going to a club or an amusement park where you pay once, you go through the gates once, you get checked by security once, and then they very often take a stamp and say, OK, now you can come and go. And then for you, efficiency-wise, if you come back later in the day or later in the evening, you can just present your hand. You've been stamped. Presumably, you've already paid. You've already been searched or whatnot. And so it's this sort of fast-track ticket back into the club, back into the park. That's essentially what a cookie is doing for you, whereby it's a way of reminding the website, we've already done this. You already asked me for my username and password. This is my pass to now come and go. Now, unlike this hand stamp, which can kind of be easily copied or transferred or duplicated or kept on over multiple days, these cookies are really big, seemingly random values, letters and numbers. So statistically, there's no way someone else is just going to guess your cookie value and pretend to be you. It's just very low probability statistically. But this is all it boils down to, is this agreement between browser and server to send these values back and forth in this way. So when we actually translate this now to code, let's do something like a simple login app. Let me go into a folder I made in advance today called login, and let me code up app.py. And let's take a look in here. So what's going on? A couple of new things up top. If I want to have the ability to stamp my user's hands virtually and implement sessions, I'm going to have to import from Flask support for sessions. So this is another feature you get for free by using a framework and not having to implement all this yourself. And from the Flask session library, I'm going to import session capital S. Why? I'm going to configure the session as follows. Long story short, there's different ways to implement sessions. The server can store these cookies in a database, in a file, in memory, in RAM, in other places too. We are telling it to store these cookies on the server's hard drive. So in fact, whenever you use sessions, as you will for problem set 9, you'll actually see a folder suddenly appear called flask_session, inside of which are the cookies, essentially, for any users or friends or yourself who've been visiting your particular application. So I'm setting it to use the file system, and I don't want them to be permanent, because I want, when you close your browser, the session to go away. They could be made to be permanent and last much longer. Then I tell my app to support sessions. And that's it for now. Let's see what this application actually does before we dissect the code. Let me go over to my terminal window, run flask run, and then let me go ahead and reload my preview URL. Give it a second to kick back in. Let me go ahead and open my URL. Come on. Whoops. Let me go ahead. Too long of a break. There we go. So this website simply has a login form. There's no password, though I could certainly add that and check for that too. It just asks for your name. So I'm going to log in as myself, David, and click login. And now notice, I'm currently at the /login route. But notice this. If I try to go to the default route, just /, which is where most websites live by default, notice that I magically get redirected to login. So somehow my code knows, hey, if you're not logged in, you're going to /login instead. Let me type in my name, David, and click login. And now, notice I am back at /. Chrome is sort of annoyingly hiding it, but this is the same thing as just a single /. And now notice it says you are logged in as David. Log out. What's kind of cool is, notice if I reload the page, it still knows that. If I create a second tab and go to the same URL, it still knows that. I could even I could keep doing this in multiple tabs. It's still going to remember me on both of them as being logged in as David. So how does that work? Especially when I click log out, then I get forgotten altogether. All right, so let's see how this works. And it's some basic building blocks. Under my slash route, notice I have this. If there is no name in the session, redirect the user to /login. So these two lines together are what implement that automatic redirection using HTTP 301 or 302 automatically. It's handled for me with these two lines. Otherwise, show index.html. All right, let's go down that rabbit hole. What's in index.html? Well, if I look in let me look in my templates folder for my login demo and look at templates/index.html. All right, so what's going on here? I extend layout.html. I have a block body. And then I've got some other syntax. So we haven't seen this yet, but it's more Jinja stuff, which again is almost identical to Python. If there's a name in the session variable, then literally say you are logged in as, curly braces, session bracket name. And then notice this. I've got a simple HTML link to log out via /logout. Else, if there is no name in the session, then it apparently says you are not logged in. And it leads me to an HTML link to /login. And then end if. So again, Jinja does not rely on indentation. Recall that HTML and CSS don't really care about indentation. Only the human does. But in code with Jinja, you need these end tags, end block, end for, end if, to make super obvious that you're done with that thought. So session is just this magic variable that we now have access to because we've included these two lines of code and these that handle that whole process of stamping every user's hand with a different unique identifier. If I made my code space public and I let all of you visit the exact same URL, all of you would be logged out by default. You could all type your own names individually, all log in at the same URL using different sessions. And in fact, I would then see, if I go into my terminal window here, in my login directory, notice the Flask session directory I mentioned. And if I cd into that and type ls, notice that I had two tabs open, or actually, I think I started the server twice. I have two files in there. I would ultimately have one file for every one of you. And that's what's beautiful about sessions, is it creates the illusion of per user storage. Inside of my session is my name. Inside of your session, so to speak, is your name. And the same is going to apply to shopping carts ultimately as well. Let's see how login works here. My login route supports both get and post, so I could play around if I want. And notice this. This login route is kind of interesting as follows. If the user got to this route via post, my inference is that they must have submitted a form. Why? Because that's how I'm going to design the HTML form in a second. And if they did submit the form via post, I'm going to store in the session at the name key whatever the human's name is. And then I'm going to redirect them back to /. Otherwise, I'm going to show them the login form. So this is what's kind of cool. If I go to this login form, which lives at literally /login, by default, when you visit a URL like that, you're visiting via get. And so that's why I see the form. However, notice this. The form very cleverly submits to itself. Like the one route /login submits to its same self /login, but it uses post when you submit the form. And this is a nice way of having one route, but for two different types of operations or views. When I'm just there visiting /login via a URL, it shows me the form. But if I submit the form, then this logic, these three lines kick in. And this just avoids my having to have both an index route and a greet route, for instance. I can just have one route that handles both get and post. How about logout? What does this do? Well, it's as simple as this. Change whatever name is in the session to be none, which is Python's version of like null, essentially, and then redirect the user back to /. Because now, in index.html, I will not notice a name there anymore. This will be false. And so I'll tell the user instead, you are not logged in. So like, I want to say as simple as this is, though I realize this is a bunch of steps involved, this is the essence of every website on the internet that has usernames and passwords. And we skipped the password name step for that. More on that in problem set 9. But this is how every website out there remembers that you're logged in. And how this works ultimately is that as soon as you use in Python lines like this and lines like this, Flask takes care of stamping the virtual hand of all of your users. And whenever Flask sees the same cookie coming back from a user, it grabs the appropriate file from that folder, loads it into the session global variable so that your code is now unique to that user and their name. Let's do one other example with sessions here that'll show how we might use these now for shopping carts. Let me go into the store example here. Let me go ahead and run this thing first. If I run store in my same tab and go back over here, we'll see a very ugly e-commerce site that just sells 7 different books here. But each of these books has a button via which I can add it to my cart. All right, well, where are these books coming from? Well, let's kind of poke around. Let me go into my terminal window again. Let me go into this example, which is called store. And let me open up about index.ht. Whoops. Let's open up index. How about books.html is the default one, not index this time. So if I look here, notice that that route that we just saw uses a for loop in Jinja to iterate over a whole bunch of books, apparently. And it outputs in an h2 tag, the title of the book, and then another one of these forms. So that's kind of interesting. Let's go back one step. Let's go ahead and open up app.py, because that must be, what's kicking all of this off. Notice that this file is importing session support. It's configuring sessions down here, but it's also connecting to a store.db file. So it's adding some SQLite. And notice this. In my slash route, I'm selecting star from books, which is going to give me a list of dictionaries, each of which represents a row of books. And I'm going to pass that list of books into my books.html template, which is why this for loop works the way it does. Let's look at this actual database. Let me increase my terminal window and do SQLite of store.db. .schema will show me everything. There's not much there. It's a table called books with 2 columns, ID and title. Let's do select star from books, semicolon. There are the 7 books, each of which has a unique ID. And you might see where this is going. If I go to the UI and I look at each of these buttons for add to cart, just like Amazon might have, notice that each of these buttons is just a form. And what's magical here, just like deregister, even though I didn't highlight it at the time, there's another type of input that allows you to specify a value without the human being able easily to change it. Instead of type equals text or type equals submit, type equals hidden. We'll put the value in the form but not reveal it to the user. So that's how I'm saying that the ID of this book is 1. The ID of this book is 2. The ID of this book is 3, and so forth. And each of these forms then will submit apparently to /cart using post. And that would seem to be what adds things to cart. So let's try this. Let me click on 1 or 2 of these. Let's add the first book, add to cart. Here's my cart. Notice my route changed to /cart. All right, let's go back and let's add the book number 2. There we have that one. And let's skip ahead to the 7th book, Deathly Hallows. And now we have all 3 books here. So what does the cart route do at /cart? Well, let's look. If I go back to my terminal window, look at app.py, and look at /cart. OK, there's a lot going on here, but let's see. So the /cart route supports both get or post, which is a nice way to consolidate things into one URL. All right, this is interesting. If there is not a quote-unquote cart key in session, we haven't technically seen this syntax, but long story short, these lines here do ensure that the cart exists. What do I mean by that? It makes sure that there's a cart key in the session global variable, and it's by default going to be an empty list. Why? That just means you have an empty shopping cart. But if the user visits this route via post, and the user did provide an ID, they didn't muck with the form in any way and like try to hack into the website, they gave me a valid ID, then I'm going to use this syntax. If session bracket cart is a list, recall from a couple of weeks ago that .append just adds something to the list, so I'm going to add the ID to the list and return the user to cart. Otherwise, if the user is at /cart via get implicitly, we just do this. Select star from books where ID is in. And this might be syntax you recall from pset 6. It lets you look for multiple IDs all at once, because if I have a list of IDs in my cart, I can get all of those books at once. So long story short, what has happened here? I am storing in the cart the books that I myself have added to my cart. My browser is sending the same hand stamp again and again, which is how this website knows that it's me adding these books to my cart and not you or not Carter or not Emma. Indeed, if all of us visited the same long URL and I made it public and allowed that, then we would all have our own illusions of our own separate carts. And each of those carts in practice would just be stored in this Flask session directory on the server so that the server can keep track of each of us using, again, these cookie values that are being sent back and forth via these headers. All right, I know that's a lot, but again, it's just the new Python way of just leveraging those HTTP headers from last week in a clever way. Any questions before we look at one final set of examples? Yeah? So I think you're asking about using the get and post in the same function. So this is just a nice aesthetic, if you will. If I had to have separate routes for get and post, I mean, it literally might mean I need twice as many routes in my file. And that just starts to get a little annoying. And these days, too, in terms of user experience, this is, maybe only appeals to the geek in us. But like having clean URLs is actually a thing. Like you don't want to have lots of words in the URL. It's nice if the URLs are nice and succinct and canonical, if you will. So it's nice if I can centralize all of my shopping cart functionality in /cart only, and not in multiple routes, one for get, one for post. It's a little, nitpicky of me, but this is commonly done here. So what this code here means is that this route, this function, henceforth will support both get requests and post requests. But then I kind of need to distinguish between whether it's get or post coming in. Because if it's a get request, I want to show the cart. If it's a post request, I want to update the cart. And the simplest way to do that is just to check this value here. In the request variable that we imported from Flask up above, you can check what is the current type of request. Is it a get? Is it a post? Or is it something else altogether? There are other verbs. If it's a post, that must mean, because I created the web form that uses post, that the user clicked the add to cart button. Otherwise, if it's not post, it's implicitly going to be logically get. Then I just want to show the user the contents of the cart, and I use these lines instead. So it's just one way of avoiding having two routes for two different HTTP verbs. You can combine them so long as you have a check like this. If I really wanted to be pedantic, I could do this. elif request dot method equals get. This would be more symmetric, but it's not really necessary because I know there's only two possibilities. Hope that helps. All right, let's do one final set of examples here that's going to tie the last of these features together to something that you probably see quite often in real-world applications. And that, for better or for worse, is now going to involve tying back in some JavaScript from last week. The goal at hand of these examples is not to necessarily master how you yourself would write the Python code, the SQL code, the JavaScript code, but just to give you a mental model for how these different languages work so that for final projects, especially if you do want to add JavaScript functionality, much more interactive user interface, you at least have like the bare bones of a mental model for how you can tie these languages together, even though our focus generally has been more on Python and SQL than on JavaScript from last week. Let me go ahead and open up an example called shows, version 0 of this, and let me do Flask run. And let me go into my URL here and see what this application looks like by default. This has just a simple query text box with a search box. Let's take a look at the HTML that just got sent to my browser. All right, there's not much going on here at all. So there's a form whose action is /search. It's going to submit via get. It's going to use a queue parameter, just like Google, it seems, and submit it. So this actually looks like the Google form we did last week. So let's see what goes on here. Let me search for something like cat. Enter. OK, so it looks like, all right, so this is actually a somewhat familiar file. What I've gone ahead and done is I've grabbed all of the titles of TV shows from a couple of weeks ago when we first introduced SQL, and I loaded them into this demo so that you can search by keyword for any word you want. I just searched for cat. If we were to do this again, we would see all the title of TV shows that contain DOG. dog as a substring somewhere, and so forth. So this is a traditional way of doing this. Just like in Google, it uses /search, !q equals cat, q equals dog, and so forth. How does that work? Well, let's just take a quick look at app.py here. Let me go into my 0 example here, show 0, and open up app.py and see what's going on. All right, very simple. Here's the form. That's kind of how we started today. And here is the /search route. Well, what's going on here? This gets a little interesting. So I first select a whole bunch of shows by doing this. Select star from shows where title like question mark. And then I'm using some %signs from SQL on both the left and the right. And I'm plugging in whatever the user's input was for q. If I didn't use like and I used equal instead, I could get rid of these %signs. But then it would have to be a show called cat or called dog, as opposed to it being like cat or like dog. This whole line returns to me a list of dictionaries, each of which represents a show in the database. And then I'm passing all of those shows to a template called search.html. So let's just follow that breadcrumb. Let's open up search.html. All right, so this is where templating gets kind of cool. So I just passed back hundreds of results potentially, but the only thing I'm outputting is an unordered list, and using a Jinja for loop, an li tag containing the titles of each of those shows. And just to prove that this is indeed a familiar data set, and I actually simplified it a bit, if I look at shows.db with SQLite, I threw away all the other stuff like ratings and actors and everyone else, and I just have, for instance, select star from shows, limit 10, just so we can see 10 of them. There's 10 of the shows from that database. So that's all that's in the database itself. So it would look like this is a pretty vanilla web application. It uses get, it submits it to the server spits out a response, and that response then looks like this, which is a huge number of li tags, one for each cat or one for each dog match, but everything else comes from a layout.html, all the stuff at the top and at the bottom. All right, so these days, though, we're in the habit of seeing autocomplete. And you start typing something, and you don't have to hit submit. You don't have to click a button. You don't have to go to a new page. Web applications nowadays are much more dynamic. So let's take a look at this version 1 of this thing. Let me go into shows 1 and close my previous tabs and run Flask run in here. And it's almost the same thing, but watch the behavior change a little bit. I'm reloading the form. There's no button now. So gone is the need for a submit button. I want to implement autocomplete now. So let's go ahead and type in C. OK, there's every show that starts with C. A, there's every show that has CA in it, rather. T, there's every show with CAT in it. I can start it again and do dog. But notice how instantaneous it was. And notice my URL never changed. There's no /search route. And it's just immediate. Like with every keystroke, it is searching again and again and again. That's kind of a nice UX, user experience, because it's immediate. This is what users are used to these days. But if I look at the source code here, notice that in the source code, there's just an empty UL by default. But there is some fancy JavaScript code. So let's see what's going on here. This JavaScript code is doing the following. Let me zoom in a little bit more. This JavaScript code is first selecting with query selector, which you used this past week, quote unquote input. All right, so that's just getting the text box. Then it's adding an event listener to that input for the input event. We didn't talk about this last week, but literally when you provide any kind of input, by typing, by pasting, by any other user interface mechanism, it triggers an event called input. So similar to key press or key up. I then have a function. No worries about this async function for now. Then what do I do inside of this? All right, so this is new, and this is the part that let's just focus on the ideas and not the syntax. JavaScript nowadays comes with a function called fetch that allows you to get or post information to a server without reloading the whole page. You can sort of secretly do it inside of the page. What do I want to fetch? /search question mark q equals whatever the value of that input is. When I get back a response, I want to get the text of that response and store it in a variable called shows. And I'm deliberately bouncing around, ignoring special words like await and await here. But for now, just focus on what came back. A response came back from the server. I'm getting the text from it, storing it in a variable called shows. What am I then doing? I'm using query selector to select my UL, which is empty by default. And I'm changing its inner HTML to be equal to the shows that came back from the server. So let's poke around. Here's where, again, developer tools are quite powerful. Let me go ahead and reload this page to get rid of everything. And let me now open up Inspect. Let me go to the Network tab, and let's just sniff the traffic going between my browser and server. I'm going to search for C. Notice that immediately triggered an HTTP request to /search Q equals C. So I didn't even finish my cat thought. But notice what came back. A bunch of response headers, but let's actually click on the raw response. This is literally the response from the server. Just a whole bunch of LI tags. No UL, no HTML, no title, no body, nothing. Just LI tags. And we can actually simulate this. Let me manually go to that same URL, Q equals C, enter. We are just going to get back, /search Q equals C. We are just going to get back this stuff, which if I view source, it's not even a complete web page. The browser is trying to show it to me as a complete web page with bullets, but it's really just partial HTML. But that's perfect, because this is literally what I essentially want my Python code to copy paste into the otherwise empty UL tag. And that's what this JavaScript code then here is doing. Once it gets back that response from the server, it's using these lines of code to plug all of those LIs into the UL after the fact. Again, changing the so-called DOM. But there's a slightly better way to do this, because honestly, this is not the best design, because if you've got 100 shows or more, you're sending all of these tags unnecessarily. Like, why do I need to send all of these stupid HTML tags? Why don't I just create those when I'm ready to create them? Well, here's the final flourish. Whenever making a web application nowadays where client and server keep talking to one another, Google Maps does this, Gmail does this, like literally every cool application nowadays, you load the page once, and then it keeps on interacting with you without you reloading or having to change the URL. Let's actually use a format called JSON, JavaScript Object Notation, which is to say there's just a better, more efficient, better designed way to send that same data. I'm going to go into shows 2 now and do Flask run. And I'm going to go back to my page here. The user interface is exactly the same, and it still works exactly the same. Here's C, CA, CAT, and so forth. But let's see what's coming back now. If I go to /search Q equals cat, enter, notice that I get this crazy looking syntax, but the fact that it's so compact is actually kind of a good thing. This is actually going to, let me format it a little nicer, well, or a little worse. This is what's called JavaScript Object Notation. In JavaScript, a square bracket means here comes an array. In JavaScript, a curly bracket says here comes an object, aka a dictionary. And you might recall from, you kind of sort of recall that you can now have keys and values in JavaScript notation using colons like this. So long story short, cryptic as this is to you and me, and not very human friendly, it's very machine friendly. Because for every title in that database, I get back its ID and its title, its ID and its title, its ID and its title. And this is a very generic format that an API, an application programming interface, might return to you. And this is how APIs nowadays work. You get back very raw textual data in this format, JSON format, and then you can write code that actually programmatically turns that JSON data into any language you want, for instance, HTML. So here's the third and final version of this program. I again select my input. I again listen for input. I then, when I get input, call this function. I fetch /search Q equals whatever that input was, C or CA or CAT. I then wait for the response. But instead of getting text, I'm calling this other function that comes with JavaScript these days called JSON that just parses that. It turns it into a dictionary for me, or really a list of dictionaries for me, and stores it in a variable called shows. And this is where you start to see the convergence of HTML with JavaScript. Let me initialize a variable called HTML to nothing, quote unquote, using single quotes, but I could also use double quotes. This is JavaScript syntax for a loop. Let me iterate over every ID in the shows list that I just got back in the server, that big chunk of JSON data. Let me create a variable called title that's equal to the title of the show at that ID. But for reasons we'll come back to, let me replace a couple scary characters. Then let me dynamically add to this variable an li tag, the actual title, and a close li tag. And then very lastly, after this for loop, let me update the UL's inner HTML to be the HTML I just created on the fly. So in short, don't worry too much about the syntax, because you won't need to use this unless you start playing with more advanced features quite soon. But what we're doing is with JavaScript, we're creating a bigger and bigger and bigger string of HTML containing all of the open brackets, the li tags, the close brackets, but we're just grabbing the raw data from the server. And so in fact, in problem set 9, you're going to use a real-world third-party API, application programming interface, for which you sign up. The data you're going to get back from that API is not going to be show titles, but actually stock quotes and stock ticker symbols and the prices of at which stocks were last bought or sold. And you're going to get that data back in JSON format. And you're going to write a bit of code that's then going to convert that to the requisite HTML on the page. So the final result here is literally the kind of autocomplete that you and I see and take for granted every day. And that's ultimately how it works. HTML and CSS are used to present the data, your so-called view. Python might be used to actually send or get the data on the back-end server. And then lastly, JavaScript is going to be used to make things dynamic and interactive. So I know that's a whole bunch of building blocks, but the whole point of problem set 9 is to tie everything together, set the stage for hopefully a very successful final project. Why don't we go ahead and wrap up there, and we'll see you one last time next week for Emoji. All right. This is CS50, and this is week 10, our very last together. And before we dive in today, just wanted to acknowledge how much work we know this course is for everyone. We know there's still a tad bit of work remaining, but we do hope ultimately that you're really proud of what you've pulled off over the past few months only. And indeed, the final project, whatever it is you end up building, really is meant to be this capstone where you're finally standing on your own. There's no distribution code. There's not really a specification, and really just an opportunity to take all this knowledge out now for a spin. And we do hope it serves you well longer term. Before we dive into, just wanted to offer a number of thanks for so much of the team that helps out behind the scenes. In particular, the Memorial Hall team, our hosts here who make all of the space and the activities behind the scenes possible. The Education Support Services team who helps with audio and video and more. And then especially CS50's own team, all here in the darkness, helping out in front of the camera, behind the camera. If we could, a huge round of applause for everyone that makes this possible. You might have noticed that these have been unusual times, and we've had some unusual guests in the front of the room here since we weren't sure what to expect early on as to just what protocols would be on campus. And so we have, of course, all of these plush figures behind the scenes who have been helping out behind the camera, behind the monitors, and so forth. And what many of you will see if you've been watching right now or in the future these videos online, you'll see a lot of backs of heads so that there's a little bit of characteristic to some of the shots that we have here. But this is actually born of an inspiration. They come comes from who will be ultimately today's special guest. Jennifer A. Lee, in fact, whom we'll meet in just a little bit, was ultimately the good friend of the class that inspired this tradition of using puppetry in some form in the class here. What I see down below is a shot like this here. And funny enough, it seems that with machine learning, what it is nowadays, artificial intelligence, so to speak, on social media and the like literally no joke, I pulled up Twitter earlier today, and among my suggestions for whom I should follow now were literally these suggestions here. This is perhaps not surprising, though, because some weeks back I actually started following Count Von Count, whom you might remember from Sesame Street. If you are not following him already, this is an amazing account to follow, an actual count to follow. And it's actually an amazing use of programming. So this account joined in April of 2012. It's got 198,000 followers as of today. And what it's been doing for like 9+ years is tweeting out a number, one per day. This morning's was 3,327. Yesterday's was 3,326. And so presumably someone's just written a program, Python or something else, that's just generating these tweets once a day. Even more amusing, though, is that like every tweet for the past 9 years has like 20 or 30 comments on it from people who are following it. So perhaps consider following this same account and the same application of CS as well. Wanted to also thank CS50's team behind the cameras. You might recall the teaching fellows last year in particular, when everything was on Zoom, kindly put together this visualization of TCP/IP and the passing of messages among routers and in turn computers. For instance, from Phyllis at bottom right to Brian at top left. Just wanted to thank the team, but also reveal to you all that these takes were not perfect by any means. And in fact, here's just 60 seconds or so of outtakes of us trying to get data from point A to point B. If we could, too, a round of applause for all the teaching fellows, teaching assistants, and course assistants who make the course possible as well. Before we now do a bit of review of the semester, thought we'd take first a higher level view of where we've come from. Recall, of course, from the syllabus, and literally week 0, we claimed this, that what ultimately matters in this course is not so much where you end up relative to classmates, but where you end up relative to yourself when you began. And we really do mean that. There are certainly classmates of yours who have been programming since they're 10 years old, but there are 2/3 of your classmates who were not, in fact, that case. And so behind you, in front of you, to the left and to the right today, are so many classmates who have had a very shared experience with you. But the only person that really matters at the end of the day in terms of how you've progressed in this class truly is where you, in fact, began. And I realize that with CS, and especially this course, and with programming assignments especially, it can feel like week after week that you're not really making progress, because it might feel like you're struggling every darn week. But that's just really because we kind of keep moving the bar higher and higher, or pushing the finish line a little further and further ahead. Because think back to like week 1, when this, for instance, when this alone was hard, and you were just trying to get Mario to ascend a pyramid that might look a little something like this. Or the week after, when you started dabbling with readability. Or 2 weeks after, Mr. and Mrs. Dursley of number 4, Privet Drive, and so forth, trying to analyze just how complex a sentence like that was, and manipulating strings and characters for the first time. And then, of course, we progressed to deeper dives into algorithms, and actually implementing something that's all too real world these days, and implementing electoral algorithms in a few different forms. Dabbling there thereafter in a bit of forensics, a bit of imagery, and taking images like this here and filtering it in a number of ways, ultimately understanding, hopefully, how these things are implemented underneath the hood, so that henceforth, when all you're doing is tapping an icon on your phone or clicking a command on your computer, you can infer, even if you didn't write that particular code, how the thing is likely working. And even if you had started to get your footing then around week 4, then things escalated quickly further to data structures. But recall, for your spell checker, you implemented a fairly sophisticated data structure known as a hash table. And even if you struggle to get that working, again, think back 5 weeks prior, you were just trying to get for loops to work and variables to work. And so with each week, realized there was significant progress. And then if you aggregate all these most recent weeks with Python and SQL, HTML, JavaScript, and CSS, I mean, you built your very own web application. And many of you will go on and build something grander for your own final project, or focus again on C or on Python alone or the like. But ultimately, aggregating all of these technologies and kind of stitching together something that you yourself created. We might have kind of put some of the foundation there in place, but the end result ultimately is yours. So at the end of the day, as we promised in week 0, this course is really about computational thinking, cleaning up your thought process, getting you to think a little more logically, more methodically, and to express yourself just as logically and methodically. But it's also about, in some form, critical thinking. And at the end of the day, what computer science is really just taking input, producing output, ideally correct output, and all the hard stuff is in the middle there. But what we do hope you have in your toolkit, so to speak, is all the more of a mental model, all the more of an understanding of like first principles from which you can derive new outputs, new conclusions based on those inputs. And certainly today, right, there's so much misinformation or miseducation in the world, and just being able to take input and produce proper output in and of itself is a compelling skill. And indeed, when you all find yourselves invariably in engineering positions where you're asked to build something because you now can, or perhaps you're in a managerial role where you decide you should build something because you know people who can, I would also start to consider, even though the past 10+ weeks have all been about build this because we asked you to really start to consider, whether it's for fun, for profession, for political purposes, or the like, should you build something? And actually considering, now that you have this skill, how you can use it most responsibly. And not just make a website do something or make an app do something because it can be done, but really start to ask, and ask of others, like, should we be doing this? It's just a skill that you can, but don't necessarily have to use. Now, when it comes to writing some actual code, keep in mind that you might continue to evaluate, or your employer or your colleagues might continue to evaluate your code along these same axes. These are not CS50 specific. Correctness, does it do what it's supposed to do? Design, like how well qualitatively is it implemented? And then style, how readable is it? How pretty is it? And these 3 axes should really guide all of your thinking, whether it's for a test or a project or an open source project or the like all 3 of these things really matter. And so if you're in the mindset of wondering, oh, do I have to worry about style for this? Do I have to comment this? The answer is always yes. This is what it means to be a good programmer, a good engineer, to optimize these kinds of axes. Now, what about sort of those tools in the toolkit? Well, let's focus on just a couple here, full circle at the end of the semester. Abstraction, recall, was one of the tools in the toolkit that we proposed, is all about taking like complicated problems, complicated ideas, and simplifying them to really the essence. So you can focus on really just what matters or what helps you get real work done. And then related to that was also this notion of precision. Even as you abstract things away, you still have to be super precise when you're writing code for a computer or just giving instructions to another human so that they are implementing your ideas, your algorithms correctly. And sometimes these 2 goals, abstraction and precision, can rather be at odds at one another. And what we thought we'd do is give everyone a sheet of paper today, which you probably received on the way in, if not a pen as well. If you didn't receive, hopefully you or a friend near you has a sheet of paper and a pen or a pencil. Do go ahead and grab that. And we thought we'd come full circle too and see if we can't get a brave volunteer to come up on the stage here. And we just need someone to give some stage directions. All right, I like it when people start pointing and pointing. How about you being pointed at? Yes? Yes, you. Yes, come on down. Well, there'll be one more opportunity after this. Come on down. What's your name? Claire. OK, a round of applause for Claire for being so enthusiastic. Come on over here. Would you like to make a quick introduction to the group?
Yeah. Hey. I'm Claire. Yeah,
That's all you need to know about me.
All right. So what I'm about to hand Claire is a sheet of paper that has a drawing on it. And the goal at hand is for you all to ultimately follow Claire's hopefully very precise instructions, because she's going to give you step-by-step instructions, an algorithm, if you will, for drawing something on that sheet of paper. All right, we're going to keep it in this manila envelope so that folks can't see through it. But this is what we would like you to give verbal instructions to the audience to draw. And you can say anything you want, but you may not make physical hand gestures or the like. Or dip it down so everyone can see it.
Oh, that's so true. That's so true.
All right, go ahead. Step 1.
Wait, I could say whatever I want?
Related to this problem, yes, I did.
Okay. Oh, my God.
Give them instructions for recreating this picture on their paper.
Okay. Start with, a square, but it's
No hand gestures.
okay. Sorry. Start with a square, but it's like a diamond kind. Like there's a point on top. Wait, I should not be the one doing this. Okay, so it's like a square, but yeah, start with a square.
Okay, step 2.
Step 2 is that on one of the sides of the square, there's another square.
Doing really well on the abstraction.
I don't feel like I'm doing too hot. Okay. Whew. Does this affect my grade in any way?
No.
Okay.
Go
awesome.
on. 2 squares.
Okay.
Step 3.
And then there's like another square, but they're like not squares. They're like kind of slanted. And there's another square in between, like next to those squares, connecting those squares.
Okay. Any step 4?
Step 4 is that it should look like a cube.
Okay, so let's go ahead and pause here. Let's thank Claire for coming on up bravely. I'll take this. Let's go ahead and collect just a few of these. If maybe Carter and Valerie, you wouldn't mind helping me grab just a few sheets of paper. If you'd like to volunteer what it is you drew in those seconds, just hand it over if you would like. No need for a name or anything like that. Okay, all right, very eager, thank you. Okay, thank you. All right. Thank you. Okay. Sorry. Okay, that's plenty. Let's come on up if you want to. Oh, you want to hand me yours too? Okay. Sorry, to reach. All right, so Carter, if you want to meet me up on stage for a second. So we have a whole bunch of submissions here that represent what it was Claire was describing. Let me go ahead and just project here in a moment. Use my camera. So here we have one. Let's see, Carter, feel free to just bring those on up here. OK, so here we have one I'll hold up. All right, so some squares overlapping started to look more like a cube. Thank you so much. Here, maybe in more primitive form, was another one. This one kind of started to have wheels, which was kind of and then things started to take shape, perhaps at the very end, both big cube and small cube. What it was that Claire was showing us now, if we project it, was in fact this. And it's actually exactly what, Claire, you just went through is actually a perfect example of like why abstraction can be hard and where the line is when you're just trying to communicate instructions. So in fairness, it might have been nice to just start with, we're going to draw a cube, and like, here's how, because that was kind of a spoiler at the end. But that too, a cube is an abstraction. But it's not very precise, right? Like, how big is the cube? At what angle is it rotated? How are you looking at it? And so when you were struggling to describe these squares, but no, they're kind of like diamonds or whatnot, I mean, that's because of this tension between what it is you're trying to abstract, but what it is you're trying to communicate. You could have gone maybe the complete other direction and maybe have been super precise and not abstract this thing away as a cube, but say to everyone, all right, everyone, put your pen down on the paper. Now draw a diagonal line to, say, southwest at 45 degrees. Now do another one that's south. You could really get into the weeds and tell people to go up, down, left, right. Of course, it could get a little tricky if they sort of follow the direction incorrectly, but it would be hard for us all to know what it is we're drawing if all we're hearing are these very low-level instructions. But that's what you're doing when you're writing code. You might implement a function called cube. How it works is via those low-level instructions, but after that, you just don't care. You'd much rather think about it as a cube function, maybe with some arguments that speak to the size or the rotation of it or the like, and that's where, again, abstraction can come in. So as we've discussed for so many weeks now, these trade-offs were manifest even in week 0, even if we didn't necessarily put our finger on it just then. Well, why don't we do things in a slightly different direction? If we could get one other volunteer. OK, come on down. I saw your hand first. One other volunteer who this time we're going to give the pen to. We're going to give the pen to. And what's your name? Jonathan, come on up. So I'm going to make this screen be drawable in just a moment. But what we need you to do first on the honor system is close your eyes. All right, eyes are closed. Everyone else in the audience is about to see the picture that we want you to draw. And you all, the audience, are going to give Jonathan the step-by-step instructions this time around. So eyes stay closed. This is what we're going to want Jonathan to draw. So kind of ingrain it in your mind. If you need a refresher, we can have him close his eyes again. But that's what we want him to draw. I'm going to go back to the blank screen. All right, Jonathan, you can open your eyes. We have a blank canvas. And now, step 1. What would you like Jonathan to draw first? Draw a circle, I heard. OK, it's a little smaller, I'm hearing now. OK, you can move it. Oh, no, don't do that. All right, we'll give you one redo. Use 3 fingers to delete everything. 3 fingers all together. Yep. There we farther apart. There we go. No, it's back. OK, I'll do this part. Yeah. OK. All right. So I heard, thank you. I heard draw a circle. Would anyone like to finish the sentence more precisely? A smaller circle. On top. A medium-sized circle at the top. All right, that's pretty good. Medium-sized circle at the top. And no more deleting after this. Good. All right, step 2. A line straight down. Yeah, OK. Good. All right, that was step 2. Nicely done. What's that? Step 3? Draw a line down from the bottom to the left. OK. Good. All right, next. Let's go over here. Next one. Same thing, but on the right. Yes. All right. That's what? 1, 2, 3, 4. Step 5. Yes, step 5. Do that again, but higher, closer to the circle. On the right side. All right, we're going to have to go with it. Step 6. Step 6. Starting from the neck, draw a line down and to the right. You don't like that. He's What do you want him to do? Step 6. Can't no one do. Where the other line ends, say again. Where the other line ends. Near the vertical line. Where the other line ends. Draw a line that goes down. OK. Couple more steps. Step 7. 7. Draw a horizontally slanting line from the end of the line you just drew. Diagonally. OK, we're resorting to hand gestures now, but I think that's what you mean. Yes? OK, good. Good. All right, have 1 or 2 final steps. Let's get as close as we can. Say hi. Make him say hi. No. OK, hi. OK, and maybe one final step. We'll give him one more. Say again? Again? Put one of those lines from high to the circle. A line between high and the circle. All right, let's show Jonathan. That's pretty darn close. Let's show him what we had in mind was this. So a round of applause for Jonathan, too, if we could.
Thank you.
A bigger round of applause for Jonathan, if we could. All right. So, I mean, this is actually, there is this thing in computer science known as pair programming, where you actually program with someone else. And that's actually not all that dissimilar, trying to communicate your ideas to someone else. But notice just all of the ambiguities, and it certainly doesn't help that we're in a big space, but all of the ambiguities that arise when you're just trying to convey something precisely. So this is not necessarily as constrained as a program would, but it's representative of, at the end of the day, even after all these weeks, this stuff is hard. And in fact, it's not necessarily ever going to be completely straightforward, because the problems you're going to try solving down the road, presumably, if you continue to apply these skills, themselves are just going to get more and more sophisticated. But hopefully the feeling you get from accomplishing something as a result is just going to rise with them as well. Before we now do a bit of review, just wanted to offer a few suggestions in answer to an FAQ, which is like, what do I do after a class like CS50? Typically, about half of you will go on and take one or more other classes in CS, which is great, building on this kind of foundation. And about half of you will not. Like, this will be it. But very likely, certainly given how the world is trending, will you have opportunities in the arts, humanities, social sciences, or beyond to just apply programming to data sets, to problems in those own domains. And so toward that end, we would encourage you to start thinking about how you can transition from what has been your code space in the cloud to something client-side, like using your own Mac and PC here on out, so that you're not reliant on a courses infrastructure, a particular website. And even though we used a fairly industry standard tool, you can actually get almost all of that stuff running, with some effort perhaps, on your own Mac and PC. So terminal windows actually come built into Mac OS. If you go to your applications folder, utilities, there is a program literally called Terminal that has always been there, even if you've never used it, that will behave very similar to what VS Codes does as well. In the world of Windows, can you similarly install a version of the terminal Windows software that we used in the cloud too, to actually run similar commands like cd and ls and much more? We would encourage you ultimately to learn Git. You've been indirectly using Git this semester. When you run certain commands, we have been using Git underneath the hood of some of CS50's tools that essentially push your code, so to speak, to the cloud, to a place like github.com. But Git itself is an incredibly powerful and just useful tool for, one, backing up your code somewhere else to the cloud, which is effectively what we've used it for, but two, collaboration, so that you can actually share your code more readily with other people, and three, building much bigger pieces of software where each of you work on different files, different folders, or even just different parts of the same file, and then somehow merge all of your handiwork together at the end of the day to build something much bigger than you as one person could alone. VS Code itself now, too. We've been hosting it in the cloud, a real version of VS Code, but it's much more commonly used on people's own Macs and PCs. And you can download it onto your own Mac and PC. You might have to jump through a few more hoops to get things like C working, though Python is much easier to get working as well. Some of the configuration won't be quite the same, like your prompt might look a little different and the like. But that's just going to be the case anytime you sit down in the future at a different system. It's going to look and feel a little different to things you've used before, but hopefully there'll be enough familiarities that you can get yourself up and running pretty quickly nonetheless. Hosting a website, not necessarily something you have to do or will do for your final project, depending on your proposal, but there's lots of ways to just host your own portfolio page, home page, website, whatever, on the internet itself using tools like these, GitHub or Netlify or other tools too, most of which have like free student-friendly plans. Some of these are indeed paid services, but they very often have entry-level plans that are totally fine if it's just you on the internet and you don't expect having thousands, 10,000s of users. It's a drop in the bucket for these companies, and so they very often have free tiers of service. If you want to host something more dynamic, something like CS50 Finance that takes user input and output, uses sessions, uses databases, you might like something like Heroku. And for instance, we have some documentation on one of CS50's websites for actually moving your implementation of CS50 Finance over to this third-party application called Heroku, so that you can actually run it or something like it in the cloud as well. Here tier 2 using a free tier of service. All of these providers, these are big cloud providers these days. Amazon, Microsoft, Google, and others all have student-friendly accounts that you can sign up for during or shortly after you're in school that just give you free compute time and storage. GitHub itself has this whole student pack that by transitivity gives you access to a whole bunch of discounts on other things as well. So if you're liking this stuff and you just want to learn more, perhaps over break by playing on your own, these then would be some good starting points. And as for just keeping abreast of trends in programming and technology or the like, there's so many different blogs and websites out there, but here are just some. A couple of different subreddits, so to speak, on Reddit that are very programming specific. Stack Overflow, with which you've probably interacted. Serverfault, which is similar. TechCrunch, Y Combinator, and other sites too. And ultimately, we would encourage all of you to stay in touch, certainly beyond today. By the time you finish your final projects, we'll have something waiting for you. And if you want to stay engaged, either on the teaching staff or just as a lifelong learner of CS and programming, by all means, check out any of these URLs here. But in just a few weeks' time, will you have one of these to your name, your very own I Took CS50 t-shirt, which we will distribute before long as well. And now, if we may, we have an opportunity here to synthesize the past several weeks of material. If you would like to go ahead and open up the URL that we put on the screen earlier, I'll toss it up here again. You can use your phone or your laptop. You might recall for a previous problem set, we asked you to propose a whole bunch of review questions, multiple choice or the like, that synthesized the past several weeks of material. We took some of our favorite submissions of those, ported it to this Poll Everywhere platform so that we could interactively see where everyone's minds are at, understanding is at. And I think you'll find all of these are written by you and your classmates, that we slipped a few fun ones there, also written by you along the way. If Carter, you want to come on up here to get us ready. If you haven't yet opened the website, go to this URL here on your phone or your laptop. And let me go ahead and switch us over here before Carter takes control of this machine here. Here's that same 2D barcode again. Feel free to background that now. And in just a moment, we've got a 20-question quiz show. It's all multiple choice. So long as you have internet access, whether you're here physically or online right now, you should be able to buzz in within 10 to 20 seconds of seeing a question. And I'll read each one aloud. I think, Carter, we're just about good to go. So does everyone have the software up and running on their phone or their laptop? If not, no big deal. Just look on with a friend. But otherwise, Carter, do you want to say hello too and tee us up?
Absolutely. Hi, everyone. We're going to go ahead and get started here with our first question. Speed here matters. So our first question, David, go ahead. What is it?
All right. What does CSS stand for? Is the first question written by you. 4 possible options are cascading style sheet, coding style sheet, cascading style system, coded style sheet. 15 seconds, up to 300 responses already, both here in person and online. Give folks a few more seconds. What does CSS stand for? These are the 4 options that were provided. 3, 2, 1. Carter? Cascading style sheets at 86% is indeed the right answer. So congrats to those of you, 86% who got that one. Here's the leaderboard. You all have fairly random usernames. But if your username is on this board here, or really any of the 86% of you that just got that right, all of you are currently in the lead. But we'll see if this shifts before long. Question 2, which best describe the role of a compiler is our next question. Debug one's code, run the written program, distinguish between functions and arguments, turn source code into machine code. 300 responses in so far, 10 seconds to go. Which best describes the role of a compiler? 3 seconds, just crossed 400. And Carter? Turning source code into machine code at 92%. Some excellent progress there is indeed the correct answer. And indeed, more generally, a compiler just converts one language to another. The use cases we've seen for it have been only source code to machine code. But as you go out into the real world, you'll actually find there to be compilers from one source code language to another source code language that itself might be runnable or compilable thereafter. Good job to all of you guests. And Carter, number 3. What is the type of argc? Asks a classmate. Int, stir, char, float. What is the type of argc? All right, about 350 responses. 7 seconds to go. About to cross the 400 threshold. And 3, 2, 1. The type of argc is Int is indeed correct, but we're now starting to distinguish, folks. Only 55% there. Char is not correct. You might be thinking of argv in C, but even that is not a char. It's a char star array, or a char star star, in fact. So it's not just a char. Stir is in Python, but even that, too, if you were thinking of sys.argv, that would be a list of stirs, not a single stir. All right, Carter, it's the leaderboard. All right, there are our guests, all still tied. And number 4, what is the searching efficiency of a balanced binary search tree? Big O of n, big O of n squared, big O of log n, big O of n log n. What is the searching efficiency of a balanced binary search tree? The balanced being key because, as folks continue buzzing in, recall that binary search trees can devolve into linked lists. Big O of log n is correct for 54%. All right, now people are getting annoyed, but let's keep going. Number 5. Leaderboard's not yet that interesting. More subtle, what was the CS50 duck's Halloween costume? He's here in winter dress today, thanks to Valerie. A skeleton, a vampire, Frankenstein, or a ghost? What was its costume at Halloween a few weeks back? Answers are coming in a little slower this time. People online are perhaps clicking on the video. And vampire is correct at 69%. Nicely done. All right, guests are still shuffled in the top. Oh, and we're starting to see some leaders pull ahead. The time in which you buzz in is also taken into account now. In C, how can we unify several variables of different types into a single new type? Trees, arrays, structs, tables. Oh, it got quiet. In C, how can we unify several variables of different types into a single new type? 8 seconds. 400 responses in. 450, and the answer is structs are indeed correct. Recall that we had a student struct, and we saw structs later on for nodes that allowed us to cluster multiple variables or data types inside of our own brand new structure that we then type def to a name. Carter, shall we see the leaderboard now? All right, whoever guessed 40, 45, and 43, 83 have eked ahead ever so slightly. So buzzing in fast can now benefit your score too. Next question, Carter. In Python, which of the following statements is false? Tuples are an ordered, immutable set of data. Dictionaries associate keywords with values. Arrays in Python are fixed size. Python is an object-oriented language. Which of those statements is false? 3 seconds. Answers coming in more slowly. But the most popular answer is correct. Arrays in Python are indeed not of a fixed size, which is why that's false. They're not even called arrays. They're called lists. And recall that they dynamically grow and shrink, effectively implemented for you as a linked list. All right, how do we? All right, we have a leader. Whoever 4383 is, nicely done. What does strcomp return in C? strcmp. Does it return a Boolean, an integer, a string, or a char? What does strcomp return in C? Used to compare two strings, of course. Recall that it returns potentially not just true, false, but, ooh, an integer is indeed correct. Does anyone recall why? Why is it an int and not just a simple true, false? Why are 3 values helpful? Exactly. It returns 0 if they're equal, or it returns negative value or a positive value based on whether one string comes before or after the other, ASCII-betically, so to speak, based on its ASCII code. The results, Carter? All right, 4383, still doing quite well, but being caught up with here. What is David Malin's phone number? 949-468-2750. Play when you call it. The Harvard alma mater, a parody of Yale's song, a recording of David Malin singing Never Gonna Give You Up. Feel free to call or text. I can't get it now, but we have nicely automated that process. 4 seconds, 400 responses in, and the answer, of course, is never gonna give you up. Thanks to a little programming in a script that our friend Rong Shin wrote that essentially answers the phone automatically and replies with a URL or a song. Carter? Oh, dethroned. Dethroned. 2688, nicely done. Next question. From which of the following places does malloc get free memory for a program to use? Heap, stack, array, or pointer? From which of the following places does malloc get free memory for a program to use? Answers are a little slower this time. 5 seconds. And the answer is in... OK, that's the answer we were given in the problem set. But I think we would beg to differ. Pretty sure, Carter, would you go with?
I would go with the heap.
I think it's indeed the heap. So this answer, not correct. I know. We just transcribed what you gave us, though. Let's see how that affects the scores. OK, 2688 is still doing OK. Next question. About 10 or so to go. Suppose I have an unsorted list of items, store receipts perhaps. Should I sort the items before searching for an element? Yes, you should always sort before searching. No, you should never sort before searching. If you will be searching the list many times, then yes, you should sort first. If you will be searching the list many times, then no, you should not sort first. Some nuanced replies. 5 seconds. Fewer answers than usual at this point. And if you will be searching the list many times, then yes, you should sort first. An example that we discussed of trade-offs, because if you're just going to do a one-off search and never again, why bother incurring n log n or n squared time to actually sort the thing? All right, some shuffling happening, but 2688, nicely done. Next question. When you run the create index command in SQL, what type of data structure do you create? Array, B trees, linked lists, hash tables. When you run create index, recall we did this with like the movie titles, the TV show titles, to speed things up so that things wouldn't be super long and linear. We did a different data structure. All right, about 400 responses in. The answer is indeed B trees. B trees. Not to be confused with binary tree. A B tree typically has other children besides 2 that pulls the data even higher up from the leaves of the tree. Could use a hash table, could use a linked list, but indeed the technology in databases is generally these things called B trees, certainly in SQLite. Carter? Oh, dethroned, but 4179 has now pulled ahead. Nicely done. Next question. What HTTP status code means I'm a teapot? 000, 418, 007, 128. This, recall, was a April Fool's joke by technical people some years ago that has become part of computing lore. It's still there, though, in the document. In 2 seconds, we'll know that it's 418 indeed. Let's see how that affected things. 4179 is way down on the list. 7280 is number 1 now. Nicely done. What is an example of a SQL injection attack? When someone submits malicious SQL commands via web form, physically destroying a computer hardware that stores a SQL database, overwhelming a server with thousands of requests to access a database. Injection attacks are only in movies or TV. 5 seconds. Some fun answers. 400 responses about in. And indeed, when someone submits malicious SQL commands via a web form because the programmer is not escaping the code using the question mark syntax that we've seen, using CS50's library or other third-party libraries like it. Carter? 7280 is still the guess to beat. Nearing the end, few more questions. How are the elements of an array stored in memory? Contiguously, in random locations that happen to be available, as a linked list, as a binary tree. How are the elements of an array stored in memory? About 5 seconds to go. Almost have everyone in. 2, 1, and contiguously is indeed the right answer. Back to back to back in random locations that happen to be available is probably describing your use of malloc in the heap, but you would then need a linked list or some other structure to stitch those locations together. An array, by definition, is contiguous. Carter? 7280 is hanging on to that lead by about 499 points. Next up is, which SQL query would allow you to select the ID of a specific movie star, Zendaya, in a table of movie stars? Select ID where name equals Zendaya. Select star ID from movie stars where name equals Zendaya. Select ID from movie stars where name equals Zendaya. Select ID from movie stars where name equals quote unquote Zendaya. And I'm spoiling it. I should have read out some quotes earlier too. 1 second. The last one is correct. And indeed, this one's almost correct, but lacks the single quote. Zendaya is not a single, it's not a SQL keyword. It's, of course, a string. So it does need to be escaped there. But 63% of you realize that. 7280 is still in the lead. I think we have a few more questions to go. Why is a hash table faster to search than a linked list, even though the runtime for both is big O of n? The hash table actually has big O of n squared runtime. The hash table optimally has omega of O runtime. The hash table creates shorter linked lists to search rather than one long linked list. The hash table takes less memory. And this was an example of practical versus theoretical differences. And indeed, that was interesting. With 83% of you buzzing in, the hash table creates shorter linked lists, ideally, if you have a good hash function, rather than one long linked list, even though technically it's still in big O of n. 7280 seem to know that, is pulling ahead of the crowd. Still a few questions. Is Game of Thrones is a ... comedy, drama, historical, fantasy, documentary, romance, sci-fi, or all of the above? This is written by your classmates, recall, based on our SQL week. In 5 seconds, we'll be reminded that, according to our CSV file, they were all of the above. OK, all of the above. All right, 7280 did OK with that. Next question. Which of the following is a golden rule when allocating memory? Every block of memory that you malloc must be freed. Only memory that you malloc should be freed. Do not free a block of memory more than once. All of the above. More into the nuances of C. This golden rule when allocating memory. Didn't have to worry about this in Python. We did in C. In 2 seconds, we'll know that all of the above are indeed things you must do. Not doing those would be, in fact, bugs. Carter, the leaderboard? Still doing well. 7280, whoever you are. Last few questions. Last question, in fact. Last question. What do the binary bulbs on stage spell today? The answers could be face with medical mask, face with tears of joy, snowman without snow, or red heart. What do the binary bulbs on stage spell? 6, 5, 4, 3. The answer is the red heart. Taking a look at the leaderboard here, who's our winner? The winner is, guest 3487. A big round of applause for our guest. Thank you to Carter. So it's nice that there's some opportunity here because recall that in week 0 we did start talking about emoji and really about data and representation. And we talked not about just binary, but ASCII and then Unicode. And then when we had Unicode, we had all of these additional bits that we could play with. And we could start to represent not just letters of the English alphabet as in ASCII, but really letters of any human alphabet and even alphabets that are continuing to develop. And indeed, this was faced with medical mask, which we claimed at the time was just how a Mac or PC or Android phone or iPhone nowadays would interpret and display a pattern of bits like this. This happening to be for the 4 bytes that represent that particular emoji. And over time, humans have been deciding to use different patterns for new emojis that might not have existed yesterday. And indeed, most any time you update your Mac or your PC or your phone these days, at least on a semi-annual basis, are you getting some new and improved emojis. And they're not just these faces now. They're, of course, representing different human emotions, different physical objects. And ultimately, among the Unicode Consortium's goals is to be able to represent all human languages. But were it not for certain groups of people and certain individuals, these things would all rather look fairly similar. And indeed, today, we're so pleased to be joined by an old classmate of mine, Jennifer Aitley, who was class of '99 here at the college, who's gone off to do many, many different things in life, prolifically so. Not only has she been a writer, an author, a journalist for the New York Times, a producer of films like The Harvard Computers, The Search for General Tso, and The Emoji Story, which focuses on exactly today's topic. Jenny and her colleagues have been involved particularly with championing representation of different types of people and cultures and languages. And these are just a few of the emojis that our friend Jenny has indeed brought into creation on our phones and laptops. Jenny, too, is the original inspiration for what has become, it seems, my Twitter recommendations and all of these puppets. I was visiting her in Manhattan one time some years ago. She had on her shelf a couple of puppets known as Muppet Whatnots. At the time, you could go to FAO Schwartz or the website, therefore, an old toy store, and you could actually configure your very own Muppets. And I thought this was the coolest thing. And literally on the cab ride home from her place was I logging into the website, configuring a couple of puppets. A couple weeks later, they arrived, and then rather sat on my shelf for a couple of years as I wondered why I had just bought 2 Muppets in the back of a cab. But brought them into the office at one point. A colleague saw them, drew inspiration from them, and now have they been woven really into the fabric of this course in particular and a lot of the course's pedagogy, at least incarnated here just for fun, but also in video form as well. Which is only to say, so glad that our friend Jenny Aitley is here for us today to talk about these emoji. Jenny?
Hi. All right. Well, this is very exciting. I took CS50 in 1994. To give you a sense, one of my blockmates was the first intern for Netscape, if you guys have ever heard of Netscape. And I graduated just as Google was coming. Like, we did not have Google when we were undergrads. So it's an honor, obviously, to be in at CS50. It's also very impressive to see how David has turned it from entry-level computer science course into a lifestyle brand that is world-renowned. So it's an honor, and I'm going to talk to you today about how an emoji becomes an emoji. So first, I'm going to talk about my journey down a rabbit hole of how I got involved with emoji. So this is my friend, Ying Liu. She is a designer famous for designing the Twitter fail whale, which was like this kind of image that popped up when Twitter went down, which back in the day was rather often. So she's Chinese Australian American, so which is like a weird, interesting combination. And so one day we were texting about dumplings because that is what Chinese-ish women do. We text about food. And so I sent her this picture of dumplings, and then she said, yum, 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 yum. You know, knife and fork, knife and fork, knife and fork. And then she was like, oh, I'm surprised that Apple doesn't have a dumpling emoji. And I'm like, oh yeah, that's kind of weird. And you know, it's one of those things where, you know, the thought comes to your head and then it leaves. I was, you know, it was just sort of an observation. But then half an hour later, onto my phone pops up this like dumpling emoji with hearts. Actually, you can't see it here, but it actually had like blinking eyes. So she called it bling bling dumpling. She's a designer, so she decided she was going to fix this like lack of dumpling emoji problem. And I was actually like really puzzled, like how could there be no dumpling emoji, right? Because, you know, I knew that emoji were originally Japanese. This, by the way, was back in 2015. So Japanese foods, super well represented on the emoji keyboard. You have ramen, you have tempura, you have curry, you have, bento box, curry, then tempura. You even have like kind of slightly weird foods, like, let's see, you have these like things on a stick, which are fish cakes, I discovered. Then you have this white and pink swirly thing, which is also a fish cake. You even have this like triangle thing that looks like it's had a bikini wax. But in essence, there were all these foods that were on the keyboard, but there was no dumpling, right? And I was like, dumplings are this kind of universal food. Like every culture has some version of a dumpling, whether or not it's empanadas or ravioli or, God, what else? Ravioli, pierogi, momos, jiaozi. The whole idea is all cultures have basically found the idea, like this concept of like yummy goodness within a carbohydrate shell, whether or not it's baked or steamed or fried. So dumplings are universal. Emoji, I didn't use them that much, but I was like, they're also kind of universal. So the fact there was no dumpling emoji told me like whatever system was in place failed. And I actually had no idea. I was like, who controls emoji? I'm going to go fix this problem. Like there is something wrong with the universe if there's no dumpling emoji. And I took it upon myself to like go fix that. So I Googled, and I basically discovered there was this thing called the Unicode Consortium, which is a nonprofit based in Mountain View, California, that when I looked had these like 12 full voting members. So this is late 2015. Of those 12, 9 were multinational US tech companies. So there was Oracle, IBM, Microsoft, Adobe, Google, Apple, Facebook, and Yahoo. So these were 8, I think. And then you had the German software company SAP, the Chinese company called Huawei, and then the government of Oman. So these were like basically the people who were in charge and had full voting power on Unicode. So they paid $18,000 a year to have this full voting power, which is a lot of money. I was like kind of very indignant on like how this cabal of tech companies basically control this global curated image-based language on your keyboard. So there was a little bit of a kind of loophole, which is you could pay $18,000 a year to have full voting power, or you could pay $75 a year as an individual. You had no voting power, but you had the ability to sign up for the email list and also show up at the meetings. So put in my credit card, got on the email list, and was kind of checking my email one day when there was an invite that said they were going to have a quarterly meeting, and I think this was going to be October 2015. And I looked, it was in Sunnyvale. I looked at my calendar. I looked at, the point that I was actually going to be able to be in Silicon Valley at that time. So I took a bus to Apple, where they were having that meeting. And I don't know completely what I thought I was going to see. I think maybe it was going to be maybe like a Sanders Theater or like a little mini Congress, like people making emoji decisions. But that was not what it was. Basically, this is the room where it happens. These in 2015 were the people who were deciding emoji. These were emoji decision makers, which were not like the most demographically kind of diverse group. They had a sense of humor about it. One guy had a shirt that said "Shadowy Emoji Overlord." And so I decided, along with my friend Ian Liu, to create a group called Emoji Nation, whose motto is emoji by the people, for the people. And it kind of brought the voice of the normal world into the decision-making chain. So, we launched a little campaign about dumpling emojis. We made a Kickstarter video. Let's see.
Dumplings are one of the most universal cross-cultural foods in the world. Georgia has kinkali, Japan has gyoza, Korea has mandu, Italy has ravioli. Poland has pierogi, Russia has pelmeni, Argentina has empanadas, Jewish people have kreplech, China has pot stickers, Nepal and Tibet have momos. Yet somehow, despite their popularity, there is no dumpling emoji in the standard set. Why is that? Emoji exists for pizza, tempura, sushi, spaghetti, hot dog, and now tacos, which Taco Bell takes credit for. We need to right this disparity. Dumplings are global. Emoji are global. Isn't it time we brought them together? Oh yeah, and while we're at it, how about an emoji for Chinese takeout?
So this is Thanksgiving of 2015. I wrote a dumpling emoji proposal. This is it. Kind of different styles, like whether or not it's a head-on view or a slightly diagonal view. And so that's Yi Ying with then one of the co-chairs of the emoji subcommittee. And so along with dumpling, we also did takeout box, we got chopsticks, and then fortune cookie, which actually, I have to be honest, I don't think fortune cookie would have gotten in on its own merits were it not on the coattails of the other three. So we got these 4 through, and that is how they look today. And I have to say that dumpling looks really photorealistic in the Apple world, unlike the fortune cookie, which has like no slit. It looks like a dead Pac-Man. I don't know what is going on with that design, but so very proud. I also did a lot of research on Chinese food in America and wrote a book called The Fortune Cookie Chronicles, produced a documentary called The Search for General So. So like I had a lot of moral authority on the issues of Asian food in America. Not all things, but this one I felt like I had like made a mark on the 2,500 year history of dumplings by moving them into emoji. So it kind of gets into this very complicated thing, like how does an emoji become an emoji? And it's actually fairly complex. So let's say you have an idea for an emoji, you write a proposal, and then you submit it to the emoji subcommittee that then like debates and thinks about it. Sometimes they have feedback and they kick it back to you, and if so, then you have to revise it, and it kind of goes around and around in a circle. And then once they're happy with it, they kick it to the full Unicode technical committee, which is sort of a governing body within Unicode on things technical and encoding. So what are the kinds of things that impact whether an emoji can be an emoji? So one, is there popular demand? Is it frequently requested? And at this point, one of the very crude ways that we measure is if you search for it on Google, this would have more than 500 million kind of like results, which is what elephant gets in English. And that's sort of like a median, like elephant is like kind of right in the middle of like popular emoji and not popular emoji. So we use that as a benchmark. There's a plus if there's multiple usages and meanings. For example, like sloth. That was an emoji that we did. It also, it's both literally kind of an emoji of an animal, but it also has lots of connotations. So if something has lots of multiple meanings, that kind of gives it a bump. One thing is visually distinctive. Like, does it work at little tiny emoji sizes? And that's actually really hard because there are some things that I think could have been emoji, but don't completely work when you try to shrink it down. And I'll give some examples of that later. And then kind of filling the gap or completeness is another factor. So for a long time, we had red heart, yellow heart, green heart, blue heart, purple heart. There was no orange heart. And so there was a gay designer from Adobe who was like actually very heartbroken by that. So he had been substituting the pumpkin to get the orange, to get the rainbow. And so he proposed an orange heart. And that was, obviously at that point, you're like, yes, that will complete a set. And another thing is it already something that, one of the companies has, and therefore everyone else is going to like adopt it? And so a good example for that is the binary, I think it was the non-gender binary emoji, the pink, blue, and white flag. So I have to say, WhatsApp is by far one of the most rogue platforms. So they just like randomly like added it one day, and we just noticed it, and we're like, oh God, given that they have to do it, now we have to build it into the step. So factors of exclusion, or against inclusion, to be more PC. Sometimes if it's too specific or narrow, that works against being included. So poutine, which the Canadians love, was kind of really specific, and I know it's really important to the Canadians, but it just kind of didn't have enough sort of global appeal. If it's redundant, so an example for that is a couple years ago, Butterball proposed like a roasted turkey emoji, but we already had like an unroasted live emoji of a turkey, so it wasn't clear that we needed the cooked version to go with like the live version, so that didn't pass. Not visually discernible. So this one's actually really tricky and knocks out a lot of things. So it knocked out kimchi, for example. Really hard to do kimchi at emoji sizes. Like, how are you gonna, is it in a jar? Is it like, just sort of in a little bowl? So kimchi kind of died on that. Another one that was really hard was cave emoji, actually, really hard at emoji sizes. And then this is interesting, no logos, brands, deities, or celebrities. And this is a new policy we just introduced, which is no more flags. Flags were killing us in terms of all kinds of complicated reasons, and there was much regret that we ever added flags, and lots of politics. So at this point, no more flags. So once it kind of gets passed into the full Unicode Technical Committee, the proposal gets voted on like once a year, and then they pass all the emoji for the next year. We just actually did that a couple of weeks ago. And it takes a while. It gets sent to all the companies like Apple, Google, Adobe, Facebook, and then they add it to all your devices. And then, ta-da, it takes about 18 to 24 months from when you first have your proposal to when it lands onto your devices. So Emoji Nation has worked on a bunch of emoji, and so we've kind of shepherded this through. So one of the interesting questions is, why is it that Unicode controls emoji? So a lot of it has to go it has to do with the history of emoji. They were originally popularized in Japan. There was one of the initial sets is from 1999 from Docomo. These were actually recently collected by the Museum of Modern Art in New York City. And so all the Japanese vendors had these like little glyphs that they added to their character set. And the main problem is, like, if you were Docomo, you had like, one set. If you were in SoftBank, you had another set. So no matter what, you could only kind of text with people who are on your platform, not across platforms. And that was a real big problem when Apple and Google started introducing smartphones into Japan, and there was sort of this kind of understanding and expectation that if you did something in your smartphone, you also want it to show up in email and be sent into the ether, and someone else is supposed to get the same image that you sent. So that was not the case. So in 2007, they went to Unicode and asked them to basically unify the emoji set. And Unicode is interesting because its mission is to enable everyone speaking every language on Earth to be able to use their language on computers and smartphones. And they actually see this as a human right, because at a certain point, if your language cannot be captured digitally, it's going to disappear. So they spend a lot of time doing Chinese, Arabic, Cyrillic in the very early days. In 2001, they actually had a proposal for Klingon, which they did not actually accept at that point. So they have 3 major projects. They encode characters, including emoji. That's actually what they're most famous for. They also have a bunch of localization resources. So that's like, in this country, they use this as a currency, and they use this kind of time format. And it's, whether or not it's month, date, year. In some countries, it's, date, month, year. In other countries. So they kind of tell you what country cares about what. And then they also have the libraries so that no one's basically programming things from scratch. So what's really funny is if you say CLDR really fast, it sounds like seal deer. And this really confused one of the girlfriends of one of the engineers why he was always talking about seal deers. And so she basically surgically attached a bunch of antlers to this little guy and made a seal deer. And so it took 3 years between 2007 to 2010 to introduce the first Unicode emoji set. So these were the ones that kind of came out. It took many years to figure out how to reconcile all the different images and which ones should we include, which ones we shouldn't include. And as you guys probably know from CS50, a Unicode code point is a unique number assigned to each Unicode character. So you can represent that emoji tears with face with tears of joy as this, or the binary code. So emoji are just kind of hanging out on your phone after 2010 until 2011, when Apple suddenly made them much easier to access on your phone. And one of the kind of confusing things, of course, is emoji are very ambiguous, and it's not always clear what they mean, and that's one of the great joys, right? It can be more, there's much more interpretation in terms between the sender and the receiver. So if you actually if you start doing that on Google, the autocompletes are what does it mean when a guy sends it to you? What does it mean when a girl sends it to you? And clearly, many people have been confused by that emoji when it's been sent to them. So who can propose emoji? And the short answer is basically anyone. There's a Google form that is open between April and August. So the hijab emoji actually was originally proposed by a 15-year-old girl who is Saudi Arabian but lived in Germany, Rayouf Al-Humaidi, who actually got into Harvard and then chose Stanford. So I was giving her a hard time about that. I know, well, I'm kind of on that. I was like, So she wrote the proposal, and it got through. And she's actually the subject of the documentary that we put together called The Emoji Story. We also have a group of Argentinians who fought really hard for the mate emoji, their national drink. And then there was this nonprofit for girls' advocacy that really wanted a menstruation emoji. And they sent in this bloody underpants proposal, which is like really terrible, I'll be honest. So we kind of worked with them and got blood drop, which actually is actually is done pretty statistically well. We were kind of surprised actually how popular it is. The skin tone emoji were actually proposed not from within Unicode, clearly. It was done by a mom from Houston who's also an entrepreneur, because their daughter came home one day and said, I'd really like an emoji that looks like me. And her mom, Katrina Parrott, was like, that's great, honey. What's an emoji? And so, but she actually had worked in procurement with NASA, and so she understood forms from proposals, and she actually was the one we should thank for having like 5 skin tones today. Women's flat shoe and sort of the one-piece bathing suit, as opposed to just the yellow, teeny weeny yellow polka dot bikini, is a mother of 3, now 4, who just wrote that because she was very offended that all of the shoe emoji had high heels for women. I actually really like this guy. Some random guy in Germany came up with this emoji, as we like to say, it's a Colbert emoji. He wrote a proposal and it got accepted because it was a really good proposal. Then you even have governments. The Finnish government, like literally the Finnish government, their equivalent of the Department of State, proposed a sauna emoji, which these are the images, and I think they're really ugly. There's so many problems with this emoji, but we helped them as Emoji Nation. First, we got rid of the club feet, and then gave them sort of examples do you want them to hold the ladle? Do you want the sort of steam around it? Do you want it with clothing or not clothing? We actually did a little bit of a towel for the more modest in us. So it got passed, and then the way it ended up is basically person in a steamy room. So this is how it kind of evolved. So you can see that is what Finland kind of submitted, that is what we submitted, and then that is how it's ended up on your phone. And that is basically supposed to mean sauna emoji. So one of the questions is why do I care so much about emoji and representation of emoji? And a lot of it has to do with the fact that I grew up speaking Chinese and going to Sunday school or Saturday Chinese school. And as you can see, there's sort of some really interesting parallels between modern day emoji and Chinese radicals and characters from a long time ago. So this is fire, this is mouth, this is tree, this is moon, this is sun. And you can mix and match them in Chinese as well. So one of the interesting ones is 2 trees together basically makes a forest. You have a sun and a moon together, and that means bright in Chinese. It's kind of fun. Then this one's fun, right? So it's basically a pig underneath a roof. So you're oh, maybe that means farm, or I don't know, a barn or some kind of animal thing. But actually that in Chinese means home, jia, or family. So home is where your pigs are, which I think says a lot about society and what people cared about way back in ancient China. This is one of my favorites. So this is a character for woman or female, ni, and I guess it kind of looks like this, she's curtsying or something. So super interesting character if you grow up, writing your characters, So this is a woman underneath a roof, and you're oh, that might mean wife or family or something, but it actually doesn't. It means peace. So the idea is things are at peace when the woman is under a roof, which I always thought I felt like kind of weird about that growing up. Another one is, okay, there's a woman, and then you have a child, or boy child specifically. So you're like, oh, that might mean family or mother or something, but actually it means good. So the standard for good in ancient China was a woman with a boy child, which I thought was also, as a 6-year-old I found problematic as well. And all kinds of interesting things in Chinese use the female radical. So 3 women together means evil. This one means greedy. This one means slave. This one means jealous. This one means betrayal or adultery, which I think is interesting. So in case you want to bring this to your favorite 10-year-old, we have a Chinese, an emoji kids book coming out from MIT Press in the fall called Hanmoji. So it's from MIT Teen Press. It's super fun. So it's a lot of these concepts, but a little bit more rigorous. And this idea of gender in emoji was really important to a bunch of us as we were kind of working through the issues. So for a long time, on the emoji keyboard, there are all kinds of jobs you could have as a man. You could be a police officer, you could be a detective, you could be a Buckingham Palace guard, you could even be Santa, you could be Black Santa, right? But as of 2015, if you're a woman, there are only 4 jobs you could have on the emoji keyboard. So you could be a princess, you could be a bride, you could be a dancer, or you could be a Playboy bunny. So those are your 4 choices. And so we worked really hard on trying to diversify what women could be. And one of the ways we did it was through this idea of combining emoji. So in emoji land, there's something called Zwidge, a zero-wit joiner. And a lot of emoji that you see are actually glued together. So the rainbow plus flag is how you get rainbow flag. And this is actually how we worked on introducing a bunch of the occupations in emoji land. So a lot of these are the chef is a woman plus the frying pan, or a teacher is a woman plus, or a man actually, plus a school. And so one of the interesting things is you can actually have, as a result of all the gender parity stuff, we actually had to make male and female versions of all the emoji, because some of them originally were passed as man in tuxedo. And now, because we had gendered versions of everything, we now have woman with tuxedo. I don't know if you noticed, there's also man in a wedding dress to kind of complement the woman in a wedding dress. There's now actually also bearded woman. I don't know if you've noticed that. So it gets interesting, because originally at a certain point we had passed women breastfeeding. And then there was all of this complaints coming into Unicode about, what about men as caretakers? You can't actually tell she's breastfeeding. It's more just she's holding it. So people were like, what about the man as a caretaker? Paternity leave and da-da-da-da-da. So there is now man kind of nursing the child. And the other kind of ways you can combine the emoji are through skin tones. So unfortunately, those are not through Zwidges. This is through an older kind of technology where you have all the skin tones are basically the yellow character plus a little square box at the end. We call them skin tone modifiers. And in terms of one of the things that we worked on at Emoji Nation, which was one of the hardest ones, was to create the interracial couples. And we worked on that with Tinder, which really cared about it because apparently, which I thought was interesting, when you introduce online dating into a community, the rates of interracial marriage go up. And there's a pretty interesting academic paper that kind of systematically looks at the rollout through different countries and different communities. So it was really nice to see it introduced on the phone. One of my friends cried. In terms of Emoji Nation emoji, we've worked on a lot. So these are just a sampling of the ones that we've done. I really liked, let's see, DNA, I feel really good about. Lobster on behalf of people from Maine. Yarn and thread for all the people who like knitting. There was bagel emoji on behalf of all New Yorkers. This emoji actually, which we called microbe, was very sleepy on the keyboard until 2020, and it really had its moment. I'm really kind of proud of that one. And There is Yoga Emoji Sponge. So these are just a sampling of the ones that we worked on. And this is a sampling of the people who have contributed. You too, if you feel really passionate about emoji, could like impact billions of keyboards worldwide. So it's interesting to see in terms of frequency of use. It's very power law, right? So here sort of, these are actually like order of magnitude. Like, so 1 is half of this, 2 is half of 1, all the way down. And one of the most stunning things I was surprised to see is that face of tears of joy by itself is like almost 10% of all emoji sent. 9.9% of emoji is just that one character. Number 2 is red heart, which I guess you guys can see in its binary form. And then it falls off like pretty quickly. So I know I'm hearing that face of tears of joy is very boomer or very Gen X, and that it's maybe among you guys it's a little bit kind of blasé or déclassé at this point. So the future emoji, we really don't, Unicode does not want to be encoding emoji. And along the way I became a vice chair of the Unicode emoji subcommittee, so I went from like kind of shaking my fists at the institution to becoming part of the institution. So there's one idea, this coded hashes of arbitrary images. Can we create a system where instead of just using a binary code to represent all different emoji, we actually can do specific images. We create hashes, and then like you look, and you can look up like by the hash which image you're looking at. So that was the idea. This is from a Stanford professor. Didn't really get takeoff. Then there was this idea using Wikipedia or Wikimedia, the Wikidata QID numbers, which I didn't know this until this proposal came along, but everything in Wikipedia has a number, and that allows it to sort of match things between different languages. So in Chinese, the page for Obama is matched with the English page, with this Arabic page, and that went nowhere. So what I'm going to finish with is telling you what the new emoji are. You guys are among the first people to hear about this because no one's really been paying attention. So this was published a couple of weeks ago, but like it made no news because you have to be looking at the Unicode register. So first off, more hearts, because you guys all love hearts. So there's light blue heart, gray heart, and pink heart. There was kind of debate, do we need more pink hearts? The answer seems to be yes. Light blue is really interesting because in some cultures, light blue and dark blue are different colors. In our culture, we just call them like versions of blue. It's sort of like how in English, pink and red are different colors, but in some cultures, there isn't a difference between pink and red. And then there were a bunch of bird things. The wing emoji is coming, blackbird and goose. I don't really know why. Hyacinth as a flower. This has like very popular in Iranian culture. Jellyfish, I don't know, I'm very suspicious of jellyfish because they used man o' war as one of their like phrases that they searched for, and that had 1 billion. I think like it had a lot of entries, and I feel like those were not about the actual invertebrate. Like there was something else going on there, but kind of wrote in on that. Moose on behalf of the Canadians, donkey on behalf of I guess the Democrats. So that was interesting because like you had to have the donkey look different from a horse, and there was a whole debate like, do you want a donkey head or do you want a donkey body? Do you want donkey with floppy ears? Do you want like all kinds of donkey debate? And it was actually originally proposed in 2019 and just got in this year. Ginger and pea pod. These are kind of weird, like the food things kind of got in a weird way. Ginger was good because it also represented root. And then wireless got in, which is interesting because we couldn't use the phrase Wi-Fi because that's actually trademarked by like the Wi-Fi people. And then on behalf of Sikhs, Khanda finally got in. It was the largest religion that wasn't already represented on the emoji keyboard. And then on behalf of like the faces, shaking face. So I'm glad you guys are really excited by that. It is unclear to me, like, I was not a big proponent of this, but your excitement about it makes me change my mind. Then folding hand fan. I actually find that one interesting because I think it was just like college students or fresh out of college students who were like, we want to do a proposal that passes. And they were very opportunistic and just sort of like chose fan. And then first they submitted electric fan, and then we told them like, oh, the longevity for electric fan isn't great, even though it's been around for a couple hundred years. Why don't we go with the folding hand fan, which is a much longer history? And then this one is actually a big deal, is Afro hair pick on behalf. There was a lot of controversy about and debate about curly hair, and it's supposed to represent afros, and then Apple did not do that. So everyone else has very afro-looking hair. Apple just makes it look wavy. And so there was like upsetness that like black hair wasn't represented in emoji set. And so this was a proposal that someone worked on. And then instruments, maracas and flute. And that's it. So in terms of, if you have any questions, you can look at emojination.org. You can email me for all things emoji, Jenny@emojination.org. And remember, you guys can actually impact billions of keyboards around the world. I mean, it's a little bit of impact per humans, but billions, so it adds up to a lot. And if you have any more questions, I'm here and can give lots of answers and questions. And I'm really thrilled actually to kind of bring the emoji flag waving to such a large crowd, and especially a large, diverse and very motivated crowd. And one of the interesting things is we've kind of like, I'm not a proponent of this, but they've slowly decreased the number of emoji per year. It was like 70, then it was 50, then it was 30, and this year we only did 20. And I'm a little bit sad about that, but I hope that if there's more excited proposals that can be submitted to Unicode, we might be able to dial that number back up. So that is me. Am I good? Yay. So thank you.
This is about 20 years late, but thank you so much, Jenny. We have an I Took CS50 t-shirt for you. On the way out, too, we have some CS50 stress balls for you. Cannot wait to see your final projects coming up if you'd like to chat with Jenny. This was CS50. See you soon. right, this is CS50, and this is first year family weekend here at Harvard. So welcome to all of the moms and dads, brothers, sisters, cousins, aunts, uncles, grandparents, and beyond. CS50 here is Harvard University's introduction to the intellectual enterprises of computer science and the art of programming. And what that means is that what we've been doing in here over the past several weeks is introducing students to computational thinking, the process of cleaning up one's thoughts and expressing oneself all the more correctly, all the more precisely, and ultimately translating those thoughts, of course, to a computer in the form of programming, which is where we've spent quite a bit of time programming, writing code over the past several weeks. But toward that end, we've also been equipping students with some basic building blocks. You might already know, if a parent, that computers only somehow speak zeros and ones, even if you're not necessarily a computer person yourself or know what that means. But with those zeros and and ones can represent numbers and letters and colors and videos and more. And in fact, your child, perhaps sitting next to you, can perhaps tell you what today's message says. Here we have 64 light bulbs on stage, and if you look at 8 of them at a time, there's a pattern of bulbs that are either on or off that if you know the code, so to speak, can you actually convert these bits, these zeros and ones in light bulb form to today's particular message. Now, before we begin, we thought we'd make this as engaging, as interactive as possible. Rather than focus on any assumptions of prior computing knowledge, you need know nothing today other than how to operate, for instance, your own phone or a laptop or desktop or the like. And indeed, we'll assume a general audience. And in this Halloween week, we also see if we can't scare you a little bit into practicing better practices when it comes specifically to the security or cybersecurity of the device you carry with you every day in your pocket, use on your desk, on your laptop, or beyond. So if you haven't already, whether you're here in person or tuning in online, go to this URL here, which will lead you to an interactive polling tool. Any phone or laptop or desktop suffices. If it's a little easier than typing in this URL, you can just scan this code with your phone's camera. Take a moment to just open your camera, and hopefully if you're at a good enough angle and we've made this thing big enough, this is a 2-dimensional barcode or QR code embedded in which is that exact same URL. We're increasingly seeing this throughout the world as a mechanism for doing what many of you are doing right now, linking the physical world to the virtual. But that URL, again, is simply this one here. And in a moment, you'll see on your screen, it's OK if you weren't quite able to get that working. Feel free to glance to the left or to the right of you for someone else who did. Let me go ahead and full screen a question just to ask of everyone here as we focus today on cybersecurity. Is your phone secure? Whether an Android phone, an iPhone, or anything else, if you're holding it in your hand right now, here in person or online, you should see 3 possible answers, yes or no or unsure. We've got over 300 responses come in already. In a moment, I'll flip over and reveal the results and see if we can't see how much work we have to do together here today. A few more seconds, almost up to 400 answers. Almost up to 400. It's OK if those keep coming in. I'm going to toggle back and show the results in just a moment here. And the results are now in. According to a response rate of over 400, it looks like 36% of you don't need what we're about to do here today, which is great. We'll see if we can't poke some holes, though, and maybe some assumptions you all are making. 31%, 32% maybe of you are a little are saying, no, your phone is not secure. So glad you came. And then understandably to another third of you are unsure. So in very good company today. And we'll see if we can't open the eyes of everyone in each of these disparate audiences. Well, let's consider first for a moment exactly how we might think about the security of our phones, representative of just any computing device. And in fact, everything we discussed today could be extrapolated to laptops and desktops and servers. But all of us being so familiar with phones, let's start with phones themselves. Now, odds are you have on your phone, like so many other things in your life, a password or a passcode. And in fact, without raising your hands and therefore leaking information, think to yourself, well, what is my password or passcode? It's probably 4 digits. It's maybe 4 letters. Maybe it's even longer. Maybe it's even nothing. And I think maybe from the chart earlier, we can assume that we have a third of each of those possible responses. So a password, of course, is this super common mechanism that you and I are all using all the time to keep our devices secure. But do passwords keep things secure? Like, how many of you thinking about your phone right now and that specific password might think it's secure? And if so, why do you think it's secure? We have at least 33% of you are ready to say that your password's secure. Don't want to know it, but why might it be, in your mind, secure? Why might you think it's secure? Or more generally, what makes your password secure? It's random. OK, so it's random. So random letters and numbers and the like. And that's great because it's not just a word in the dictionary that someone could guess and type in. Downside, of course, I dare say, is that it might take you, as well as anyone else, quite a bit of time to guess or figure out what, or just to remember what it is if it was indeed random. But randomness is going to be a primitive that really actually helps us. Unfortunately, you and I and really the whole world are not very good even at passwords, as omnipresent as they are as a defense against adversaries. In fact, if we look at the most common passwords from the past year in 2020. Thought we'd share with you some of those results. This is the result of security researchers having found big exploited, compromised databases, analyzing them for what passwords are in them, and then inferring from that what the most common passwords you and I are all using. Unfortunately, in 2020, the most common password, according to one measure, was 1, 2, 3, 4, 5, 6. Now, funny, yes, but if you're seeing your password on the screen already, not so funny, perhaps. The number 2 password was not much better. Number 3, picture 1, presumably for a device, a website that requires that it not just be a word, it have at least one number, which this person took these hundreds of thousands of people took literally. Password was number 4 this past year. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 1, 1, 1, 1, really not trying hard there. 1, 2, 3, 1, 2, 3, varying it a little bit. 1, 2, 3, 4, 5 was number 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 was number 9. And then number 10 in 2020 was senha, which, any Portuguese speakers here, means password, means password. So made the list twice in this case. So one takeaway already today should be if your password's on this list, like, probably you're in one of those other 33% whereby we can do better than this. Why? I mean, really the obvious. If you're in this list, there's so many bad guys, so to speak, out there that are going to try guessing your password first. Why? Because just statistically, if they try 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, they're just going to get into a lot of devices quickly because they're just so commonly used, those passwords. You don't want to be on this list. Ideally, you want to be random, but we want to somehow balance randomness with memorability so that you don't actually keep forgetting your password, which of course defeats the whole point of these things in the first place. But in a class like this, CS50, and computer science more generally, let's be a little more thoughtful as to what we mean by a device being secure. Like, what does it mean to be secure? And can we even slap some numbers on it so that we can make measurements, so that we can ideally compare and contrast one system versus another, one password versus another. So it's not just our instincts arguing that my password is better than these, but how can you quantify that perhaps? Well, let's start simply. A lot of Android phones and iPhones these days require minimally that you have like a 4-digit passcode. You're minimally encouraged to have at least this bar set so that you're not having no passcode altogether. So if you do have a 4-digit passcode, well, let me go ahead and ask this question. How much time might it take to go about cracking, so to speak, that is figuring out what a 4-digit passcode is? In fact, let me go ahead. If you want to pull up your devices again, you should see on the screen this question now. How long might it take to crack, that is figure out, guess, a 4-digit passcode, for instance, on someone's phone? A few seconds, a few minutes, a few hours, a few days. Thinking here from the adversarial perspective, if someone got a hold of your phone somehow, how long do they need to get into your phone if it has a 4-digit passcode? A few seconds, few minutes, few hours, few days. Got about 300 responses so far. Let's give folks another few seconds here. Another few seconds here. All right, up to 350 or so. In a moment, let me go ahead and flip screens over to the results. So we'll see the preliminary results here. And if I now pull this screen up, we see that 50% of you claim that it's going to take only a few seconds. Few of you say, about a few fewer of you are saying that it takes a few minutes, a few hours, and even a few days. Well, let's answer that first, because honestly, if it's already a few days or even longer, our work is here probably already pretty done. Unfortunately, the problem with things like 4-digit passcodes is that anyone who grabs your phone, you step out of the room, you leave it behind, you lose it, they could certainly mimic your input device and just use their finger pretending to be you, trying 0000, nope, 0001, nope, 0002, nope. And it's a little slow, to be fair. It would take me a while to count all the way up to 9,999. That's 10,000 total possibilities there. But let's go ahead and consider exactly how else you could do it. For instance, here is an example of, in computer science, what we call a brute force attack. And just an adversary using their finger is a brute force attack if they're trying all possible passcodes. The problem is, even if your passcode is way at the end of the list of numbers, eventually they're going to get it by brute force. Sort of like in yesteryear using a battering ram or the like to brute force your way into a building, a castle or the like. In software sense, it just means trying all possibilities. And you don't even have to just use your finger, right? Anyone with some programming savvy who's good with hardware could maybe do something like this. Here's a quick video I'll hit play on. No sound, but a little bit of a robot that has an Android phone underneath it, and it's got a little robotic finger that's doing the work for you. You can step out of the room now as the adversary, let the robot do its work, trying 0000 through 9999, and ultimately, presumably, get into that phone. So let's see if we can't quantify then exactly how fast the human or the robot could get in. Well, how many total possibilities are there? That's the right way to begin thinking about it. If you have 10 digits for the first one, 0 through 9, and then another 10 possibilities, another 10, another 10, the total number of possibilities, of course, between 0000 and 9999 is 10,000. 10 times 10 times 10 times 10, which gives us that much of a search space, a universe of possible passcodes to choose among. Unfortunately, you can do even better than your own finger or even that robot. Anyone in CS50 now who knows a bit of programming in languages called C or Python or anything else could open up a programming window and actually just start writing some code. And so let me do that. What you're seeing here, if a family member, is a programming environment called Visual Studio Code that students have been using for the past several weeks. Up here, we have a tabbed window where we can type our code. Down here, we have what's called a terminal window where I can type commands to make the computer run that code. And then over here is just a menu bar. So crack.py means I'm going to write a program to crack, that is, figure out passwords using this language called Python. And even though most CS50 students wouldn't know what code to start writing, they'd have to look up some of what I'm about to do. It's only going to be a few lines. So I'm going to go up here and say, from string import digits. This is a fancy way of saying, hey, Python, give me access to all decimal digits. It just avoids my having to type out 0 through 9 manually. All right, then I'm going to say from iter tools, import product. This is another feature of Python that CS50 students, for the most part, have not yet seen, that just says, hey, Python, give me the ability to do like the cross product of a whole bunch of numbers. So these 10 times these 10 times these 10 times these 10. And then what am I going to do with that? Well, for each possible passcode in the product of those digits repeated 4 times, I'm going to go ahead and, for now, let's just print out what the passcode is. In other words, assume that I am now the adversary. I don't want to waste time using my finger. I don't have a robot that I made. But I am good at writing software. And heck, I've got like a USB or a lightning cable in my bag that I could connect your phone to, my Mac or PC. And I could just have my code that I'm writing now send all the possible codes from laptop to phone to automate this process just using the little port at the bottom of all of our phones. Well, let me go ahead and maximize this so-called terminal window, which is, again, where I'm going to run this code. And again, the question a moment ago was, does it take seconds, minutes, hours, days? Well, let me go ahead and run Python of crack.py. I'm pretending for the moment that I did grab that cable from my bag and plug it into the phone, hitting enter, and it didn't actually do anything. That was not supposed to happen. So in CS50, we spend a lot of time introducing students to bugs, which are mistakes in programs, sometimes not so deliberate. Let me go ahead and apologize. Let me open this file. This didn't technically happen. OK, Python. There we go. OK. In CS50, we now will run the code here. And I'm going to go ahead and run a command called python of crack.py. I had the file in the wrong location a moment ago. And this is the equivalent on a Mac or PC of double-clicking an icon. Here we go. Is it seconds, minutes, hours, or days? Barely 1 second to try all 10,000 possibilities. You can't even see them all on the screen, but this printed out 0000 all the way down, of course, to 9999. Plug in that cable, and boom, the adversary doesn't need to be in that room for very long in order to get into that phone. All right, so what would be better then? Like, clearly, 4-digit passcodes, bad. If you have someone in your life who has a finger or a robot or the ability to write code, and unfortunately, because of us, you now all have someone in the family with at least a third of those, how might we do better than this? What's better than a 4-digit passcode? Anyone? Yeah. OK, so 6 digits, heck, or 7 digits, or 8 digits. Why? Because that's going to make, of course, the passcode longer, which means we're going to have to try more possibilities, which doesn't mean that the adversary is fundamentally stopped. but it is going to slow them down. It's going to take them more time, probabilistically, to get to your passcode. And it, in a sense, then increases the cost to the adversary. And indeed, that's the theme in cybersecurity, raising the cost to the adversary, either financially or time-wise or the like. Just like in the real physical world. Most of you go home, you lock your doors at night. You might have invested in a better deadbolt than another. Why is that? You really just want to be more secure than the house next door. You want to make sure that it takes too much time, too much effort, too much risk to the adversary to get into your home. And that's, again, what cybersecurity is all about. To say my phone is secure is sort of nonsensical. To say that your phone is more secure than someone else's, that's really a reasonable, fair statement to make. So I like this instinct. Let's see if we can't make things a little harder. And actually, let's go one step further. Rather than just numbers, you've probably noticed on your phones, you can use letters of the alphabet too. If you click the right option on the phone, you can start typing in words and letters. So how might we do that instead? Well, let's transition to 4-letter passcodes. 4-letter passcodes. And if we do 4-letter passcodes, where the letters of the alphabet, for instance, are A through Z in English alone, let's go ahead and ask this question here. If you have 4 letters of the alphabet, so let's not increase length yet. Let's just change to a bigger vocabulary. Now we have A through Z instead of 0 through 9. How many 4-letter passcodes are possible? How big is that universe that the adversary is going to have to search via brute force? So I'm seeing a lot of 7 millions, a bunch of 52,000s, 26,000s, 10,000s, 9999, a few smaller numbers here. Hopefully it's not this low, right? Because we've already set the bar at 10,000 possibilities for numbers alone. Hopefully if we've got English letters, A through Z, we can at least do better than 10,000. So I think we'll start to see maybe some of these bars change a little bit. But we've got 60% of you proposing 7 million. Well, let's go to the math. So here we might have a way of thinking about this, both uppercase and lowercase. Even better if you consider it that way. Lowercase A through Z, uppercase A through Z. That's 52 possibilities for the first digit, times 52, times 52, times 52, or 52 to the 4th power. That indeed gives you 7 million plus possibilities. All right, well, let's now translate this to code. That already sounds way better. 10,000 versus 7 million. This is definitely going to slow that hacker down. Well, let's consider exactly how fast or slow it might now be. Let me go into my crack.py program, and let me make a little tweak so that instead of just using digits, this time I'm going to use letters, otherwise known as ASCII letters, as CS50 students will know. That just means familiar English letters of the alphabet. And I'm going to change my code to use these ASCII letters, 4 of them still, instead of digits alone. And that's the only change. Now I'm going to pretend to plug my phone that I just stole from someone into a USB or a lightning cable. Let me maximize my window just so we can see things a bit more. Let me run Python of crack.py now. And let's consider how long it takes to do 7 million possible codes. OK, slower. Slower. Can't dramatically just say in one breath that we're done. But we're already at the G's and then the H's. And it's kind of flying by. You know, this is where the adversary is probably getting nervous in the TV show or movie, right? Someone is tiptoeing around in the other room. You don't want them to come in. You only have this much time to crack the code. And we're at the R's, the S's, the T's, U's, V's. So, you know, this feels like, what, a minute or so? It's a good number of seconds, but it's still pretty brief. Certainly if someone has the ability to, now we got to do the capital letters too. Certainly if someone has the ability not to just secretly do it like in Hollywood in the next room, but just take it with them and do it over the course of a minute or two at home, this seems to be faster. This seems to be slower because we're trying so many more possibilities. But you know, if the adversary takes your phone, has it long enough, this doesn't feel like terribly long. So what might be better than this? Let's take it one step further. What might be better than 4 letters? What do most websites ask you to add to the mix? So special characters, right? And those things are darn annoying, right? Because sometimes they even tell you what letters, punctuation symbols you have to use, and then you type one and you realize, it's not on the damn list. I mean, it's frustrating. Why? Well, it's going to raise the bar, though, to the adversary. And that's indeed going to be the goal here, again, just to increase the cost or time required for the adversary so that it doesn't finish like it did just now after a couple of minutes, but it's going to keep going and going, hopefully, such that they're going to lose interest in your phone and go try to crack into someone else's, presumably. So let's try this. Let me now go over to how about one other question here? And this question will now just be, let's go from 4 characters. How about let's take it one step further and mix the 2 ideas here. More digits and longer passcodes. how many 8-character passcodes are possible? And by character, as a CS50 student will know, I mean number or letter or punctuation symbol now. And there's like 32 or so standard punctuation symbols. So we're up to a good set of numbers now. How many 8-character passcodes do you think are possible? Million, billion, trillion, quadrillion, or quintillion? All of which, of course, are better than 10,000 possibilities. So we're in a whole different space now. Looks like these answers are coming in a little more slowly, perhaps as folks think about this. This is 10 digits plus 52 letters plus 32 punctuation symbols. Much more secure, it would seem. All right, we're up to 230 responses. Give folks another second or so. If you're trying to do the math, 10 plus 52 plus 32, that's going to give you 94 possibilities for each of the digits. All right, we're just about at our 350. All right, I'm going to toggle over the screen here. Going to click over to the results, show them in just a second on the screen now. And this is an interesting distribution. I think some of you perhaps have the instinct now of just go for the biggest one. It's not quintillion, nice as that would be. Maybe it's quadrillion, trillion, billion, or million. We have more of a split there. So let's consider the math. So if we've got 8 characters, and I claim that that's 94 possibilities for each, 10 digits, 52 letters, 32 punctuation symbols, that's 94 to the 8th power, essentially. And that indeed is 6 quadrillion possibilities. Now, that's crazy big at this point. I dare say we're pretty safe from the human finger now. We're probably pretty safe from that robot, which is going to take a while too. But Macs and PCs are pretty darn fast. And God forbid the adversary have a big server or use the cloud, so to speak, and really use a big, expensive machine. How long does it take to get into 6 quadrillion possible passcodes? Well, how might we think about this? Suppose, just for the sake of discussion, it takes the adversary 1 second per code, just so we have some unit of measure to start with. 1 second per code, which means in the worst case, the adversary really gets screwed. And my passcode is like 9999999, or with a lot of crazy punctuation symbols in it. If each passcode takes a second to guess, how long is it going to take the adversary? If in the worst case, they spend 6 quadrillion seconds. How many hours or minutes or days or years? I'm hearing a lot. A lot is, in fact, correct. I did do the math. The adversary, if they're lucky and get all this way, they're going to be 193,000 years old by the time they get to all of those possible passcodes. So this sounds alluring. And in fact, let's just change our code one final time just to get a sense of how this might look and behave. In this version here, let me go back into my code. And let me change this now to use not just ASCII letters, but digits. And I'm going to add in punctuation. For CS50 students, there is, again, this library called the string library that lets you just import all of these symbols automatically, so we don't have to type out every character on my keyboard manually. And then down here, I'm going to take the product of those ASCII letters again, plus those digits, plus the punctuation, repeated 8 times, I claim this time. I'm going to now increase the size of my window just so we can see more on the screen, rerun the code. And this is going to take us, some hundreds of thousands of years. So we won't run to the end of this demo. Now we seem to be in a better place. All right, so what's the takeaway here? Clearly, you should use a passcode, a password that's 8 characters with letters and numbers and punctuation. Yes? OK, so, there's a mix here. Some of you are saying yes, someone no. How about someone who says no? Why? Why no? Yeah. Recaptcha. OK, so there's other mechanisms. More on that in a second. Other instincts? Yeah.
Like the computers are much faster than just 1 code per second.
Yes, I'm kind of cheating with my verbal simplification here. Even this computer is way faster than 1 code per second. So it's not going to be hundreds of thousands of years. It might be tens of thousands of years or hundreds of years. But it's not going to be quite as dramatic as this. So that's a concern. Yes, so maybe there's other mechanisms. So maybe we don't have to be so extreme as to introduce all of this randomness as was proposed before. Because honestly, there's this theme in computer science too, and really information technology of trade-offs, right? Sure, I can use a really big random password. But my God, I'm going to end up writing it on my monitor on a Post-it note, which I suspect statistically some of you are guilty of, right? And you shouldn't necessarily just blame yourself or your colleague who's doing this. Like, this is a symptom, perhaps, of bad IT policy. If we don't have necessarily very usable systems, maybe we shouldn't blame the human for forgetting their very random password. Maybe we shouldn't require the human to have a very random password. So what could we do? A couple of technical mechanisms were just proposed. Let's go down this road of how we might try to defend against this. And I'll keep this running just for fun in the background. Let me switch back over to a visual here. Now that we've considered that many codes, what if we do something that some of your own phones already have that slow the adversary down? And some of you might have seen on your iPhone a screen like this. Let me zoom in. iPhone is disabled. Try again in 1 minute. Has anyone locked themselves out of their phone like this? I have. This is not, I mean, it's embarrassing to admit, but it's not leaking any information. All right, so many of you have done that already. But why is this actually a compelling feature? Just to be clear. Annoying as this might be, because you probably don't want your phone locked at the very moment you're trying to get into it, why might it be a good thing? Yeah, let's go somewhere else if we may. Yeah, and back. Sorry? It slows down the process. It annoys you, to be fair. Like, you pay a bit of this price, but it really slows down the adversary. Now they're going to be able to type in not 1 code per second, but 1 code per minute, a 60 times difference. That's really going to force them to pump the brakes. And unless that adversary is after you specifically, odds are they're going to go take someone else's phone or lose interest because you've raised the bar high enough to their getting in. On Android, if you do this, it depends on the operating system version. Here might be something similar on Android. Too many attempts, try again later. I mean, this is even more annoying. It doesn't even tell you when to try again later. But it does slow down the adversary. So if you don't have features like this enabled, you should. And if you're particularly security conscious or paranoid even, you can even enable a feature on these phones nowadays where they self-destruct, so to speak, after 10 wrong guesses. Right? Why 10? The presumption is among Apple and Google and others that if you type your passcode 10 times wrong, you're probably not who you say you are. You're probably someone else. Although, if you're a little groggy first thing in the morning, or if you've been out late and having a good time, 10 might not be a high enough threshold to sort of protect your phone from you. And so there, too, is this trade-off again. And that's an extreme one. If your phone deletes itself, which is what I meant by self-destruct, then that might actually be to your detriment, unless you have backups and all of that. But that's another technology question altogether. So there, too, this theme of trade-offs. You raise the bar to the adversary, but you've got to pay the price. You're not going to get any such feature for free. All right, what's another mechanism that many of us increasingly, thankfully, are doing might be when you log into a website like Gmail to have two-factor authentication, sometimes called two-step authentication. I mean, how many of you use two-factor or two-step authentication with at least one account? All right, so that's amazing. How many of you use it with all of your accounts? All right, fewer of us. And there, too, that's not necessarily the wrong answer, right? I have a lot of stupid websites that I have accounts on, like I bought something once on them. I don't really care about it. So there's a judgment call there in terms of what you really care about. But maybe your financial websites, your healthcare websites, or anything that's mildly sensitive to you probably should be raising the bar to the adversary by enabling this. So what is this? Particularly for those of you who didn't raise your hand, someone else, what is two-factor or two-step authentication? What's two-factor? Yeah.
When you have to use your phone to verify that it's really you.
Yeah, so when you have to pull out your phone and verify that it's really you, or in the corporate world, you might have a little dongle, a key fob on your keychain that's got a little number on it. But generally speaking, two-factor authentication is all about, indeed, a second factor. It's kind of oversimplified as 2 steps, but it's really key technologically that it be a different factor. It is not two-factor authentication if you just have 2 passwords that you have to remember, because both of those could be forgotten by you. Both of those could be stolen by someone else if you write them down, the Post-it note or the like. Two-factor authentication is about having a fundamentally different factor available to you so that the odds that someone get at something you know, like your password, and something you have, like your phone, is just much, much smaller than the threat of just figuring out something you know, like a password alone. So the factor is something that's fundamentally different from the other thing. And so once you configure this, the user typically sees a screen like this. For instance, in the context of Gmail, the screens vary. Here at Harvard and Yale, students are familiar with something called Duo Mobile, which is the exact same idea. And they typically use one-time codes, 6 digits thereabouts. And you can only use that code once. And the idea is it's texted to you or pushed to your device so that you and only you can use it. Does this fundamentally secure your account? Is this enough to just have a good password and two-factor authentication. Does that keep the adversaries out altogether? Not if someone, what? OK, not if someone really wants to get in. Then you have other problems that are certainly of concern. But you do want to ideally keep most adversaries at bay. And there, too, all we're doing is like raising the bar, right? There's nothing stopping someone in physical proximity to me stealing my phone and getting into all of those accounts I just raised my hand about. But you at least protect yourself against the billions of other potential adversaries in the world that are geographically not near us. So you at least narrow the threat. So that's a good thing. But what else could we do? Because I feel like it's not fair for us to say, all right, everyone go home, start using better passwords, longer, more complicated. Because again, there's this trade-off. We don't want to send everyone home essentially with a pad of Post-it notes to then counterbalance what's an unrealistic expectation. So how many of you, perhaps with a show of physical hands, use a password manager already? This is something practical we can equip you with. OK, so that was relatively few hands. And those of you who are in the habit still of memorizing your password, or worse, writing down the password, there are better solutions today. But here, too, there's going to be a caveat. There's no clear win necessarily. A password manager is a piece of software that you install on your Mac or PC or your phone that manages your passwords for you. And these come either built into the operating system. Windows has Credential Manager. Mac OS has something called Keychain. There's third-party software like 1Password or LastPass. Companies and universities often have site licenses so that students in particular can use these kinds of things for free. But the ones that come with your operating system or phone are themselves already free. And not using them is really the missed opportunity here. So what is a password manager? It's a program that, yes, manages your passwords, but it does a few things more. It generates passwords for you, typically. I mean, honestly, it's been years since I have chosen my own password on a website. I instead click a button in my password manager software, or I use a keyboard shortcut to generate something that's 8 characters, heck, maybe 16, 24, 32 characters long. I don't care, because the software's job is to manage that password for me. That is, the software remembers this crazy long password for me. And better yet, it comes with a button or a keyboard shortcut that will automatically fill out forms for me on the web. When I say log me in, it will grab my password from my computer, plug it in, and voila, I'm logged in. The upside of this is that even if that website is compromised and my password leaks out, I'm not using that password presumably anywhere else, because the software's job is generally to create unique passwords for each website. And it's not going to be guessed via brute force by one of you writing code, because it's just too long. Probabilistically, we're all going to be gone by the time your computer finishes trying to crack it. So what's the downside? I mean, this sounds great. If the software generates passcodes for you and plugs them in for you, where's the downside? Anyone? Yeah.
If you're using somebody else's computer and need to access it and you don't know the password.
Yeah, if you use someone else's computer, or you're in like a library environment, a lab environment, you don't have your passwords accessible. Now, there's a way to mitigate that, so long as you sync the same software to your phone. You might have to pay another $1.99 or $20 to have the same software on your phone. You can at least mitigate that by sharing the passcodes across your devices. Not as user-friendly. You're still going to have to now manually type out this really long password. And that, too, is annoying if you get one character wrong. But that's one way to mitigate that. Other concerns? That's maybe the biggest threats. I mean, you're kind of putting all of your proverbial eggs in the same basket. If someone now gets into my password manager, which I should stipulate is supposed to itself have a really big, long password that I do have to remember, but only one such long password, I mean, then I'm really out of luck. Now, every single account I own is compromised, except for those that at least have two-factor, unless the adversary also steals my phone or my key fob. Other concerns? Exactly. If someone gets physical access to your device, honestly, in general, all bets are off. And this is why some of today's lessons are really important. It's only going to matter when you first lose your phone, or someone walks off with your laptop, or the like. There are certain things you can do to defend against that inevitability, dare say. But you want to make sure that if you are using some of these solutions, like a password manager, that long primary password you use for it is itself really hard to guess. And I would say, I'm OK with you writing that down even, but putting it in like a safe deposit box, or hiding it somewhere in the house that's just very low probability of someone finding. Because the other problem with putting all of your eggs in one basket, if you forget your password. Then you lose everything. And that, too, seems like a pretty serious price to pay. But this is a constant battle in computing nowadays, usability and security and finding that inflection point. But there, too, you can be selective, right? I called out financial information, health information, your personal email, your calendar, anything that's mildly more sensitive to you or important. Raise the bar at least on those accounts, even if you're not quite ready to go all in on all of these other factors. Well, let's consider then where we're using these passwords. Consider just a couple of specific examples. Email, of course. Gmail is the example I used earlier. Gmail and email accounts more generally are increasingly offering us features. And in fact, there's one that I thought we could highlight as an example of something that, as a CS50 student, a CS50 family member, you should really start viewing the eye a little more, the world with a more skeptical eye, a little more paranoid eye, and not necessarily just believe things that websites say. I mean, it's mostly meaningless when a website says, sometimes with a pretty little logo or emblem, our website is secure. Like, what does that even mean? And it's, again, all about relativity. And even Gmail, I dare say somewhat irresponsibly, has this feature in recent years, confidential mode. Like, is anyone, if you're using G Suite or Google Apps at work or Workspace nowadays, in the habit of using confidential mode? I mean, it sounds, OK, no one's using this, so this is great. And I worry now that I'm introducing you to a feature that you shouldn't necessarily use. But all this time, if you're a Gmail user, there is along the little menu bar an icon that lets you enable confidential mode. And later tonight, play around for it. Just look for it, and you'll see exactly the screenshot which I took yesterday. According to Google, recipients won't have the option to forward, copy, print, or download this email. Right? Great for lawyers, it would seem. Great for business. Great for private correspondence. But why is this perhaps a bit misleading? Like, where should the skepticism come from here? Even a company like Google, I dare say, they've probably buried the caveats that I'm hinting at under the learn more. But unfortunately, that might be too late. Yeah, in back. Yeah, I mean, those of you who know how to take a screenshot, that's the simplest way. If you don't know how to do that, well, here's a phone. I can just take a picture of what it is I see on the screen. And so these are software defenses that are in place that essentially disable the forward button, disable the print button. But honestly, as you probably already know, once something is already digital, I mean, it's out there. And there are other ways to get at it. It might not be as high quality if you're taking out your phone to do it. But you should view things like this with skepticism. And even I, when I occasionally receive something like this, I kind of roll my eyes, but regret that the user thinks what they're doing is consistent with this language, but it isn't necessarily. And so indeed, in part, from an introduction to computer science, you begin to, get a little scared from what's going on out there because there's so many different threats and so many things that you can't, in fact, do. And the onus is unfortunately often on us users to read between the lines and see what actually is possible. Here's another one that you might be more in the habit of using. Incognito mode or private mode in Chrome or Safari or Firefox or Edge or the like. What does incognito mode do, if familiar? What's incognito mode? Yeah. It doesn't log locally what you're doing. Exactly. Most people here probably generally know about things called cookies, even if you're not quite sure how they work. But they're like these little remnants or breadcrumbs you leave behind when visiting websites that allow the websites to keep track of who you are in some sense. According to Google here, when you're using incognito mode, Chrome won't save your browsing history. So that's good. Cookies and site data, information entered into forms. But to their credit, they do disclaim that your activity might still be visible to the websites you visit, your employer or school, your internet service provider. So they're getting better at least helping you evaluate by giving more of the facts whether you do or don't want to do this. But this doesn't mean that the websites you're visiting indeed don't know who you are. All of our computers have unique addresses, these things called IP addresses that you might have heard about. In CS50, we'll explore these in another week's time. Your computer is constantly leaking information that could be used to infer who you were. So this is really just best left when you don't want to accidentally, on like a friend's computer or a lab computer, remain logged in, because cookies are typically used to just remember that you've logged in. So if you use a friend's computer, you use incognito mode and just close the window, boom, you're effectively logged out. But even as Google disclaims, there's other caveats there too. So what else might we keep in mind? How about, let's consider one other big one that's another thing to start looking for increasingly in order to keep yourself secure. And this one's a little more technical, encryption. And as CS50 students will know, this is something you can implement in code. And in fact, let me ask this question. What does it mean to encrypt something. Think back to PSET 2 and Caesar and the like. Let me look a little farther back. Almost any student hand should theoretically be up here. Yeah. Exactly. Encryption's all about substituting one letter for another and generally scrambling the appearance of some message up so that the recipient knows how to reverse that process and see what you actually sent. But anyone intervening in between you can't actually see the information between you. So just to impress the parents in the rooms, any students, what does this say? We're not ending here, but this was CS50. That's what it would say. But notice the scramble. Let me go back and forth, back and forth. In this message, T becomes U. H becomes I becomes J. S becomes T. This is what we called a few weeks ago in CS50 a rotational cipher, a Caesar cipher that literally does, as you described, substitutes one letter for the next, but it does so in a very predictable way. A becomes B, B becomes C, and so forth. And we also talked weeks ago that you don't have to keep it that simplistic. You can use a bigger mathematical formula to make it at least harder for some adversary to figure out. But you and I, as users these days, are constantly, thankfully, using encryption. You probably generally know that you should be hoping for, expecting this these days. Like HTTPS is a good thing. S means secure, literally. And any website that has that in its URL indicates to you that you and the website are having an encrypted, a scrambled communication, which means if you type in your password, your credit card information, anything else personally, no one between you, theoretically, points A and B, should be able to know what it is you've typed into that web page. The web page absolutely can, because they have the ability to decrypt that information, to reverse the process. But at least encryption is generally a good thing. But today, let's take that one step further and encourage you all to be looking for, expecting, if you will, as consumers increasingly in the coming years, something better than encryption alone, but end-to-end encryption. And you're starting to read about this a little bit more, but it's perhaps a little less familiar. Someone in the room who's familiar, what is end-to-end encryption? Let me give folks a moment. What is end-to-end encryption? OK, yeah.
It's where you always try to, it's when WhatsApp encrypts a message on one side and sends it where it's encrypted.
Good. So it's when an app like WhatsApp encrypts a message, but it's encrypted all the way to the other side, to the recipient, even though Facebook, in this case, owns WhatsApp, even though your message is going through Facebook or Meta's servers, they do not have, theoretically, the ability to decrypt your message, whatever chat message you've sent to a friend. They are just sending seemingly random zeros and ones all the way to the end user, who can then decrypt it. If you're an iPhone user, iMessage, for instance, does this automatically so long as your text messages are blue and not green. That means you're using iMessage, and Apple's platform that does this. But let's focus perhaps on something that's been all too familiar to most of us over this past year, Zoom. Right? Zoom actually took some flack some months ago because in their marketing literature, they were advertising end-to-end encryption. They were not implementing end-to-end encryption, at least initially. This was probably marketing gone awry, not quite understanding what end-to-end encryption means. They were using encryption. And what that meant is that if I were having a meeting with a colleague, or you were sitting in on a class with a teacher, you might have an encrypted connection, all of you, to Zoom centrally. But they had the ability early on, and still now if you leave this feature off, to decrypt that information and see and listen to, theoretically, anything going on in that meeting or that classroom. Now, technologically, there's not really a good defense against that if using that older approach. All it really is policy, or hopefully there's rules in place, there's contracts in place that say, well, yeah, that's possible, but don't do that. End-to-end encryption is a stronger guarantee for you that circumvents that risk altogether by ensuring that if you're tuning into that class or you're logging into that meeting, all of the zeros and ones are going through Zoom servers, just like Facebook's, but only the end users, only the students and teachers, only the colleague and colleague can actually decrypt and see and hear what it is that's being said. And if you're one who schedules Zoom meetings, you can actually see this. For instance, here's a screenshot I took yesterday, too, scheduling like a Zoom meeting for today. And you'll see that you can choose the day and the time, the password, haha, and also down here, the encryption level. And by default, it's typically enhanced encryption, which is stupid, like enhanced encryption. It's just encryption. And in fact, it's sort of worse encryption than the other checkbox, which is end-to-end encryption. But there's this little caveat. And here, too, consistent with this reality in computing, there's always a trade-off, right? It's not all upside and all win. Several features will be automatically disabled when using end-to-end encryption, including cloud recording and some phone stuff. I mean, that's already kind of a big loss for a class, for instance, a conference that wants to keep the sessions. But it kind of makes sense, right? If the data is encrypted between all of the end users, and therefore Zoom has no eyes into the data or ears, then it makes sense that they can't record it for you in the cloud because it's completely scrambled to them too. So a good primitive to have in place, but also something that you need to sacrifice in terms of usability. Well, let me, in our final moments here, let me flip back over to where our hacking tool is. It would seem that 8 characters is doing really well because we still got 3 A's at the beginning of this. So that might be, in fact, one takeaway. And in fact, let me flip over and propose 3 pieces of homework for everyone here. 1, use a password manager, the one that's built into your phone or your operating system, or pay a little something more for something that you might like a little better. 2, use two-factor authentication for more of your accounts. Maybe not all, but at least more of your accounts. And that's certainly a net improvement. And then 3, use not just encryption, but end-to-end encryption. And unfortunately, these features are not all quite as simple as, oh, well, let me just check the box and turn on that something that's always been available to me, because it's not always been available. And Zoom, only once they sort of got into trouble for this did they acquire some other company that implements this feature and then add it to their software. But as users, as consumers, as parents, as students, considering choosing one tool or another because of these features is really something you are empowered to do, and to not use those tools that you don't think meet some threshold of comfort for you. For more on this and computer science more generally, any of you can take CS50 online at edx.org/CS50. It's been so nice to see you. Happy to chat one-on-one, but otherwise have a wonderful day here on campus. This was CS50.